Hello, everybody who's already here. I'm spamming around. Notifications that I'm going live. Hello, Andrew. Let's see. Would be fun to set up some kind of hot reloading so you can easily view changes. You mean for the ray tracing stuff? I have no idea how it's gonna be shaped. Okay. Andrea. Oh, you did it at 2? Nice. So, well, if you happen to be around when I start doing it, so look at the countdown. I'm gonna start at 6 p.m. Our time. So if you're still around, maybe you can give me some advice when I inevitably fuck something up. Okay, so here's my plan. I have a release of Zine to make. So I'm going to make a new release of Zine because we fixed some pretty important bugs. So we should make that available on CI so that people can update their CI. Then I think there's one feature that I want to add to my new GitHub action. So code owners, code owners auto merge. There's one feature that we need to add, I think, to this bad boy. And look at it, 5 stars already. I'm famous. But jokes aside, this is something that probably most people don't need, but it's definitely a greater number than 0 people that need this, I think. This, for example, can be useful if you have, for example, a project where you don't want people to um, like merge changes at random, but maybe you have this concept where a code owner, where you give code owners, how can I say, like you assign code ownership to translators. So a translator has the ability to change their translation files independently. You don't want them to change without any, check other changes, but at least you want them to be able to change their translations independently to reduce friction. Maybe this can be a solution. I don't know. In my case, it's for Zig.day, so it's a slightly different use case, and this is a perfect match. And it's surprising that GitHub doesn't do that on its own. So in any case, there's one last feature that I want to add, and then I will be genuinely done with this for a while, at least until somebody says that they want some other feature that I find reasonable that we did not implement the first time. So this is it. But for your information, yeah, no spoilers. It's very trivial to add multi-threading before moving to a higher resolution, and it will save you a lot of time. Good to know. Good to know. Thank you. You know what? Maybe we could do something crazy. What if we did this with the async await branch of Zig? What if we did ray tracing in a weekend on the async await branch? But it's also possible that it's so trivial that it's not like you're really going to gain much that way. I don't know. We'll see. Yeah, not a lot of IO, sure. But the async await branch gives you, like, you can use async also to just offload to a thread in the pool computation, even if it doesn't do IO. Not necessary, obviously, but I don't know. But also, yeah, there's probably not a lot of that. You know what? We'll be able to. We'll see once we get there. And honestly, switching from one branch to the other is not gonna take much. So we'll be able to do that on the fly if we decided it's good to do, good to have. In the meantime, let's see how we're doing here in case that we want to come back to here. Okay. I think we can leave it this here like this. So let me see how we're gonna do this. I think I'm gonna make myself a cup of tea and then we start. Sorry, this is a slow start because since we're gonna also basically do stuff 3 hours, 4 hours from now, I'm not in a rush to do everything super fast right away. That said, in the meantime, if anybody has questions, obviously feel free to ask. We can chat about anything Zig related. I'll be right back. Okay. So here's what I want to do. Do a zine release. Is there anything else I want to add to zine before we release? No, I don't think so. So let's go do that. Oh, but I'll keep temp test open because we're gonna use it later on. Everything is fine, right? Yeah. Oh, you know what we can do? Here's what we can do that is actually interesting. I want to add this. A check that when you tag, so let me put it this way. Wait, I didn't add this in the past because it wasn't working in Zig. So here's what I want. When I'm making a release, so if we look at the build script and we look at the to release step, setup release step, the release step, I think, let me check. Yeah, the release step is only available if we are at a git tag. If we don't have a git tag, then release won't work. Let me show you. So look at the git log. The git log says that we're at main, but we don't have a like v something tag. So the last v something tag is here. So here, if I try to do zig build release, it should fail, and it does. Git tag missing, cannot make release builds. Cool. So this does that. But then here's also what I would do. I need a check that complains if we are at a release tag and the version is not up to date. So how does this work? We need to be able to basically import the zone file. So const zone equals, I think I can do this. This should work. Then I do if zone dot version is different, then so here the version is just the numbers without v. So somehow we need to access version. If b option preview, make a preview release of zine. Now this preview shit, well, whatever. Let's look at version. What's in a version? It's either commit tag or oh, tag is already a string. That's delightful. So we can do this. If zone.version, well, it's a string compare. So mem equal u8 zone version 1 dot dot. We skip the v, and then we compare that with version dot tag. And if they disagree, then we complain. I think maybe we can do it like this. Here we do the positive. Here we do the negative. Is there add fail FMT? No definition found. Come on, ZLS. That's probably me. I just need to update ZLS. Yeah. Question about having the slice child type as the first parameter of functions like std not equal. Is it still better to do this with modern sig or doing reflection checks? Andrea, this is a great question, and it actually has a very precise answer. I'm gonna make a function here. Let's say that we are implementing our own equal. So this is one style. What would the other style look like? I'm going to call it equal anyway. So there's no, or you know what, we can do equal one. So there's no type argument. There's LHS, which is any type. And then you do RHS, which you define as I guess you could do this. Type info of LHS dot pointer dot kind dot how do you even express this? Well, you know what? We can say, we can make a function for it that does all the necessary metaprogramming. So you could say slice child type of LHS. You can even do, of LHS. And then bool. To any types, return a compile error with checks in the function body. Okay, that also works. Sure, let's do this. Perfect. And then we assume that we check in the body. Okay. So, yeah. So, on one end, this is obviously a nicer signature than this one, right? This any type really doesn't convey you much. Here, you already see that it's two slices parameterized by the same type T. But there's a more important problem here. Look at this. So, expected comma. Well, okay, never mind. It's I'm gonna add a comp time block just so that it. Oh, you know what? Test. Okay. So let's say you have this. Look what happens. If you're using hello Mlug. Yeah, it has begun, but the ray tracing in a weekend starts in 3 hours and a half. So I'm waiting for our American friends before I start doing that. So if you're using equal and you have these two calls, so what are the types? Let's look at the types of these invocations. So this is going to be equal of pointer const to 2466 colon 0 u8 comma constant pointer to an array of 3 colon 0 u8. So this is what you're passing in, but because you're parameterizing over type T, sorry, there would be u8, right? So let's also do the correct call, u8. Okay, so type and then these two guys. The thing is, these types, the original type of these strings, of these string literals are these, but they get coerced to slices. And so you end up with only one generic instantiation of equal parameterized over the type u8, and then everything else is the same. So the call side, what you mentioned earlier is correct, like the call side will do coercion and cast everything always to a slice. If you're using equal 1 instead, you will create a generic instance of each of these functions for every combination of their types. And with string literals, it's a disaster. When you're not using string literals, it will be more likely that you pass around slices. So it won't be necessarily, a combinatorial explosion, but it does show you that you end up with, most probably you will end up with more than one instance of equal for bytes, just because you're not forcing coercion. So sorry, this was maybe a bit long-winded, but the point is, by passing in the type first, you can guarantee that coercion happens and not have too many instances of a function in your code, which you don't want. Like you don't want this thing to specialize over the length of these strings. Generally speaking, this is a bad idea. Maybe you do want sometimes for these to be inlined and like short comparisons. Maybe should be, everything should be super reduced. I don't know. Let the compiler decide that. But in general, you don't want to spam a ton of these things. And going a little bit bonkers, any type embodies, embeds into it generic instantiation. So it should be used with care. Yeah, especially not with slices. I feel like that slices are like the quintessential example of you definitely want this style when slices are involved. When they're not involved, then sometimes any type is fine. Okay. Let's go do our evil stuff. Let's see if ZLS recovered. Have you seen the latest banger? Did you made a PR for the web stuff? I'm going to try it out on stream on my projects if you have. Oh, there we go. Oh, you also added videos. Nice. Oh, you didn't get any reactions yet. I'm gonna add the first one. Nice. So let's see what Amlak did. So check this out. So it's a little bit small, maybe for the stream. I don't know if you guys can read it. I'll read it for you. So he's launching Zigbee test and passing a -- listen argument with an IPv6 address. And then he's also passing -- fuzz. So this starts a web interface. Fuzzing had a web interface also before. Sorry, it also had a web interface before. But this one doesn't just have fuzzing. This one has a section dedicated to fuzzing, which is what he's showing right now. But it also has a section above that shows information about the build process more in general. And I think this is being demoed here more explicitly. Let's see. So he's launching now Zigbee test with -- time report. And these are all the tests, or at least some of the tests in the compiler test suite. So you see them being executed, and then you get a time report that tells you how long each of these things took to compile, and I'm guessing also run. Well, this is a compile thing, so it tells you how much it took to compile. And going back to the idea of generic instantiations, this is, oh god damn it, this is showing you also this column here, analysis count. It's telling you how many times a given function has been analyzed, which I believe is not precisely how many generic instances you have, but it's very close to. And so you can use that to see how many instances of a given function you ended up generating. And also, if your project takes forever to compile, now you can see why. Although, the answer will be most probably waiting on LLVM. Usually that's what takes the most time. But, let's just say that if you were a little bit too, man, what's the word when you're like a little bit too aggressive with something? Zealous. If you've been a little bit too zealous with com time and inline, you've marked functions as inline when it's actually not a good idea to do, or you made things com time, where it's not really strictly necessary that you make them com time, and you thought it was a good idea, but then you started using this thing, this functional a few too many times, and now that com time argument is causing a ton of those things to be generated. Or similarly with any type, maybe a function originally didn't deal with slices, but then you added slice in the mix, and now you have the problem that I just presented. You will see it reflected here in analysis count. In any case, so it gives you this breakdown. Well, and then you can also do rebuild. And he even added the animated thingy. Cool. Yeah, we can try this out. Okay, give me a sec, because first I want to make the zine release, and I want to implement what I was working on. Once I'm done with this, I'm happy to try it out. So, okay, so can I go to definition on add fail now? Yes. Turns out that updating ZLS does solve your problems with ZLS very often. Zig build ID when? Well, I mean, a web interface can get pretty close to that. There's actually real editors, real IDEs that are web pages. I just realized. Revealed my coming hand with F incremental on macOS, by the way. God damn it. Yeah, but it would be nice if it didn't have to. Okay, so is there add fail FMT? No, there's only add fail. Okay, so we have to FMT on our end if we want to FMT. Do I want to FMT? Yeah. Let's see. Git tag does not match zone package version. Git something like this. Let's set a comma so we get everything on a new line. So this is going to be a b.fmt. Git is this, comma, zone is this. Okay. So this should be it. We can also do this. And now that I think about it, we can void this. Oh, this is nice. Okay. Does not match package version. So zone, we want zone version. Oh, this is wrong. This is zone.version, and the other one is version tag 1 dot dot. Check with a nice error for an empty zone.version. Oh shit, you're right. It might be missing, right? Although in my case, it's not a problem because this is not for any project. This is for my project, and my project has that field, so it's fine. But if I were to make it like a generic, like I don't know, a Zig release kit. If I made a release kit, then sure, you're right. I would probably have to have a thing that complains if there is no version field specified in the zone file, or there is no zone file at all, by the way, because that's also a possibility. You could have a package. Well, but how would you have a package that does not have a zone file, but that is using Zig release kit? You could still do that. You would have to be evil, but you could still do that. Okay, zone version, comma, version dot tag, one dot dot. Okay, let's see how this goes. Value of type blah blah blah. Oh, because we have to do release dependent, huh? Okay. Expect a comma after argument. What do you mean? Oh, depend on. Okay. What if I didn't do this? Yeah, that seems good actually. And that also kind of teaches me things that we could probably want to do this. Also, there is a dot step involved that I forgot about. And a ampersand, which we did do. Okay. Expected type build step. No, okay, it went away. Okay, let's see. Zig build release. Git tag missing, cannot make release builds. Sure. Can I Zig build without errors? Zig build test also works. Now let's make a tag then. So, well, git status. Check that zone version matches git tag version. Okay, so you can use init -m, yeah. So Zig build release, git tag missing, perfect. Git tag .1, Zig build release. Git tag does not match zone package version. Git zone. That's not bad. That's not bad. Okay, let's fix the zone file. Which, by the way, also means that we got our strings backwards. You're right. I got my strings backwards. Okay, so this also means that it's status. Let's see. Delete the tag. It's inversion. Git tag. .11. Zig build release. Actually, let's just delete the release directory first, and let's build release. This now should work. Now let's look at it go. I'm not gonna be able to use my system for a bit. Imagine also having a web UI open. Yeah. I mean, for the release, I don't think I really care, right? It is what it is. It takes what it takes. But it would definitely show stuff. That's for sure. Yeah. But I'm gonna try it out now with like a normal build. I'm curious to see, maybe I do have some silly, insane genetic instantiation of something and I just don't realize it. Or maybe I'm doing some I don't know, see interrupt that for some reason. Well, not interrupt necessarily, but like I'm adding C projects to the build and maybe that triggers a corner case that you didn't think about in your interface, and we're gonna see a nice crash. We'll see. Well, to be honest, I find honestly this in the terminal, like seeing the graph that goes up and down, this is to me um, as satisfying as it gets. With maybe just one caveat, a progress bar at the top in the terminal. That makes it, right. That to me is the best in this case. That said, I think that the web interface for like development, more not releasing but like development, it surpasses this. Yeah. Yeah, I think that the design of dash m, it's not dash m specifically. Zig init uses your directory name as the project name. Yes. Oh, you know what I think we should add, Matt? I think we should add some code that detects a. No, I don't think we should override that. I think that what we should do is detect if the directory starts with zig dash and remove the zig dash prefix. I think that would be a very good idea to add, but not as a like not really necessarily as an option. Too magic? What do you mean? You don't want people to create zig dash projects just because. By the way, I've had packages that were named zig something simply because zig init added zig something in the in the zone file, and I didn't bother fixing it. Also, name one wrong. Name one time where removing the zig dash prefix is wrong. I dare you. Then you call it download zig. Zig dash guana. Then it's guana. Then you call it guana in zig. Like zig dash makes sense for your project name, like on GitHub, because on GitHub you want maybe to explain that a given thing is for the zig ecosystem. Like for example, zig YAML. This is YAML for the zig ecosystem, but you don't import zig YAML in your code. You just want YAML. So I think that you're setting aside funny corner cases, which, by the way, people can then fix on their own. The reality is that what normally will happen 99% of the time is that people will make a zig something package that goes on GitHub or similar places, and then you want that to be just YAML. Well, you want I think this to be prefixed with zig, but then you don't want the package name to be prefixed with zig. Let's see what this package does. For example, this package is doing it wrong. This by the way, this mine is a fork from Jakub's package, and this is doing it wrong. And I can tell you why it's doing it wrong. Like I can promise you why it's doing it wrong. Entirely because Jakub used zig init to generate this thing, and he got zig underscore YAML put here automatically and never bothered changing it. That is the entirely the reason. I would bet good money, like not just good money. I would bet all my money that this is the case because I've done it too. My point is that you cannot really fix this on your own because the fingerprint. Yeah, sure. I mean, you will have to touch the thing twice, sure. But how many people on the planet do you think will have to do this because removing the zig prefix is really that wrong? I don't know. If it will happen, I don't know, 10 times in a year, I would be surprised. How many times do you think people will create zig underscore stuff packages where zig should not be in here? And then other people will have to do fetch and then remember the name because they want to remove the zig prefix. And then sometimes they run fetch, they forget to remove the zig prefix, and then they get zig underscore YAML and YAML in their zone file. I do not necessarily name my directories after projects. Okay, that's another perspective. That's another really weird perspective. In any case, I think the point is, I think it's reasonable to look at this from the perspective of what you want to do and how you would want the system support what you want to do. That's fair. But I think specifically in the case of Zig init, an even more important perspective is what will the average programmer do? And how can you make that a little bit better in order to have, statistically speaking, a positive change? I would argue that removing the zig prefix is a slam dunk on that perspective. I would argue the amount of extra work that you take away, that you save by automatically removing the zig dash prefix in package names is by far superior to the amount of extra work that you create for those cases where somebody wants to do, non-obvious things. Or said another way, maybe there should be an option to set the name manually, but that is, in my mind, orthogonal to automatically removing the zig dash prefix when you don't specify a name. I think that we should definitely have the former. We should definitely have removing the prefix. And then if you want, you can also have an option to set the name manually, but they are not solving the same thing. They are solving two different things. Removing the prefix helps make the ecosystem better. It's like, having trash cans around town so that people don't drop their trash on the ground, roughly speaking. Maybe it's not the best example, but you get the idea. Like doing things that help make the ecosystem a little bit better because it counteracts when people do things without thinking. Because people will do things without thinking. I do things without thinking. Here's an example of the same happening to somebody else. And I'm sure that a trivial search will find an endless amount of these examples. The extra word should be completely in either case. Sure, but it's a separate thing. I guess my point is we should have the remove prefix, and then and then I don't know. You guys can discuss if you want to have like an option to add to specify a name. I don't have a strong preference. So I would prefer the Z compiler to not be special case in certain strings. This is still, you're still looking at this from a different perspective because it's not. So I would prefer for the Z compiler to not be special case in certain strings. Please create closed-platform GUI library that does not suck. Thanks. Alcras, why? Look, if you have a problem with that, why don't you put effort to make one that doesn't suck? You know that these things always require somebody to do work. Somebody has to do it. So instead of asking, do it. and then you will discover that it's probably not that easy. but that's how it is, right? Every single thing, if you think about it, every single thing in the Zig ecosystem that is kind of nice, somebody sat down and started working on it. Every single thing. Name one thing that you like in the Zig ecosystem. Somebody has sat down and done it. So sometimes it has to be. It's your turn to be the hero, I guess. The reason you will find a bunch of packages with names starting with Zig is because people have historically thought it was a better way to name packages. I would still prefer it, in fact. What? Okay. Well, have a good shower. See you later. Okay. Let's make the release. So to make a release, we also need to go to the website, zssg.io. Let's see, what were people saying? I'm a noob. What is ray tracing? Ray tracing is, so I'm going to follow this book, but you've seen this image, right? Oh, okay, it's only seen. You see this image, you probably have seen it, some of these images. The idea is that ray tracing is the concept of setting up like a 3D scene where you have a source of light, and the source of light, in games, this at least used to be the case, that people would fake real lifing, because they would, make, for example, certain objects bright on their own, even if they don't have a source of light hitting them. And they would and then they would know that if like there's an area that it's supposed to be darker, then everything gets darker. But they don't have like a real simulation, like physical simulation of light rays bouncing around and lighting things up as they get hit. Or like reflections, for example, are another example of that. Reflection, you can fake it, right? You can fake a mirror by, doing programming tricks, or you can basically have a mirror genuinely be lights, rays that go from light sources to items that then bounce over something that is reflective, and that decides what the reflective surface should show. So ray tracing is basically doing the physical simulation stuff, and it gives you better results, but it's also turbo expensive. So we'll see. And nowadays GPUs have some of this stuff integrated in hardware. So apparently they can run this stuff in real time because it's not done in software, it's done in hardware. But I don't know if they use the same techniques that will be shown in this book, because this book is kind of an introduction. I'm going to do in one weekend. So I'm not going to do the next week. I'm not going to do the rest of your life, or rather, for now I'm doing the weekend. I could see myself doing the next week. I don't see myself doing the rest of my life. We'll see. In any case, this is the idea. Okay, what we're saying, we make a release. So in GitHub pages, we want version 11.1. In GitHub pages, we want to tell people to use 0.1. Cloudflare pages, .1, and then we go to the release log and we make a new entry. I took CS classes from Peter Shirley, the guy who wrote these books. Oh, nice. Cool guy. He used to give out prizes like iPods for getting questions right in class. What? Like an entire iPod? And wow. Wait, what? Wait a second. What was the what would be an example question that would win you an iPod? 11.1, 2025, July 26. Another round of bug fixes with this release. All known bugs have been solved. Like, I can't think of a real bug. Like, there's missing features compared to like a full version of Zine. But is there any other like bug that we have? I don't think so. Well, okay, let's add the list. I see Ghosty in there. Are we migrating to Ghosty now? Well, I've migrated to Ghosty a long time ago. I've been daily driving Ghosty for a long time now. Oh, you want to see something cool about Ghosty? Okay, I'm gonna take a break from this for a brief moment. Ziglang/zig. Check this out about Ghosty. This is not unique to Ghosty, but check this out. Check this out. Oh, did it get merged already? It might be. Oh yeah, it got merged already. So check this out. Check this out. Do you have a demo in here? Oh, alright, I think this is good enough for the first version. I added SED progress at status. Indicates the application is progressing towards completion of a task. Unless the application is interactive, this is the only status the program will ever have. The application has completed an operation and is now waiting for the user to input rather than calling exit 0. The application encountered an error and is now waiting for user input rather than calling exit. The application has encountered at least one error, but it's still working on more tasks. Interesting. So, by the way, we need to integrate with this API also in Zine. So, give me a second because there's a demo of this that I want to show, which is pretty cool. I think this is std. Yeah. Copy link. Okay, check this out. Look at this demo. Oh. Wait, wasn't it running? What the heck? You see the progress bar at the top? So this is basically, these are escape codes that that allow you to communicate to the terminal emulator that progress is happening. If you think about it, it's insane that for many years, progress bars have been rendered. No, it is. They didn't come up with this. It's OSC 9:4. It's so it's a thing that not all terminal emulators support, sure, but it's not something that Ghosty made up. It's just that it's I guess it's a more obscure set of escape codes that maybe most emulators don't implement, but this was invented in the past. So yeah, and now Ghosty has added support for it. It's not the only terminal emulator. There's also a few others. I forget where I saw this, but there's other terminal emulators that support this. Not a ton, but some do. And yeah, so instead of drawing with equal signs or like other characters, progress bars, in a way that isn't semantically understandable by the terminal emulator, now you can integrate with this, which is cool. And the standard library progress bar system in Zig has now added support for this, so we have it. It's merged in master branch now. Okay, let's see. Real iPod, one of the questions was, how much does a submarine weigh? To which I said 0, because of buoyancy. He really wanted someone to estimate the volume and density. Oh. Well, yeah, I guess the answer is that a submarine can change how much it weighs, right? Depending on how much water it pulls in or pumps out. So yeah, they have control over that. Is it possible to detect if terminal supports it, or is it done by term and var? That is a good question. I believe that there is an API for having the terminal tell you which escape codes are supported. I believe not many programs use it. Most programs either do what you said, so they look at the term var and they basically use it as a what's it called, like agent, user agent string, like like in the web, people look, is this Firefox, is this Chrome, is this IE, and so they do the same, but with similar catastrophic consequences when they see something that they don't recognize. There's another thing called, I believe it's called term cap, but it's another bad thing, term cap. I believe this is like a database. Let me see if yeah, it's a database where basically instead of having just the string, your system has somewhere a structured file that contains information about, I guess, for each of these strings, what capabilities it has. The problem is it's obsolete. Like they even say it here, it's obsolete. And so, but there are programs that still use term cap. And so those that do also have big trouble with newer terminal emulators. Sorry. So, long story short, you shouldn't be using this either. I think there's to use term info. Let's see term info. Oh, it's another shitty database. Okay, I think the term info is not obsolete, but it still sucks. I think you're not supposed to use any of these things. Let me see what libvaxis does. I think the libvaxis does the right thing, but I don't know exactly what it is. I think it's querying the database, the terminal emulator directly, but I don't remember how. Let's see if there's like a place where we can see this quickly. TTY. Because Vaxis knows about capabilities. It knows how to query for capabilities. I just don't know how this works. Test TTY. I don't remember where this stuff is, but it is somewhere. Let me see. Window, Vaxis, Unicode, screen, parser, mouse, loop key, internal screen, image, graphene cache, cell, widgets. I think, okay, maybe we can do it like this. Let's see what screen has. Which properties does it have? Screen does not have what we want. What does Vaxis have? There we go. Capabilities. You see here, there's capabilities. We know if the emulator supports the Kitty keyboard protocol, the Kitty graphics protocol, actual RGB, Unicode, SGR pixels, color scheme updates, explicit with scale text. Oh, right, there's also scale text. That's insane. So where do we, let's take a look at references to capabilities. So here it gets initialized by default. It's called caps. Okay. GitHub obviously doesn't know. Holy shit, GitHub knows when I'm clicking on caps to give me caps. Okay, here we are setting this stuff. You can see that we're setting it. No caps, no caps. There we go. How does it work? Enable detected features. Enable detected features detected by responses to query terminal. So query terminal is what we want. Query terminal send. Query terminal. Let's go. Query terminal send. 1 second timeout. Queries done.store unordered. Let's see. Write queries to the terminal. So this is done by communicating with the terminal emulator over escape codes. So it's not done by looking at a external system, but I guess it's a protocol that the terminal emulator needs to support. But what's good is that it's the authoritative answer. It's not a separate component that might or might not be up to date. It's the actual real thing running right now that tells you what it supports. So it's something that you can trust. Let's see, this call will block until Vaxis query futex is woken up, or the timeout event loops can wake up this futex when something. Okay, let's see. Write queries to the terminal to determine capabilities. This function is only for use with a custom main loop. Call Vaxis query terminal if you are using loop.run to enable this. Okay, so something is not enabled. So yeah, it's just a bunch of escape codes. Basically, it writes a bunch of escape codes. Explicit with query. We send the cursor home, then do a scaled text command, then query the position. If the parse value is an F3 with a AL, we support scaled text. The return response will be something like blah blah blah, which when parse. So some of these things are not even communication. They're like just actually testing the capability, which is disappointing. I think terminal emulators could do better, but anyway. Is it yours or review? No, I'm looking at how a terminal, a TUI library does feature detection in terminals. So this is a library for making TUIs. I'm actually using it here in Bork. I'm using only the low-level API. I'm not using any of the Vaxis widgets. I made my own quote-unquote widgets. They're very dumbed down for very dumbed down in interactions, but that's fine when it comes to Bork. Anyway, okay. Another round of bug fixes. Let's go start making a release so we can see what changed. Ensure the future of your work. Consider inviting another GitHub user to be your successor. Invite a successor. What? Here's now a thing in case you die. Also interesting, why is this showing now? Did they just implement this? Oh no. I think it's because I reached 1K stars. I think by reaching 1,000 stars, now it's like important enough that maybe having a successor. Can you imagine? We got from King Dynasties to having successors on GitHub repositories. This is both interesting and useless. I don't see it. So, at first glance, if you look at it in a naive way, you could say, oh yeah, this is nice. This ensures that your project doesn't get, stuck. But if you look at it from a more, in my opinion, from a more sophisticated perspective, open source is designed around the idea of being able to fork a project and then continue it. So you don't really need a successor to continue developing Zine once I die, or even without me dying. Tomorrow you decide that, man, you like some of the things in Zine and you really hate other things, and so you decide that you fork the project and you make your own. You can do that today, and you don't need me to anoint you as the successor. Yeah, the URL breaks, that makes sense, but sure. But maybe that's actually good. Are we sure that we actually really want the URL not to break if somebody else becomes in charge? I don't know. Like, it's a big breaking change, and I guess that I get it that if it's somebody that I've appointed, it's different. Sound is not clear today. Do I sound weird? What? I think I'm fine. I'm just hearing myself in the stream preview. Maybe okay. I can lower this a little bit. Um. Okay. Yeah. So, Rose, and you might be onto something because I am 100%. I've messed with my system because I have a malfunctioning audio interface, and so I made some changes to make this work. So, you're not hallucinating. You are right. But there's nothing I can do for now. This is it. Okay. It sounds to me like you're doubled a bit. Oh. Oh. I hear you more on the right here. So, yeah, so the fact that I have a malfunctioning audio interface does make sense. Yeah, no, I think it's fine. Sound balance is off. I hear your voice more on the right ear, I think. Yeah, I think you're right. Yeah, I think you're right. It's not terrible though, hopefully. The problem is that I can't really fix this right now. I can try to unplug the interface and replug it, and that should not destroy the stream. So I can mess around with this a little bit, but I try to mess with it before the stream, and it's just a device that is malfunctioning. I have one of these guys. I have one of these guys. There was a slight hic earlier that shifted stereo briefly. Oh, yeah. So I have one of these guys, but it's not really functioning really well. That's the problem. That is the unfortunate. It's a really good device. It's just that mine is not working well. Wait, what if I do this? Test. Okay, now we're back. Let me see. How do I sound? I don't know. For now, this is it. Let me do the Zine release and then I'll try to fix audio. No, wait, what? Why? I double clicked on something else. God damn it, man. Do-do-doom. I have you on speakers, so the imbalance might feel doubling to me as I could not grasp what felt wrong. I see. Yeah, sorry guys. That's I know that I need to fix this. The problem is that this thing is expensive, so it's not like I'm gonna buy another one at random. I did message the support, but I need to reply to what they wrote me because of course when you complain they first say, "Did you try rebooting it?" Yeah, I did try rebooting it. Did it ever work correctly? Did you use the right cable? Yes, it worked for like years. So let's see, github.com/christopheit/zine. Let's look at the last release. Yo, thumbs ups. Nice. There's users. Yeah, I mean, I'm not saying that they're necessarily bad. I guess there's a reason why they do that. Because I can imagine people contacting them for no real reason and complaining about stuff when it's them doing things wrong and not really the product being broken. For example, when you do video capture, you need to make sure that you connect the video capture to a USB controller that isn't already overloaded, that doesn't have a ton of other demanding devices connected to it. And it's not, for example, always clear which of the ports on your chassis, on your computer chassis, connects to where on the motherboard, that kind of stuff. So there's a lot of things that can go wrong with this type of device in in a way that users just don't know what they're doing. But in my case, it's different, and so it's annoying because it worked perfectly for a long time, and now it doesn't do that anymore. Okay. So what did I want to do? Yeah, commits. Fix a bunch of invalid accesses and update Zig version, added path normalization, fix installed path usage, and then the latest comments that we added. Okay, so these two are not interesting. These three are the bug fixes. Who would you recommend on YouTube to watch to understand Zig better? Well, I would say first and foremost, the official Zig website, the Learn section, the language reference. That's your source of truth for the language, and then you have the standard library documentation. And on top of the standard library documentation, if you go to source, if you go to the repository, there's a wiki page that tells you how to read the standard library source code. And the standard library source code is actually really readable. Do it. Like if you're somebody who programs in Zig, you should read the standard library source code. Like if you're coming to Zig and your perspective is, oh man, I want to learn what's in the standard library, and the only way I can do this is by using the docs. I'm gonna open another tab for this, and the only way I can do this is by going here and clicking around. And I'm annoyed whenever this website doesn't, this documentation doesn't have everything. Sometimes I want to learn certain things that the docs are not good at showing yet. You're doing it wrong. You are approaching Zig in the wrong way. This is not up to discussion. This is an objective truth. You're doing it wrong. Doing it right means reading the standard library source code, which doesn't necessarily mean you open, I don't know, you do that on GitHub. Don't read the standard library source code on GitHub. GitHub is awful for reading source code. It's absolute ass. But if you have an editor with ZLS installed, you can go to definition. Well, when it works, I need to reboot this. you can go to definition on things. So for example, let me see, I need somewhere where we have standard library stuff. Here, for example, I'm using std_debug.assert. What's the signature? How does debug.assert work? You press the go to definition in your editor. For me, in Helix, is G for the go to menu, and then D for go to definition. Whatever editor you're using supports this. Well, actually, no, that's not true. But whatever editor you're using that has complete support for language servers will be able to do this for you. So you press D to go to definition, and that gets you on the standard library source code. And here you can read the doc comment, the doc string. Actually, the doc string you can already do from here. It's space K in Helix, shows you the signature, shows you the doc comment. So you can already see this without going to the source code. But if you go to the source code, you will see this, and then you also get to see the implementation. Assert seems unremarkable, but for example, a lot of people had misconceptions about how assert works in Zig, and I suspect some of the misunderstanding comes from the fact that unreachable is a language feature that is not immediately obvious to understand. It's not unique to Zig, but it's a thing that exists also technically in C, but people in C don't really use it, so they don't know what this thing does. But I think a lot of people assume that assert worked in a different way in Zig, partially because they never bothered to see how it's implemented. And you can do this with everything in Zig. Like for example, you want to know what you can do on a writer. You go to definition on the writer, and here's the trick. You search for pub function, and that gives you all the public functions that you can invoke from a writer. This gives you basically the public interface of writer. Sure, if you have autocomplete, you can also do writer dot and then have the autocomplete menu suggest you a few possibilities, which is, I guess, in some ways better. I don't have it enabled. I don't like autocomplete in Helix, so I keep it disabled. But that's my personal choice. But like, even if you are in a similar situation, or more in general, you want to see not just the signature, because the autocomplete will give you the signature, right? Here you can see also the implementation, and you can see it basically in its context, and you say, wait, advanced vector, or let me find, I don't know, maybe a different example. Print write byte. For example, splat byte all calls splat byte in a loop. So you go to definition on splat byte and say, splat byte calls write splat. Okay, what does write splat do? Oh, it does count splat. What does count splat do? Oh, okay, it works this way, right? Maybe you don't do that on a writing interface, realistically speaking, to match, but for other ones, you can do that. Sorry, Christoph, I'm literally dropping in to ask a quick easy question to whoever knows. Slice of a line for T, is this a slice pointer where the first element is aligned at 4, or all elements are ensured to be aligned at 4? The first element is aligned at 4, but this should also be true of all the other elements. Like normally, you know what? Maybe you can find a counterexample to this, but usually types have padding in, like a struct. Let's assume that T is a struct. Usually structs have padding, and that padding also is guaranteed. So this is not just the first element, because it would be broken. This property is guaranteed, I believe, for every element in the slice. And for some, it's trivial to guarantee, and for others, it does require adding extra padding in the slice. But I do believe that this is not just the first one. Because what I think this does, it works this way. This is a slice of align T for elements, and that means that you will get align for elements out of it at any index. So align 8U8 is just a regular string. Oh, that's a good point. You're right. That's an actual counterexample. Never mind then. And this is not true. Yeah, an align 8 string is definitely a string without extra padding between the bytes. That is for sure. Yeah. You know what? I think I said it wrong. I think Andrew had it right the first time. Yeah. I guess it's just a property of the first element. That makes sense. But you can cast it to slice t where t has alignment of t is 8. Mm-hmm. Yeah, no, I think Andrew gave you the right answer right away. What is the best way to learn Zig? Write Zig. Number 1, write Zig. Number 2, join a community so you can see how others write Zig and they can give you feedback on how you write Zig. Writing definitely is the best way of doing it. Yeah, so going back to the point of I'll keep my Zig private. No, don't do that, Temporus. You should live stream your work on Zig. So yeah, I get it that other ecosystems the standard library is not always readable, especially in situations where you're using a language where the language used for implementing the standard library, maybe it's not even the language itself. Maybe the standard library has pieces and bits and pieces of it that are implemented in C, and it's a higher level programming language. That obviously is a non-starter. Or you're using, I don't know, Java. Is the Java standard library readable? Probably not. I've read a little bit of the C# standard library. That thing was ass. So I get it that in other languages, reading the standard library is not the right way of doing it. Or rather, I will say this. I think that it should be the right way of doing things. If your language does not make it, if your language has a standard library that it's impossible to understand, I would say there's something wrong with your language. Setting that aside, being able to read the standard library is a superpower. It teaches you a lot, both in terms of ramping you up with regards to how things are done in the language, what's idiomatic, what are the expectations, but also you're basically looking at what should be one of the best, highest quality examples of source code that you can find in the ecosystem. And so it's like a sure way, should be a sure way of learning good practices. And then you also and then on top of all of these, there's like an extra benefit. You actually learn how to use better the most critical dependency that you will have to use. The standard library is, at the end of the day, a package like any other. Well, not exactly like any other. It's a little bit special, but it is a package at the end of the day, and the package that you will use the most. And so learning how to use it well will make you a better programmer in its own right. So yeah, not reading standard library source code, I find it unthinkable nowadays. Did having two backends, LLVM and non-LLVM, make Zig harder to maintain? Yes, you have to do extra work. Also, it's not two backends. There's the LLVM backend, that is one backend, but then you have to have the x86-64 backend, the Arch-64 backend, and then SPIR-V backend, and then the more architectures you want to support directly without going through LLVM, the more backends you have to write. The reason why everybody uses LLVM, or rather, one of the main reasons, is because LLVM allows you to target multiple architectures all at once. So you output once for LLVM, and then LLVM does this extra work. But once you take out LLVM, then you will have to do more work on your own, a lot more work. So it does make it harder to maintain to some degree, but it also gives you the ability to do things that are impossible to pull off if you have to depend on LLVM and you don't know how to do otherwise. Java Standard Library is actually pretty good. Nice. So a align U8, it's ensuring that the first byte is 8 bytes aligned. Yes. 100%. It's not adding weird space between your string. You know what? I was getting confused with T because I thought for a second, but I know this to be a fact. So, yeah. Andrew Krevsky was 100% right the first time. As someone coming from the Java standard library, the Zig docs are fine but sparse. Yeah, the Zig standard library is not perfect. That's for sure. Right now, the Zig project is focusing on the compiler itself, and so the standard library is growing in a somewhat organic fashion with varying degrees of quality in it, depending on when it was like patched last. I'll give you an example. Andrew right now is redoing a bunch of the networking stuff because of the new async IO change. And so he's redoing the HTTP server and the HTTP client, and that basically gives a good hand of polish to them. But for a while, these things have been used they weren't really being used much by Zig itself, so they worked, but they weren't as good. They didn't have as much documentation, etc. And then things have improved as usage of these things in the compiler improved. One of my small annoyances of the Rust stdlib is there's a number of feature usages that only work in the stdlib. Aha, they cheat, huh? They give themselves superpowers. This is, by the way, a very interesting thing. In Zig, the standard library is not special cased at all. There is nothing in the standard library that only the standard library can do. Like, pretty much nothing. Except for this. I think start. Start is, well, not really special, but the point is that when you're making an executable, everything starts from start. I guess unless you define these functions. Let me see. I don't remember exactly how it works. I know that if you define these things yourself, then your version will be called. But is it these guys that delegate in case you have that definition? No. Never mind. So you know what? Start is not even all that special then. So what happens is that if you don't define the starts, sorry, if you don't define the start symbol or the I don't know, I don't remember which one of these crappy functions is the one that Windows likes to use as its entry point. But if you don't have them, then Zig will use these definitions and they will call into your main function. They will do call main, and call main finds your root file, searches for a main function, and then calls your main function. And depending on how you did the signature, calls it in slightly different ways. So if you have a main function that returns void, then here call main returns 0. If your function returns like an error set, then here we do, in case you return an error, here we print the error trace and then the stack trace. This is like convenience stuff. But if you define the start symbol, then I believe this stuff doesn't even get invoked at all. And so never mind, start is not even all that special. But yeah, there's nothing special in the Zig standard library. For me, it's all the macros and indirections. Yeah, top to bottom. Yeah, also WASM backend, C backend. Are you guys writing all those? The Zig core team is working on them, yes. The ARM64 backend was just merged into main branch recently. It doesn't pass all tests yet. It passes 75% of them. But it's getting there. Let's see, where can we find the PR? Here we go. Add new from scratch self-hosted backend. And this works for ARM64. And not only that, these are also faster, like much, much faster. Let me show you the devlog entry. So you go to devlog, and look, this was the last post. New Arch64 backend, and these are fast. This one, the Arch one, is even faster. So these are both faster than LLVM, significantly faster. And on top of that, the Arch one, the ARM64 one, we say Arch 64 because the ARM, the company, for some reason they decided that they said, no, we want our architecture to be called Arch 64, which is a goddamn stupid name, but that's what I guess they say. In any case, I'm going to say ARM 64 now just for simplicity. The ARM64 backend is even faster than the x86-64 one. The main reason for this is because ARM is a simpler architecture. It's easier to write code generation for ARM than x86-64. This is not to downplay the fact that Jacob Lee, who did this work, did clever stuff. For example, he implemented an algorithm to generate machine code in reverse. MIR, not exactly machine code, but in reverse. Like he basically, instead of needing an extra pass, he's doing like two things at once, backwards also, which is harder to reason about. But the point is that he's also the author of the x86-64 one. So how can I say, like he's been clever in implementing this one, but he has also been clever in implementing the other one. So it's not that the ARM one is particularly cleverer than the other one. The same clever guy wrote both of them. So I would say at the end of the day, it mostly tends to boil down to the fact that x86-64 is a cursed architecture. I love the non-configurable between formats. I prefer two spaces, but I no longer care. Yeah, same. You know, I have a preference for, if you ask me, while I have no respect for the C# ecosystem, I like this style of parentheses. I like the opening curly to be on a new line. I think it's a good idea. I like it. I like the fact that opening and closing are on the same column instead of being on two separate columns. But you know what? What I like more is having an auto formatter and is everybody having the same style. That beats it 10 times as much. Like it's so much better. Also, for those who don't know, the Zig auto formatter you can negotiate with. So if you have some code and you have, for example, a function signature, and you have a bunch of arguments, Zig allows you to have trailing commas to signatures, and also other places. So a trailing comma is not an error, and the trailing comma is used to negotiate with the auto formatter. Adding a trailing comma means that you want vertical alignment. Remove the trailing comma means that you want horizontal alignment. You know also what's clever about this? That when you have vertical alignment, you never have the problem that, oh no, I'm going to add another thing, but then I forgot that this needs a comma, and now my thing doesn't compile because I forgot to add a comma here. By the way, if anybody here has ever had to add an entry like in a JSON file, that happens all the time, right? You're adding something in a JSON file, and you forget that the last element, for the love of God, cannot have a trailing comma, otherwise the parser poops its pants. But in reality, here by virtue of having that vertical alignment, it also always has a trailing comma. Then you can add something without worrying about that. And then you can also flip between the two just by adding and removing it. So you can basically use the auto formatter also to help you switch between standardized, well-known configurations. It's nice. ZLS for some reason can move to anything inside as import built-in. Is it special too? Even Zig SCD doesn't have it. Built-in depends on your build target, and ZLS can go into that, but you need to have a well-defined build. For example, I'm going to go in Zine. I'm going to go in root. We have built-in in here. Look at this. I have built-in. Go to definition, and I can see it. But yeah, this depends on the last build. For example, this one is saying that my target CPU is Arch64, and you see what I mean? Like this is a source file that usually lives in the cache, and it's generated by Zig every time you build something. So it is special in that sense. It's special in the sense that it's generated on demand by the compiler to contain information about the target and similar stuff, and build mode, and all this type of information. but it's a normal module in a sense. So it's a module that exists in the set of modules that you can access. So it just gets configured implicitly. ZLS can totally go into it, but you need to have everything configured correctly. ZLS can do even better than this, by the way. Let me see if I can show you. Let me see if I can show you. What is supermd.c? Supermd.c is a module in one of my dependencies that C imports a bunch of header files. What if I go to definition on this header file? I can see the header file. This is the original header file. What if I go to definition on this guy? Let's see if I can go to definition on this import. Doesn't work. Go to definition on the C. Okay, this works. This is like depends on how it's implemented in CLS. But this is showing me how all the other files have been translated. More interestingly, I'm gonna go to references and see where we use C. Oh, come on, dude. We're not using C in here, obviously. We're exporting it. So let's see where I'm using C in this other file. Here, I'm saying, oh, I'm using this C variable, C mark node strike through. What does that look like? It's an extern var. Apparently, it's a variable that gets modified at runtime by, it's a global variable that gets modified by C. Delightful. I mean, C moment. That's how C is. I don't know what to tell you. But let's take a look at, for example, let's take a look at other uses of this. Oh my God, I only use it for variables. Okay, somewhere else, I use this for calling functions. Maybe we can do this. Go to SMD, go to AST, and in here, go to references. Yeah, here I use C for a lot more things. I call functions like CMark parser attach syntax extension. If I go in here, I can see what the signature is. So I can see the translated signature, and I can also go to definition and see it in its context. It's not super interesting because this is a bunch of shitty C header files being translated automatically, but you get visibility also into that using ZLS. But your build needs to be configured correctly. So yes, this is correct. This does not get only generated by the build system. Or let me put it this way. It depends, I guess, on what you mean by build system. But if by build system we mean std.build, then no, because you get that generated also when you use zig build-exe, which does not use the build system. So I would say it gets generated by the compiler, but this is nitpicking. Is there a dynamic feature like in C# where I can access stuff I haven't found yet? The JSON parsing is a bit annoying. I don't know what you mean. I think I would need a more concrete example. Okay. I will steal this trailing command feature from my auto formatter. Do it. Do it absolutely. Wanna check something cool out? Super HTML. This is my HTML language server. And guess what I have in it? So first of all, I report syntax errors. VS Code and other editors don't give you syntax errors by default. But then check this out. I have a zig style auto formatter. Placing a space between elements means that you want vertical alignment. Removing the space means, horizontal vertical alignment. Removing the space means that you want horizontal alignment. Same with attributes. You add a training space, you want vertical. You remove the training space, you want horizontal. I'm gonna change this. I now found a better way of doing this, but it's the same concept as Zig, and it's delightful, absolutely delightful. Also, I need to give some love to SuperHTML. There's a bunch of issues that I haven't really looked after. Like the last release was October 31st, so I haven't released this, SuperHTML in a while. It's part of the Zine ecosystem, my static site generator. So I'm gonna get to it eventually. Also, how are we doing in downloads? Are people using this thing? how's the VS Code extension doing? Almost 2,000 installs. Okay, so not a ton of people using it, but some. What trick to make ZigFMT and ZLS not make a long statement one line past 80 columns? The formatter doesn't have a 80 column limit. Like the formatter doesn't care about 80 columns absolutely at all. If you have a long statement, can you, here's an idea, Brian, do this. Go to zigbean.io, paste here a long statement that you have that is, in your opinion, too long. Share it with me, send a link, and I'll show you how to make it, how to have the formatter put it on multiple lines. If possible. There are some, like if you have a function name that it's more than 80 characters, there's nothing the auto formatter can do. But in other cases, you can. Let's see, regarding dynamic in C#, you can declare something as dynamic, and the user can be accessed with any key, and if it's not there, it throws. Oh, right, I remember now. Yeah. Would be easier for JSON, you know the structure of. Well, you know what's even nicer when you have JSON that you know the structure of? Deserializing the JSON directly into a struct. So I'm going to show you an example not using JSON, but simply because it's more convenient for me to show you this way now. I have a Redis client called OKRedis. And in here, when you send a command, you can say, look, I'm going to send this command. And the first argument is a type. And it's the type you want the reply to be deserialized into. So if you don't care about the reply, you can use void. If you do care, if you want to get the reply, here we're setting a key, and the reply would be okay. So for us, it's fine to use void. If you do get key, then you want a number, which, by the way, this is also interesting. Here we are setting a string, but by requesting a number, we request also automatic parsing of a number out of the string reply. Setting that aside, I64, so we get back a number, but then let's see, sending commands, decoding Redis replies, decoding Zig types. Then you can also request structs. So here we set key to hello world. This is not super useful. Structs. There we go. So Redis also has the concept of a key that is a hash map, key value. So basically, it's a hash map. So my hash key contains a banana key with value yes please and a price key with value 9.99. So we define a struct and we deserialize the reply into the struct. Setting aside the order, like I have a bit of extra metaprogramming specific to Redis, but the point is, if you have a struct, then you can use the struct, and it works. And if you only know some of it, so like you know the outer shell, but then there's a subsection of the struct that you don't know about. I have a dynamic type, so it's not a language feature. It's something that I've implemented in my parser, and it's called types dynamic, and or did they call it just reply? Yeah, dynamic reply. And a dynamic reply is again some stuff specific to Redis, but more interestingly, it's basically a union of all the possible replies of all the possible data types that you can get from Redis, which is close to what JSON does. So in the Zig standard library, you can deserialize a JSON string into a dynamic object. But then you can also combine them. So you can have an outer struct, and then you say, oh, this field, yeah, I don't know what's going to be inside. So I'm going to say, deserialize it into a dynamic object. And so the outer thing, you can just do dot field normally. And then that specific sub3, you're going to use the more annoying API that deals with dynamic objects, where you need to test if the shape matches your expectations, basically. Comp time wizardry? Oh yeah, there's a ton of that, but also in std.json. So let me see that. So in JSON, FMT parse from slice. Let's see, parse from slice. Parses the JSON document from S and returns the result packaged as a SCD JSON parsed. Let's see if it tells you about the return type. You must call the init, blah blah blah. Okay, they don't even tell you because it's assumed that you already know. But the first type here can be extract, so you can deserialize just in abstract. There we go. Copy. Okay, thank you. Okay, we want. I'm gonna go into a function body to do this. Okay, so this is your very long expression. How do we make it? Yeah, how do we make it nice? So here's one way of doing it. You add a trailing comma here. You can also add trailing commas to calls, and this does this, so it makes these things vertical. But you can also add a trailing comma here, and this makes also this vertical. So then you can say, wait, maybe I want this vertical, but I don't want the outer one vertical. Let's see what that looks like. So maybe you want this. That doesn't look great either. So let's see what else we can do. Okay, these are pretty much the two options that you have in this specific case. So you can add a trailing comma here, you can add a trailing comma here or not have it. Personally, I would probably go for this if you ask me. In practice, in more realistic scenarios, look at this here, for example. Here, let me remove this trailing comma so you can see everything on a single line. On a single line, it kind of sucks. I could do this and put the two arguments here on two lines. That also works. But my personal preference in this case was to do this. Short argument on the same line, and then the tuple goes multi-line. Wait, did I do that wrong? Tuple goes multi-line. Oh, I think this is my preference. What was I doing earlier? Oh, I did this? Wait, how did I do it earlier? This is how it was before. I see. So, and then you can have the trailing comma here, so you take it out. Okay. Yeah, this is definitely my favorite. So you get the idea, right? You can play with it and you can decide which style you like most. You put trailing commas or not in wherever something has a list of things inside of it, whenever there's like other commas, basically. So a function call has a list of arguments, so you can put a trailing comma there. One of those arguments can be a tuple or like or a struct literal, and then you can put a trailing comma there or not, and then you can do all the combinations. And you will find that there are some structures that are nicer than others, and make everything look like how you prefer. Here, pass went vertical, right? I take this out, goes horizontal, put it back, goes vertical. So yeah, you can do whatever you want. Okay, let's go back to making the zine release. There's a question about Zig LSP kit. Yes, how do you actually test features when writing LSPs? Good question. So you can unit test your logic, but like, I guess your question is, what if you want like integration tests? I've never did integration testing in any of my LSPs. I always just tested them manually. It's obviously a reasonable request. You can do it, but it requires you to basically have, you need to orchestrate the LSP protocol from the client end. So you basically would need to test to have a virtual client that then invokes the LSP implementation. Also, the LSP implementation has like multi-threading configuration stuff. So like it integrates with stuff in your system in a way that maybe it's I guess you decide how you want to code this. I'm talking about my LSPs specifically. So it's tough. Honestly, this is I didn't tackle it this way. By the way, you said Zig LSP kit. Just to let you know, just to let you know, Zig LSP kit, my Zig LSP kit is deprecated in favor of Zig Tools LSP kit. I need to change this readme. Let me change this readme. There we go. So I would recommend you use Zig Tools LSP kit. It's literally the same thing. So it's just that basically ownership of this system is going back to the people that actually work on it the most. So it's a good news. Switch to this. It would be mostly the same interface. There's minor differences that are mostly to do with just improvements that have been made. So good soup. It's good soup. But yeah, I never added testing for complete LSP features. I'll tell you also another one. Here's another problem with testing, like having integration testing of LSP features. Different editors will have different behavior of your LSP features, depending on how they decide to interpret the language server spec. So, yeah, I mean, it's not like how can I say? So far, there isn't like a ton of new things, gigantic improvements, or anything like that. It's just that over time, maybe there will be, but mostly it's just ownership of the project transfer. Long story short, I didn't transfer the repo because it was already a fork of a Zig Tools project. Like if you look at LSP Kit, this was already a fork. So there was no point in transferring back a fork. But yeah, it's the same thing. So what I was saying, yeah, that basically, if you want to test, there's also the problem that different editors behave differently, and so every time you implement a new feature, you kind of have to open all the editors that you care about and look into them and see how they behave when you when you use that feature, and they will do different things, and you will need to basically, well, you don't have to, but if you decide that then you want to support that specific editor that you're looking at, then you will maybe have need to have some kind of extra flag, extra branching where you somehow deal with quirks of different editors. Such is the LSP life. They should have spooned it. Oh my god, Andrew. Thank you. Thank you for that great joke. Is it static assets path? So release and serve commands dealt with some asset paths in an inconsistent manner, resulting in the situation where an asset would work would an asset path would work with only one of them at a time, depending on whether it was an absolute or relative. Now all paths are normalized before being used. An absolute install path given to a static asset would be interpreted as a absolute path by release, resulting in an attempt to install assets at random places. Well, not exactly random. Outside, well, let's say just attempting to install assets outside of the output directory, which is generally speaking not optimal. We now normalize paths to ensure we don't try to override your, I don't know, etc passwords. Wait, it's not etc passwords. What's the file on Linux that contains user authentication, or even better, WD? Yeah, there's a little shadow. Yeah, okay. Um, um, okay. So I think we are ready for a release. Let's make the GitHub release. We need to push, I guess. Need to push tags. Okay. made a release, push the website. Well, okay. Let's take a look at the website repo, see if it deploys correctly. And one issue and 2 PRs, okay. So we built successfully and we're already deploying. I thought this was automated. No, it's not. I could automate it, but I haven't. Also, the fact that it involves creating release notes on a different website is, and then linking it back in the release notes of the release. I could automate it some more, but so far it's not like a ton of work. I don't release Zine every day. Okay, technically the last release was 2 days ago, but it's not like at this frequency. It happens occasionally. I don't know. So far, I don't feel the need to do that. Devlog RSS link is incorrect. Oh, sweet. Let's see. The subscribe to this page via RSS link in Zinlog is broken. Instead of focusing on another element on the page, it tries to navigate the clearly incorrect, blah, blah, blah. The link in the supermd file appears correct, so assuming it's a problem with zine/supermd's handling of link.alternative. This might be it. Is this? Yeah, it's broken. Let's fix this. And yeah, we're not doing anything dumb, so it's link.alternative. Let's take a look at what we're doing there. So $link.alternative is handled partially by supermd, partially by Zine, mostly by Zine. The resolution of the alternative is done by Zine. So supermd is not at fault here. It's Zine. Okay, I need a quick break. I'll take a very quick break, and then I'm gonna work on this bug. This is what we're fixing next. I am back. Got something to eat. Did you see Casey Moratori's talk about OP 35-year-old mistake? Yes, I did. It was a nice talk. It was a 2-hour-long talk. That is the main thing that I remember. But it was also a nice talk. Before I fix this, let me try to fix my audio. Let's see if I can do something magic. So you're not gonna be able to hear me for a brief moment, and hopefully I will come back soon or at some point. Test. Okay, So you guys can hear me now. Test, 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 test. Okay. So you can hear me. How do I sound? Do I sound fine? Do I have the weirdo left and right problem? Oh, wait a second, because I can't hear myself. Why is this the chat stream? No right side problem. Let's go. I solved it. I wish I didn't have to do what I had to do to solve it, but I hear you fine on both sides of my headphones. Delightful. Test, test, test. Am I hearing myself right now? Give me a sec. Oh, what am I touching now? Okay, so this is my thing here. What is this? Oh, I don't know what this thing does. Oh no, I have a much more complicated like interface right now, and I forgot how to use it. Give me a sec. Now I think the balance between your voice and music is better. Okay, cool. Thank you. Roadcaster app. The firmware update. Oh my god, there's a ton of firmware updates. Yeah, no, this is not a good moment. Bro, please. Okay, it's either I update or I can't use this application. Now I'm not gonna update now. Well, no, you know what? I get it. In this case, I think it's fine because it's firmware. It's especially if it's fixing, some serious bugs, then fine. But it's not a good moment for me. Okay, so we have fixed our audio situation, I believe. So I sound decent. Test, test, test. Yeah, that sounds good. So we're good to go. Okay, what are we doing next? What are we doing next? Right, we need to fix this bug, right? Like Asian bikes. Yeah. The KZOP video was pure gold. It was fine. I mean, if you want I don't know. I was about to say contrarian perspective, but that's not even really what I mean. I guess, like, if I had to make a criticism of the talk, is that it's first and foremost a talk useful to Casey, because I mean, and he kind of says that also in the video. Although I don't know how much self-awareness really there is in that talk from that perspective. But the point is, he's the one that goes on the internet to argue about OP stuff all the time, and so that talk is useful for him to basically reply to people that say, oh no, OP has been created for this and that reason. And so he can link them the talk, I guess, now. But other than that, I would say is its main use. Then sure, it's also useful because it tells you a bit about history, although that's an opinionated take about history. Like, I think one very important thing that one form of like social media, not social, sorry, one form of media literacy that you should have is that when you see somebody tell you about history, history that they weren't there for. Actually, the same applies even if they were there, but even more if they were not there physically at the time, is that they are relying on some data, some a trail of information that they find somewhere on the internet, and they are giving it an interpretation. And you can do a good job and give a good interpretation that is well aligned with what really happened. But first of all, it's never going to be 100% there. But in any case, it's not that a coherent recount of the past is necessarily strictly the truth. I'm not saying that Casey, is lying or anything. Not at all. But, you can make mistakes. You can give an interpretation to things that is very different than what really was. Like if you had been there, like, let me put it this way. If somehow you had a time machine and tomorrow you get access to a time machine and you can go back in time and relive all the moments that Casey talks about in his talk, will stuff really play out exactly as he described it? Probably not. Probably some of it will, some of it a little bit less. So my point is, while his talk is coherent and makes sense and does make a compelling case for tracing back the origin of object-oriented programming to something completely different to how it's being sold nowadays, and has been for the last 15 years, 20 years, maybe even more. Despite that, it's an interpretation. So keep that in mind. Did you watch it? Oh yeah, I did. I watched all of it. Yeah. I do, honestly, from my perspective, I do think that it is very realistic that OP stemmed from early simulations where people were trying to basically find ways of organizing a program in a way that would be suitable for a simulation. And so simulation then led to certain ideas about trying to structure the code in a way that matches the physical reality, because if what you're trying to create is a simulation, there are worse ways of organizing code. So it's a different first stab at it. And it does, I've used some programs that do simulation. Casey mentions in his talk operative research. I did operative research in university. By the way, out of curiosity, has anybody here in chat done operative research in uni? I had a fucking shit exam about it. Like, it was one of the worst classes that we had. I mean, the subject was interesting, but the professors were not good. So it was overall a shitty course, but a shitty class. But I did do it. Like, I did the simplex algorithm there. If you do operative research, you will touch also potentially tools that simulate, for example, queues and graphs where stuff flows around the graph, and you basically need the thing to find you like an optimized solution for a given problem. Like scheduling trains, scheduling tracks that move stuff around warehouses, where depending on how you like, these are optimization problems, serious optimization problems that are absolutely worth studying, and they tend to fall under operative research. Logistic simulations, yes. Operative research is about all this stuff. Yeah. And so that entire field is rooted in this idea of physical simulations. Not entirely, because sometimes you also can find analytical solutions to problems. And so obviously when you can find an analytical solution, that's preferable. But the analytical solution oftentimes comes from a mathematical model of a situation, like of your logistics, and you might lose something in translation there. Like your mathematical model might oversimplify something that it shouldn't oversimplify. I remember hearing about this a while ago. This is not something that I did study specifically, but I remember hearing about how I think it was it Amazon, was it UPS, but like one of those delivery companies in the United States would always have routes when driving in a city that made them turn right, never turn left, because turning right, it's easier than turning left. This is true in the United States. Maybe Americans in chat who wake up very early can confirm or deny this, but I believe that in the United States, on a red light, you can always turn right. You know, if there is a road on the right, you can always turn right. This is not the case in Europe. It's a weird rule. I don't know why you guys do that, but sure, whatever. So that is a factor that you need to account when estimating what is the optimal route. If there are two routes that have, you know, the same length in meters, sorry, I guess I should say in feet, then they seem equivalent. But if one turns only right and one turns only left, they are absolutely not equivalent. So an analytical solution needs to account for that. But if you have a physical simulation, it's easier to, not miss this aspect. I guess that's my point. So, so operative research does this kind of stuff. And it does make sense for, if people came up with OOP in that context, then it makes sense that they were trying to do something that is absolutely, completely, utterly disconnected from modern day OOP and what it's being solved for. And it's also true that the mainstream tech industry is selling you snake oil. But you know what? I guess that's our problem. Like in software, in a sense, doing software, you're changing the lights on a matrix of pixels, and you're selling that illusion as something concrete. And sometimes it is concrete, sometimes not much, right? We kind of are magicians that deal with illusion in a sense. And while on one hand, you would expect magicians that deal in illusions to be discerning when it comes to real versus what's real versus what's fake, the reality is that more often than not, people in a given field kind of are, they're also are victims. They also are bad at the same thing that they deal in a sense that they're, how can I say, they're like susceptible to the same ideas. So just like we sell these illusions, people sell these illusions to us. And so somebody sold the illusion of OP, just like they sold the illusion of the cloud. Again, some part of the cloud does make practical sense, for sure. But at the same time, it's the fucking internet mafia. It's literally like organized crime. It's a fucking shit show. So we've been sold a shitty idea of what open source software should be, and constantly are, and we keep buying it. So OP, chuck OP on the pile of snake oil that we keep talking about and selling to each other in our industry. It would be better if he did more research and interviewed people, but I think his interpretation is pretty good. I think his interpretation is compelling and coherent. And the problem with compelling and coherent is that it makes you think that it's true, even though it might not. That said, it doesn't matter. I just wanted to point out for completeness, but I do think it's a good talk. They were a little obsessed with traveling salesman problem for like 40 years in CS. But the traveling salesman is still a extremely simplified perspective on optimizing logistics. Logistics is much more complex than just traveling salesman. Let's see. I don't even think OP is that bad. It's just not good everywhere. And like a lot of things in software that get popular before it's thoroughly understood, it would be used poorly. It would get used poorly, pushed too hard as some de facto standard, etc. There's a lot of good software written in all languages. It's a common pattern in software I've seen. Something gets popular, people start saying it's the way TM. Lots of people start using it. Downsides start to become obvious. People start saying it's awful next. I think that's fair, but I feel like the way you're looking at this is missing one aspect that, in my opinion, is significant. There is an economic push behind pushing a certain approach to software development. So while OOP most likely, I would say almost certainly, gain some momentum in its own right. So it was an approach that people liked. It wasn't fully understood yet, the limits of. And so everybody was like naturally drawn towards it. I can see that totally happening. At the same time, there's an industry that has been built around object-oriented programming. There's one fucking guy that, like, his entire life is object-oriented programming, right? He sells books. He sells courses. He, what is it, Uncle Roger? No, Uncle Bob. A brief intro, please retweet. Cleancoder.com. The fuck is a clean coder? The clean architecture. I mean, this is just a guide. Okay, so it's not like, oh my god, we should like he's the one that ruined the tech industry. Not at all. But he's, I feel like, a clear-cut example of the fact that behind these ideas there's an economic momentum. And I think that some of the distortion that we have in our industry is because we allow companies that have monetary interest in pushing a certain way of approaching software, where they, roughly speaking, get money from. We just allow them to teach us how to do software. That's the problem. We as an industry have a very weak culture, and we allow slimy people to bend it to their benefit. In France, we have the turn right at the red light thing, but only for bikes, not for cars. We have it in Italy as well, but it's not based on specific rules of the road. It's just what people do if they can get away with it. Dexter Kitty says he's arguing against modeling everything as an object. It's 2 hours. Yeah. Is there already a way for people from EU to donate tax-free to ZSF? I don't have a good answer to this question. So the way I understand it, which again, the point is this changes from country to country. So depending on your country, my answer and my mental model could be correct or not correct at all. So the reality is that you need to double check with, tax law in your country, like talk to an accountant or something, if you can. If you have easy free access to an accountant. If not, don't pay an accountant just to figure this stuff out. I suspect it's probably not worth it. That said, do whatever you want. But the way I understand it is that when you donate, so the tax-free part of donations is that you donate and then you're able to use a receipt of your donation to get basically I don't know how to say this in English, but basically you have the amount of money that you get taxed on, and you can subtract that donation from the total amount of money that you get taxed on. So basically, in a sense, that donation is kind of like, if you were a company, it's like it's an expense, and so it's a cost, and you can expense it, and so that lowers the amount of money you get taxed on. Now, so the question is, what are the requirements in your country for you to be able to take a donation to some kind of nonprofit entity and be able to then have that money be subtracted from your tax stuff? And I guess that depends. As far as I know, for example, in Italy, I might be wrong, but the last time I checked, as I understood it, Italy doesn't even recognize non-Italian charities. So even if I were to donate to another European charity, I believe I would not be able to have that be a tax write-off. I might be wrong. I might have been right, and then things have changed. But that's the situation. And I think the reason why countries are fairly conservative with this stuff is because obviously, when it comes to stuff abroad, everything becomes much more touchy. It's easier for you to do tax evasion just by donating money to a charity abroad, that kind of stuff. So they They know that charities in their own jurisdiction follow a certain set of rules and go through some certain like standards of validation, so that donating to a charity in the country is known to not be a tax evasion scheme. And I think they are not sure about, they feel less sure about stuff that is abroad. Of course, within Europe, we should have some, European level thing that would be nice. I don't know. We probably need to stop voting dumb as fuck right-wing politicians that don't want Europe to be a thing. But so far, I don't know if we have this. I don't really know him. What do you mean, Temporus? You outed yourself. Wait, are you Uncle Bob? Tell the truth. Were you Uncle Bob all along? You also knew the name right away, huh? Faster than anybody else, huh? How comes? Huh? Do you prefer a monthly donation rather than a one-time, assuming equal size? Well, from an economics perspective, no. Money today is more valuable than money tomorrow, maybe. Even if they add up to the same amount of money over time. But let me put it this way. As the ZSF, what we like are tiny, inconsequential to you donations that you feel comfortable living there for a long time. So, for example, if a $5 donation or €5 donation doesn't really make much of an impact to you, and you feel fine with the idea of you just leave it there and you don't touch it for, I don't know, a few years, we love this. Obviously, $5 a month for 12 months, that's €60. So you could donate €60 today and it would be the same or better. But I guess the point is that since we are not like... we're not playing with the money too much. Like we look at our monthly influx of money, and we tend to be conservative when it comes to one-time donations, because obviously one-time donation is not something that you can count on always being there. I don't know. Usually, we like the idea of having this continuous relationship with people, where they support us lightly, right, in a way that doesn't really make it hard for them. And then at the same time we can count on them to be there for a while. That I would say is our preferred way. But I will admit that this is based on the fact that we're not like MBAs. If we were MBAs, obviously we would try to min-max the money, and one-time donation today that's bigger is obviously better than $5 a month for a few years. So, but we're not doing that. So that's it, yeah, I guess. I'm just wondering if you're trying to hit like a steadily monthly income for the foundation to support programmers contractors for the work the foundation needs, because like Wiki seems to like small monthly. I guess that makes sense. Yeah, so we're absolutely trying to do this. Yeah, in general, when somebody works for the ZSF and they want to commit to working for the ZSF more seriously, they obviously would want the ZSF to be able to offer them a contract for a while. So similarly, when we agree to somebody working, let's say the equivalent of full-time in billable hours, we only offer these to people when we know we have the ability to keep paying them for a long time. So we're not going to say to a contributor, oh yeah, sure, you can do full-time for 3 months, and then we're not going to be able to pay you anymore because we have exhausted our savings, and at the same time, our burn rate is superior than how much we make. So yes, for us having the main flux of money coming in increase, that allows us more easily to know to how many people we can give full-time contracts, the equivalent of full-time billable hours. I remember transitioning from procedural languages to OO. So I have a few Uncle Bob books, Martin Fowler books. Yeah. Do you have the Django 4 design patterns book stuff? At the time in web, and me personally, I was switching from classic ASP and PHP to .NET. Yeah, the .NET world loves that shit, don't they? I think it's part of why everything Microsoft fucking sucks. With all due respect to Martin, Bob, and everybody else involved. I worked at a Microsoft company for a while, and I always found my colleagues that were like the most into this stuff. I always found them misguided. Let's just say misguided. And you know what? I'll say something in defense though, because I've been very critical, and I don't want to sound like Casey. In defense of everybody involved, yeah, it's a technique, like Temporus said, and it can work and it can do okay things sometimes. I think though the problem, and I guess I'll say this, I should credit Casey because this is something that Casey says, which I believe to be very true, is that the problem is that the people that I just described as misguided, is that they hyper focus on the abstract teachings of OOP and clean code and hexagonal architecture and all these methodologies, and they lose completely connection to the ground. So they start pontificating on, should this component send this message to this component? Should there be a intermediate component between these two? And like sometimes this decision does have concrete consequences. Some other times it's absolutely completely useless abstract circle jerking that just adds indirection layers when it's not really needed. And they do that a lot. And then you use anything Microsoft and it sucks ass. It's like with a straw. It's basically there with a straw, power sucking on that ass. And and they're, in a sense, they're willing to pay that worse user experience in exchange for a more religious experience, like religious exaltation as they're writing the code. And I feel like that makes you for a bad software engineer. Hello, I'm Lag. Any exciting developments? I fixed my audio stuff. Nothing particularly exciting. We've been chatting about stuff though. I've been having a good time chatting with chat about things. People we've been talking about the OOP stuff, Casey's talk, and Uncle Bob and all this stuff. I'm about to fix another bug in Zine, and yeah, life's good. So, where is this stuff done? It's in... where do we compute these URLs? I think it's in the code where we analyze pages, and I think the page analyzing is in worker. And I think we can search for alternative. Here we can see that we're analyzing the front matter, but are we also managing the alt? No. There we go, analyze content. There we go. This is where we need to be. Let's see. Let's look at this big switch because this is the main core. Section directive, block heading, text, math text, that's fine. Code, that's also fine. It's a link. Yeah, in our case, it's basically the link case where we link to an alternative. So let's see, URL, self page. page asset, site asset. So an alternative link is a self page link. So let's see. Code. So I think this is our case. This value is only expected for link directives. Yes. So we're saying if it's not a link, then there's nothing for us to do for sure. Then if there's an alternative, let's see. Grab the alternative name, look at the alternatives at this page. If we find one that matches, we set resolved alt. We modify the self-page content to be alt.output. So resolved alt goes from, this was a string, right? Okay, so these originally contained the name as a string and now contains the output path as a string. Okay, so far so good, which means that in the specific case of the Zine website, what we have is this. This is our output, and it has a ending slash. It's an absolute path. So let's keep this in mind because this is part of our issue. So this is what we do, and then we break. So this inline else doesn't do anything else in that case. So what does this mean? This means that this analysis part is correct. And then the next time that we touch this stuff is when we are rendering Markdown. And this is where we're messing up, guaranteed. Hey, CodeCon, thank you for the $5 to the ZSF. Thank you very much. So in here we have self page. There we go. Here we're printing a URL, and we see a self page that can contain a alt or not. If it does, yes, we print link prefix, and this is what we're doing wrong. This is what we're doing wrong somehow. Yeah. Check this out. So we do print link prefix. So this just prints the link prefix. So this is what's wrong, I guess. And then we say A0 if the alt does not start with a slash. So if it's relative, we print the page. Otherwise, we print it directly. But link prefix always, the problem is the link prefix always ends with a slash, if there's any. Yeah, it always writes at least a slash. So this guy always ends everything with a slash. So the problem is here, if A0 is different than slash, then we print this. Will this end with a slash though? What does scan URL FNT do? Prefix trading slash. So this also consistently ends with a slash, which basically means they want to do this. And I think this will solve it. And we can test this locally, very trivially. Able to find Zine.z. Oh wait, this is the wrong thing. And now it's fixed. That was it. Okay, So with this, we have fixed it. And this closes 25. $25, right? Yeah. Okay. Uh, did I mess? Closes 25. Wait, does it not get recognized? Oh, and damn, it's on a different repo. Okay, let me fix this. Blurry Cat, now I understand your rant about .NET the other day. While a bloated pest, I hope to never have to touch this order again. You had to use C#? I'm sorry. Wait, what? Wait a second. Wait a second. So I expected maybe that there would be a mention of this issue in the other repository, but you can close issues with a commit in another repo? What? I didn't know this was supported. Good, I guess. And I'm also guessing it only works across the same like account, org, whatever. And so that random projects can't do this. I would expect, but cool. Typo. Syntax, syntax. Yeah, that seems fair. For Gore. No, that was a joke. Navigation. Linking. Brings. Okay. Okay, so I guess we need to make a new release of Zine for this goddamn bug. Oh man, I could have solved this earlier, huh? Let's see. A friend asked me for help on a ASP.NET project. I had to install a bajillion tools, yes, none of which work correctly, yes. The first time, yes. And I had to dig GitHub issues, yes, to find the workarounds, yes. Official Microsoft tooling, mind you. Oh, yeah, of course. It's Turbo S. You wanna learn something funny? Let me tell you about what Matt here in chat had to do to allow me to run Super HTML in VS Code. So let me tell you first the full history of well, not the full history, sorry. I'm not Casey. I'm not gonna give you a 2 hours long talk of the history of anything. But so just for some context, Super HTML is the templating language that I use my static site generator, and it's also a HTML language server. More specifically, it's a language server for my templating language, but you just disable. But if you run it on a normal HTML page, it just disables templating specific stuff, and it becomes a normal language server for plain text, plain HTML. It's not fully featured yet. There's a ton of work that I should do on it, but the basics work. So you install, the CLI tool, and then the CLI has a LSP subcommand to be an LSP. And you can configure your editor to run this LSP. With VS Code, you have to make an extension. Super duper. No, it's going to stay as super. With VS Code, there's an extension that I made to run the LSP, because VS Code, this I find interesting. Despite language server, by the way, that's another Microsoft moment. Despite language servers being something that Microsoft invented, Microsoft owns the language server protocol. Despite that, VS Code is unable to run language servers without an extension. you have to make an extension to support a language server executable. In all other editors, all you have to do is add a configuration line somewhere that says, look, for this file extension, this is the language server. Thank you. To be more precise, it's more like for this file type, and then a file type has known file extensions, and then you can say also an LSP. VS Code, no, you have to have an extension. So when I first made the extension, you had to install the extension, and then you had to get yourself a copy of the CLI tool, put it in path, etc. Isn't it just HTTP calls or something? No, it's not even that. It's a JSON RPC protocol that can run on standard input, standard output. Like normally when you run an executable, you communicate through standard input, standard out, and it's JSON RCP. Although, sorry, you're right. Maybe the fact that it has like these weirdo headers, it kind of looks like a poor man's HTTP. Yeah. In any case, so you had to do these 2 steps. So to make things better, I thought, wait, this fucking editor, it's a browser already. It has Node. It can run WebAssembly. What if instead of asking users to download and install and put in path the CLI tool, I bundle a WebAssembly blob into the extension so that you can get all at once? And spoilers, this is how it works today. Today in VS Code, if you get the extension, you don't need to get anything else, because you will get the SuperHTML language server immediately embedded in your extension. How does it work? It works like this. In source, in CLI, not in CLI, here on the root, I have the let's see, I have CLI.zig, which is the main file for the CLI tool, and I have wasm.zig, and wasm, it's just the LSP in its own main function, and the only thing I do is grab the wasm allocator as my GPA. That's entirely it. No other modification required. But what is the problem? Is that we wanted to make this work, but guess what? At the time, even though Microsoft had added support for running WASI stuff in WASI, as in WebAssembly plus the WASI interface for standard input, standard output, even though they had added this to VS Code, it wasn't fucking working. It was not working, and Amblag had to fix it. I'm going to my blog because I linked to the relative issue, and I forgot which it is, so I wouldn't be able to fetch it without going through the blog post. So long story short, they had a buggy implementation of standard input and standard output that would hang because they weren't doing the math right when reading, when basically re-implementing on their end the read syscall. And so it was completely borked. On top of that, they had this problem where they had a function that accepted as first parameter a string, and then as a second parameter a number, but then they were not passing the string, and that was causing the function to interpret the number as a string or something like this. I'm gonna read the I'm gonna read what Matt wrote, because this is insane, and I don't even remember exactly what the heck was going on in here. So the logic is completely bogus, blah blah blah. Initial loop doesn't actually increment the result size, so the loop is an op. No, where's the function stuff? There's actually a second bug here too. Pipe driver defines this stdin interface. The create is called exactly in one place in process.ts, with the add argument being this.stdin, which is a writable stream. However, writable stream does not conform to the given stdin interface, which doesn't directly expose any read method. Blah blah blah. I think there's more to this. Well, okay, so the point is that in any case, they were passing wrong stuff. And mind you, this is not JavaScript. This is TypeScript. You know, type, as in type safe. But apparently they were passing down the wrong type, and the thing wasn't complaining. And so the guy was completely flabbergasted and said, I opened this issue on the TypeScript side. You click the issue, and it says, basically, I guess given this code, let's click on it. So given this code, so class stream has read mode, question mark, and then you have an interface called stdin that has read max bytes to read number. Expected a compile error since the signatures of read are not compatible, and yet it does an error out. And then you go here, and so expected behavior, a compile error about incompatible signatures since a number can be assigned to max. And then the reply is, this is working as intended. Methods are bivariant. See this FAQ. Not even Microsoft knows how to use their fucking programming language. So, working as intended, man. Green light. That, you know what? This is the problem with Microsoft. Microsoft software is not bad. When you criticize Microsoft, they don't see it from your perspective. For them, it's working as intended. Dude, your thing takes forever to boot. Yeah, I know, but you know, I intended for foobar factory to have an interface generic parameterized by these things, and then we have automapper to copy all over the place every field 10 times left and right, and that is the behavior that we want. Sure, the user will have to wait 15 minutes for this fucking thing to boot, and other 15 minutes for it to shut down. But that part we don't really care about. What we care about is, does the foo factory work at full capacity? That's what we care about. And that is working as intended. So you shouldn't even be complaining. So like, dude, your language doesn't complain when you assign the wrong fucking method. It's like, it's just not compatible at all. No, working as intended. Okay. That's good. The Windows Terminal performance issue case we created is also fun read. Yeah, no, I dislike that one. That one I found absolutely horrible. I'll give you a short TLDR. Casey's complaints about terminal performance are completely correct, but he had no interest in improving the status quo of anybody's life, and instead just wanted to bitch. And to basically, I don't know if his intent was strictly to use that as a way of also not exactly gaining popularity, but like be theatrical about his bitching, or if he just wanted to bitch and then he happened to do that in public. But either way, he got into a fight with the Microsoft people that led to nowhere. He made a POC just to prove that they're stupid, and then he went and called them stupid, and that's where it ended. You know, instead, who did significantly better? You know who didn't bitch at who didn't go and like antagonize any Microsoft employee, did anything of the sort? Mitchell. Mitchell just made a better terminal emulator that now we can use. Is anybody using Casey's blazingly fast proof of concept? No, because it was never meant to be used by anybody. It was just meant to prove the point that the Microsoft employees are stupid. Sure, you can do that, but and like, if what you like is drama, if what you're selling is basically roughly the same thing that like 20-year-old Twitch streamers are selling to their 12-year-old audience, fine, then go enjoy the drama. But if you look at this from a more, in my opinion, important, mature, but also important perspective of actually, as a software developer, as a software engineer, making good software that improves the life of you, the people around you, also the people that are not really around you. That's also another nice thing about software. Then you don't make a spectacle just so that you can prove that, yeah, Microsoft employees are dumb. What a surprise. You instead focus on actually making things better. So you know what? I'll change this into, smaller scale to my personal experience. I have a lot of issues with Hugo. I've used Hugo. Hugo is a static site generator written in Go. I have a bunch of issues with Hugo. I like some of it, but I think that a lot of decisions in it are, maybe I don't feel them as being as stupid as Casey feels with regards to to Microsoft employees. But I do think that some decisions are short-sighted. You don't see me go on tirades on the internet and just to prove that Hugo is dumb, slow, and the people who make it are stupid. I made my own static site generator, and now I have a better experience. And the people who also have similar sensibilities to mine, they can also enjoy Zine and get that experience that they were looking for. They also get my bugs, but that's a different story. So I think this is why this is, in my opinion, Casey's biggest limit. That's what makes him, at the end of the day, kind of a mediocre celebrity, mediocre semi-celebrity, because he has the potential of being a much better teacher, not just when it comes strictly to the technical way of how doing things, but also to how to think about your ecosystem in a more general way. And he just doesn't do that at all. He goes and does this kind of shit. So, personally, I don't find it impressive. I find Ghosty significantly more impressive. Also, I can believe that Casey can make a terminal emulator that is much faster than the Microsoft one and kind of, dunk on all the Microsoft employees. Can Casey make a better terminal emulator than Ghosty? I don't know. Maybe. So what are we doing? Am I making a Xeon release with this last fix? You know what? Maybe I'll wait a little bit more. Is there any other issue? Because this issue was even on the website. It wasn't even on the actual Zine repository. So yeah, the Zine repository so far doesn't have any like real complaint about bugs. So I'll wait a little bit. Let me spend these last minutes adding a new feature to my GitHub action bot. Code owners. Yeah, so what is it I want to do? I want to add another option, another input, where you can say, I just want the bot to allow auto merge for people that are collaborators, and only them. If they're not collaborators, then we don't merge their stuff. So this is going to be my next one. Actually, it starts with a YAML, and here we say their merge method, and then we say collaborators only, and this actually defaults to true. Only merge PRs from collaborators. Ignore external users. and we default to true, which is also a string. How do people do booleans with this stuff? Can even they? I mean, I can put a true type here. Will YAML yell at me? Action.yaml GitHub. Quick start for GitHub Actions. Prerequisites, creating your workflow. No. There's false below. Yeah, I know that you can put booleans in YAML files, but that doesn't tell me if the thing that consumes this YAML file expects me to always put a string there or not. And also, here's another interesting thing. Look at how I fetch that value. In JavaScript, I get access to that value by using core.get input. And this thing is defined to return a string. Now, can you trust TypeScript to be honest about types? Turns out you can't. But so it seems that there is no yeah, it has to be a string, basically. That's what it seems. So you know what? I'll leave it. Since this thing gives me a string anyway, I'll keep everything as a string. I guess that's how it has to be. Parse code rules, PR is declared but not used. Oh, interesting. So I'm not going to use it. I'm going to take it out. Go to references. I'm using it here. I'm removing it as an argument. Then I'm, before I do any of this stuff, also this can go down here. This can go here. And here's how we do it. The submitter stuff we do right away. So here. And then even before we trigger these things, we check if the submitter is a submitter or not. Sorry, is a collaborator or not. Here we do the checking. And then everything else continues as before. So how do we check if it's a submitter, if it's a collaborator? It's something in OctoKit. It's something like OctoKit dot. Well, it's a request, so maybe we should make this a function. So let's do it like this. Let's just make it a function, I guess. Check if user check collaborator. We pass down OctoKit. We pass down submitter. And this is a signature. There we go. Function. Also, I'm thinking that we want to have main up top. So I'm going to leave main up top. And I'm going to move these guys down here, which is better. Okay, so then now we need to get the option and bail early. So get input collaborators only. Is that how I called it? Collaborators only, yes. And if it's not present, we do true. Then we say only. If only equals true, note the string. Actually, let's do it this way. If it's different than true, we return. And right, this is not like deciding to continue or not. So how do we structure the early exit? Because we want to early exit. We could like do stupid stuff like throwing an exception, but that's dumb. Let's return a boolean, I guess, and we do something like this: if check collaborator return. And so if only is different than true, we return true. Returns whether the main function should early return or not. So we return true, and then otherwise we do the check. And the check is going to be something like this. It's going to be one of those calls. Let me see another one. Something like this, maybe. We're going to need repo details. So we need octokit, we need repo details, and then we need submitter. Okay, and it's an async function because it does await. So we need to await it. And what else? To be honest, we could do all these things in parallel. But it seems inefficient to kick off these operations if this one returns false. So I think it's fine to make them serial to one another. So it's not repos get content, but it's something different. It's GitHub API repo collaborator REST, something like this, one of those things. List repository collaborators, no. Check if a user is a repository collaborator, yes. Octokey.request this path. God damn it, dude. Can you REST repos, no definition found? Really? But it's actually real. Go to definition, get content. Repos. Also, why is this like this? Why does the other one allow me to do dot? Why is JavaScript always like this? Octokit REST pools. Can you go to definition? Oh, you can go to definition on this. What do you know? Oh, okay. So there was some other problem that didn't allow me to go to definition. So I can do REST, go to definition. List outside collaborators. List collaborators. Check collaborator. The list of collaborators includes outside collaborators. Blah, blah, blah. Check collaborator. So there's a check collaborator somewhere. But what is it? What is it under? Repo. Repos check collaborator. Perfect. Fucking JavaScript. Fucking JavaScript. REST. I'm sorry, no, where is it? Here. REST repos check collaborator. Yeah. Oh, if only we had trading commas like in Zig, man. One can dream, huh? One can dream. Okay, what's in the response now? Why can't I go to definition here? I don't get it. I'm actually giving you OctoKit. Why can't you? Why are you like this? Oh, it doesn't allow me anywhere else other than here. Okay, so it's just dumb. Okay, the problem is that it's just dumb. Rest. Go to definition. Check collaborator. Returns what? Promise. Rest endpoint method types. Repos. Check collaborator response. Yes. Can I go see here? Rest endpoint method types. What are these people doing? Why is it like this? Responses endpoints. What does that even mean? But this is list collaborators. Okay, but okay, so we're back to check collaborators. Response if user is a collaborator. Status 204. But what do these fucking status codes become in JavaScript? Does it become an exception? Why does the example not even tell you? Like, it shows you an example of the request, but it doesn't show you what this becomes in JavaScript. Does it return void? Well, I guess maybe somebody in chat can help me test this out then after this. It just says operation. What is operation? Extract OctoKit response. Response is extends key of R. Extends never. Success response data type. Empty response data type. I'm guessing this is it. It gives us a status. I guess you can at least, it's something that you can ask status to, which is going to be a number. S extends number equal number. Right. So maybe we can do dot status equals 204. What if I do Stratus? Does he complain about Stratus? No. What if I cut this and I move it in main where there's more? Oh, there we go. Now property Stratus doesn't exist, huh? Can I go to definition? Can I? But if it's status, that exists. Oh, and it does bring me back here. Okay. So it seems that we were doing correct. Two or four collaborator, 404. 404 not collaborator. Okay. Let's double check everything. Returns whether the main function should early return or not. I think the logic right now is wrong. If let's call it collaborator early return, so that there is no confusion here. Okay, collaborator early return. If collaborators only is true, sorry, if it's not true, then we return false. We immediately know that we should continue. We should not early return. Then we check this, and if it's a collaborator, we want to... Should we early return if it's a collaborator? No. If it's not a collaborator, then we should early return because it's not a candidate for merging. Yeah, submitter is not a collaborator. Baiting. Collaborators only is true. Okay, so we go down here. It's not a collaborator. This is true. Return. Okay. You know what? In all honesty, having a function for this has netted us pretty much anything. I'm going to move everything here so that, because this logic is kind of like backwards and hard to follow. And it all is based on the fact that we have this like return that we would like to return from main, but we can't because we run out of functions. So let's just go here and just do return when we need to. And just call it a day. I'm going to make a scope for this so that it's clear that this is like a self-contained thing. Collaborators only. Collaborators only. Okay. If it is true, then we enter and we do this. We do the check. And if response status is different than 2 or 4, we return basically. We do this. No await. So we also saved ourselves from a stupid coroutine. Well, I mean, there's this await, so something had to await, but Okay, so only if only is true, do the API request. If the status is different than 204, we return early. Otherwise, we survive this block and the rest happens more or less as it was happening before. Okay, this is pretty much it, I believe. We need to change the README and then we're good. And then it's going to be time to do the Raytracing in a weekend. You know what? Let me do the announcements. Okay. This seems nice. This overall seems a fairly sane extension, honestly. It does pretty much what it needs to do. It doesn't do too much dumb stuff. The worst part of this is this. We are doing a style of matching that is absolutely horrid. But at the same time, it's not easy to improve on this because even though checking linearly things um, is not optimal, you can't just merge all these patterns because you need to keep around uh, a concept of priority. So you need to basically, to make this better, we would need to build a tree out of all those patterns while also keeping track of their priority and then the users that are attached to each one of them. It could be done. But I also suspect that in practice, for most purposes, having a suboptimal algorithm here shouldn't be the end of the world. So I'm not going to attempt that. Okay, I believe that this is it. Actually, I have my, right, we need npm run this also. And I'm going to go in temp test. Did I do it again? Yeah. Okay, let's see if the bot still works and doesn't poop itself horribly. Submitter is not a collaborator bailing. Technically, I'm not a collaborator. Technically, I'm the owner, I guess. Still. Okay. Oh, there we go. Covers only true. Uncaught exception, pull request is not mergeable. Why? Let's take a look at the PR. Is it really not mergeable? There's a conflict. Okay, so, I mean, we did attempt, so it works. Ooh, can we add a map also? I want to attempt the generating a map. So it's in here. How does it work? Okay, let me exit from here. Package.json, ban build help. I guess we can minify. At this point, we can minify and have a source map, build source maps in line. Okay, let's try. So, minify source map inline. npm run dist. It worked. Yeah, index.js is much bigger than it was before because it now has the source map in it. What was it before? Yeah, it wasn't even a megabyte. Now it's 2 megabytes. And obviously the minification would even help with that. But what's happening now is something different. Now I'm curious to see if we're getting something better now in this stack trace with the source map. Let's see. I would expect that it works, and it gives me a better stack trace from that exception. That exception is still going to be there because, because the problem is still there. And it does not. Maybe we need to... The fuck are we supposed to do, man? Oh, God. Okay, let me try to run this again out of curiosity. But I don't know. Let's say that we ran this too early and we hadn't committed yet a new version of this thing. But like, how do you load source map? Let's see, GitHub action source map. So no, the source map doesn't work. GitHub action source map. Sentry source maps. New relic. Maybe there's an option in here for source maps. But this is the workflow syntax. No, I want the action.yaml. Oh my fucking god. Actions import a reference. Custom transformers. The fact that the source map is embedded, it doesn't get picked up, I find kinda sus, honestly. So this is all well and good, but where's the creating a third-party CLI action? But why does it say CLI? What does that even mean? Get version of the tool to be installed, download a specific tool, extract the tarball into the runner, expose the tool by adding it to the path. Okay. Module.exports equals setup. We don't do this. Hopefully it's fine. Exit codes for actions. I guess this is it. Publishing. There we go. Each repository must contain a single action made a data file action.yaml. Badges, but it doesn't tell you the syntax of that fucking file. So this is driving me insane. It's not telling you. So in here, it mentions action.yaml, but it doesn't tell you what the syntax is supposed to be. There is no link. Reusing automations. It doesn't tell you what's supposed to be in there. This is insane. GitHub action.yaml reference. None of these things is the reference documentation. And I want this in quotes. It's action.yaml, not something similar. Just I want the action.yaml docs. Metadata syntax reference. Workflows in action, and then there's metadata syntax reference. Okay, so this is it. Name, author, description, inputs. Yeah. Example, specify inputs. This example configures two inputs, num octocats and octocat eye color. Oh, they use dash instead of lowercase. I think I'll go with lowercase. Insert an input, blah, blah, blah. Runs. Example using node 20. Maybe we should use node 20. Maybe we're using a node that is a little bit too old. I don't know why I have node 12. Like the original stuff that we were looking at was doing node 12. And so I didn't question that choice. I should have questioned it. We should question everything, shouldn't we? So let's upgrade to node 20 and see what happens. In the meantime, I'm going to push. And let's see, using runs main pre allows you to run a script before the start of a job. Oh, like pre main post, right? Pre if. Oh, right. Interesting. There's also if post if runs for composite actions. Yeah, okay. So there's steps. Okay, so this indicates that you're doing the other one, which is just YAML. Okay, sounds good. Doc. Okay. Branding. Okay. So there's no mention of source map stuff at all. Hopefully using a not obsolete version of Node will make it better for us. I should also test the module equals. Yeah, no, maybe embedded source map is not supported. Let's see, bun build help. Build with source maps. Linked, inline, external, or none. Linked? Maybe? Oh, out there defaults to dist if multiple files. Okay. Banner. Add a banner to the bundle output such as use client for a bundle being used with RC's footer format. Defaults to ESM. I don't know what those things do. Splitting, enable code splitting. Root directory useful multiple enter points. Public path. Set node amp equals production enable minification. Is that linked? I don't know. Maybe linked will do something. There's also external. Now we have index.js and index.js.map, which is what I expected. Hopefully now it gets picked up. You know what we don't know? If Node even does source maps at all. Maybe there's something that we need to do in Node. Support natively. Enable source maps, flag to enable them. Node options equals enable source maps node. So it's a flag. So since it ends with source mapping URL test.js map, we have it. We definitely have it. So Node source map support. Add source map support Node.js for stack traces. Yes. Enable source maps, but GitHub does not enable source maps, does it? Okay, I think it's starting to, you know what? Let's add a final like 10-minute countdown. Raytracing starting, and then we're gonna start for real, just to give people time to join. So we have these. So Ban has done everything perfectly as needed, but GitHub is not loading it. Runner image operating system runner blah blah blah. I don't know. Hello, Lil Boo. Are we developing something that allows the PR to be able to merge if the submitter is a code owner of the file? Correct. I actually have it already. It works. But I'm bundling my extension, my dependencies into a single file with a ton of lines in it, and so that you don't have to download node modules. But the problem is that that gives you shitty stack traces, because whenever there's a problem, you get an error online 54 columns, column 121,000. And so usually to solve this, there's a thing called source maps. And I'm generating source maps, but GitHub Actions somehow doesn't load them. So somehow you Node is not loading them, even though not even in the inline method they get used. So I don't get it why GitHub doesn't do that. There's no source map written anywhere. Why? Source map. Like nobody complains about this? Oh, but this is not this is not the runner. This is different. Yeah, it's a skill issue. I agree, but still, starter workflows toolkit, JavaScript action. For example, how can these kind people do they set up source maps in this thing? Node 20 dist index. Let's see how let's see what they put in dist. They have a source map in here. Okay. They have a source map. Is in there package.json? Type a module. Exports. They have exports in here. I don't have exports. Scripts. Bundle. npm run format write. npm package. npx rollup. I don't know. They have so much garbage in here. Okay, so far, these are the only things that I don't have. I don't have exports. I don't have engines. Everything else, I believe, is pretty much the same. I also have in my dist the source map. Do they link it at the bottom of this file? Come on, dude. Work hard. Yes. Oh. Istanbul. Istanbul. In any case, they also call run at the end, so that's the same way I do it. And they do generate a source map. There's really nothing else that you could do, right? Actions. Do they run this thing? CodeQL, merge, check transpile JavaScript. Set up Node.js. Install dependencies. Build this directory. I have this stuff all generated correctly on my end. It's just that GitHub doesn't load it for some reason. So did you do source map support.install? Is this something you have to run inside Node.js? So if we look at if we look in dist loader, do they have this in their JS? Let's check. Source index.js. Istanbul ignore next. Okay, man. Get input. Set outputs that fail. So here's just business logic. They don't have this. Okay, let's see if they have it in dist. Source map support or install. There's no mention of source map support. Let's look at all instances of source map. Yeah, rollup config, source map true, but this is their build stuff, and I built it. I have 7 pull requests that mention this stuff. Fix source map. This PR fixes source map generation to remove the warning about the rollup source map option. It also adds an example workflow for caching and validating dependency licenses using license D. Commits, fix source map and add merge pull request, fix source map and add license D. So I think that they generate source maps, but they don't expect them to work or something. This seems insane to me. I guess I'm gonna put them in line and call it a day. And then, I mean, they're there even though they are not being used. Honestly, what do you do with source map in line if you can't even use it, right? Might as well just do this. Seems insane, but you know what? No, I'm gonna put source maps in there in case that they eventually decide to turn it on and stop being dumb. That's it. But it's pretty fast though. You gotta admit that it's pretty fast. I believe that I was using something else in the past to do bundling, and yeah, it did not take 12 milliseconds to bundle stuff. Something that is probably not even as well, I don't know, comparable probably. So yeah, this is it. It works, but we get shitty stack traces and such as life. Okay, so it's ray tracing time, I guess, for real. Okay, so here's the plan, chat. I'm gonna get up, get something to drink, and I'm gonna eat a bite. Nothing crazy, just like quickly. I'm gonna take like 30 seconds, and then we start. I think we can close all this stuff. And it's time. It's finally time. Also, you know what? I'm going also to point it out in places. Okay. Okay, I'll be right back. Okay. So here's how we're doing it. Let me see. Hello everybody. Hello all the people that joined. Yes, we are about to start doing ray tracing in a weekend. So I'm just gonna need a few seconds to set up recording. I just want to record everything because I'm probably gonna do. So the last time we did this, we did to do what's called Christos. So we did operative system in 1,000 lines of code, and there's a repo, and I recorded also the VODs so that you can basically, if you want, you can follow along, or like you can do stuff on your own, and then whenever you feel like, oh man, I don't know how to do this part, I need some help, then you can look at the video and see how we tackle that part. And I think I'm gonna do the same for ray tracing in a weekend. So that's why I want to record. That being said, if anybody has questions, by the way, I don't know anything about ray tracing, so I'm gonna learn as I go, just like people in chat here. So if you have questions about Zig, I can answer them. If you have questions about ray tracing, I'm gonna be able to answer as I learn. If you're somebody who has done this already, because a lot of people have done ray tracing in one weekend already, and you happen to hang out and be around as I do stuff, please feel free to give suggestions. As long as you're not like spoiling stuff. Maybe I don't know how this is structured, but if the book like follows a style where you make something and then you improve on it, then do give me suggestions, as long as you're not basically making me do what the book is gonna make me do it a few chapters below. That's it. Yeah. Chris RTX. Should we? I mean, we started giving dumb names to these things. We might as well continue, right? Soapbox, Rager, I'll take your suggestion. Chris RTX it is. Let's go to GitHub. Oh, wait, I need to start recording. Also, I need to make sure that we don't record music because yeah, so audio properties. We're not sending it to track 2. Are we recording from track 2? Video, general, output, recording. Twitchbot uses track 2, yes. But what about recording? Oh no, recording has track 2. Okay, never mind. So we can't do that. Can be Chris RTX until you have it running on the GPU. Lore RTXs. Okay. I know that's fair, but I'm gonna do it anyway. It's fine. The NVIDIA police can come find me later, I guess. So create a new repository. Chris RTX. Description. Ray tracing on a weekend in Zig. Done in Zig. I'm gonna put quotes also so that people know that it's a thing. Public, add a readme, git ignore, Zig, license, MIT, create a repository. There we go. Copy. Okay, shall we clean up some stuff? Man, I have so much stuff open, huh? There was a Redis server running in the background, apparently. Okay. So because of that, we have to stop music. So stopping music. Go here. Okay. Start recording. Okay, everybody behave. You're now being recorded forever. Everything that you say now will be, set in stone forevermore or not. We'll see. In any case, so we're starting ray tracing in a weekend. I have never done any ray tracing stuff. I don't know how it will go. I saw briefly that the code samples are in C++, so I'm gonna I will have to translate them to Zig, and we'll see also how that goes. I'm not a C++ programmer. Also, I have a vague idea of what some of the constructs look like. Some stuff I will have to learn on the fly. Maybe chat will help me decode, some of the most intense C++ isms. And this is the second time I'm attempting to do something like this. The first time was OS in 1,000 lines of code, which you can find both on YouTube and on GitHub. On GitHub, you will find the source code. There's links to the VODs in the README. I don't know if the VODs link to the repo. They should. In any case, I'm Christoph-IT on GitHub, so you can find all the stuff there. The repository for the OS in 1,000 lines is called ChristOS. This one is called ChrisRTX. It's a silly name, but apparently that's just how we're running with this stuff. Okay, so let's get started. Overview. I've taught many graphic classes over the years. That's not me, by the way. That's the book author. Often I do them in ray tracing because you are forced to write all the code, but you can still get cool images with no API. I decided to adapt my course notes into a how-to get you to a cool program as quickly as possible. It will not be a fully featured ray tracer, but it does have the indirect lighting, which has made ray tracing a staple in movies. Follow these steps, and the architecture of the ray tracer you produce will be good for extending to a more extensive ray tracer if you get excited and want to pursue that. I guess that's basically what you do with the follow-up books, Ray Tracing the Next Week and Ray Tracing, a lifetime dedicated to ray tracing. That's the third book. When somebody says ray tracing, it could mean many things. What I'm going to describe is technically a path tracer and a fairly general one. While the code will be pretty simple, let the computer do the work, I think you will be happy with the images that you can make. I'll take you through a ray tracer in the order I do it, along with some debugging tips. By the end, you will have a ray tracer that produces some great images. You should be able to do this in a weekend. If you take longer, don't worry about it. I use C++ as the driving language, but you don't need to. However, I suggest you do. I won't, because it's fast. It's not. Portable. It's not. In most production movie and video games, renderers are written in C++. Unfortunately true. Note that I avoid most modern features of C++, good choice, but inheritance, bad choice, and operator overloading, bad choice, are too useful for ray tracers to pass on. God damn it. Okay. I do not provide the code online, but the code is real, and I show all of it except for a few straightforward operators in the Vectory class. I'm a big believer in typing in code to learn it, but when code is available, I use it, so I only practice what I preach when the code is not available, so don't ask. I have left that last part in because it's funny that what a 180 I have done. Several readers ended up with subtle errors that were helped when we compared code. So please do type in the code, but you can find the finished source code for each book. Okay, so they have it on GitHub. Okay, we're not gonna look at that stuff. And also the implemented code for this book, our philosophy for the included code prioritizes the following goals. The code should implement the concepts covered in the books. We use C++, but as simple as possible. Our programming style is very C-like, good, but we take advantage of modern features where it makes the code easier to use or understand. Our coding style continues the style established from the original books as much as possible for continuity. Line length is kept at 96 characters per line. To keep lines consistent between the code base and code listings in the books. Okay. To be fair, doing this without operator overloading is painful, a lot of vector math. Well, we'll see how it turns out when I do it. I mean, I get the idea in general, but I don't know. We'll see. The code thus provides a baseline implementation with tons of improvements left to the reader to enjoy. There are endless ways one can optimize and modernize the code. We prioritize the simple solution. We assume a little bit of familiarity with vectors. Yeah. If you don't know that, do a little review. If you need a review or learn it for the first time, check out the online graphics codex. You know what? Keep it open in a tab. Never hurts. Fundamentals of computer graphics, blah, blah, blah. Okay, project README for information about this project. Okay, I think we can continue. I'll put an image. So that's our starting point. By the way, there is also another thing that I saw recently about ray tracers. So you know what? This is just one small one small aside, and then we can go back to the book. Has anybody seen recently? There was a video on YouTube that I saw about somebody making a game engine where they use ray tracing with audio, with sound. Does anybody remember? So, let's see. Ray tracing audio. I don't know if it was this. Ray trace sound on the GPU. I think this might be it. Let's see. No, the one that I saw was an explanation. So I guess it's the same idea. But there was a video that basically explained how all this stuff is achieved. And it might be the first one, actually. Maybe YouTube did give us a good suggestion. Yeah, where basically they use... Yeah, they use ray tracing. And they use that to understand how audio should sound. How everything should sound. It's really cool. I guess my point is... apparently the title is A First Look at Ray Trace Audio. So I guess the point is that ray tracing is an interesting idea that obviously makes sense with light, but that you can apply to other things that aren't just light. I guess anything that is some kind of wave that propagates is a potential candidate for being modeled this way. Yeah, apparently doing it with sound also yields its own benefits. Okay, so let's start with the work. I'm gonna do zig init. Oh, we don't have -m, unfortunately. This would have been a good candidate for zig init -m. So we get a good zig init. It makes a distinction between main and root. We don't care about root, so I'm gonna remove source/root.zig. I'm gonna go into the build script, and the build script this is the version that has a ton of comments and teaches you about everything about the build system. We're not learning about the build system right now. If you want to learn about the build system, I have a video where I explain how to do that. So we're gonna select every comment. Delete it. And then let's see, we have module, we have the executable, sure. Wait a second though. I think I might have deleted more stuff that I wanted to delete. Wait a second. Yeah, I deleted also the root source file. How did that happen? Let me see. S, and then we do... Oh, wait a second. Was I just looking at the wrong thing? So why is this? Okay, so I don't know. I did something wrong earlier. Okay, so this is based in root. We don't care. So we don't do this. We don't do the import. We just have main.zig. Who knows? Maybe we decide that then we'll need this in the future. But for now, we don't. So take this out, take this out, take this out. That's it. Let's see. Do Zig SMD vectors support addition, etc.? Yes, they do, but they don't. But they don't support like vector style operations. So everything is a dot operation, I believe. And there is no matrix type. So there's also that. So long story short, if you're doing graphics or like anything where you need vector matrix operations, you need to implement them yourself, or you can use a library that implements them. There's Zigmath somewhere. You know what? Maybe we could consider also using a dependency to get this stuff implemented for us for vectors. We'll see though. Maybe the book guides you towards some of that stuff, and so we can just do it ourselves. Okay, so let's see. I have the build script. I have my main function. The main function has some stuff in it that we don't really care about. So let's remove this stuff. Let's see if it works, or if I left a build error somewhere. It runs. Okay, so we have our main function. Okay, next, let's continue here. Whenever you start a renderer, you need a way to see an image. The most straightforward way is to write to a file. The catch is there are so many formats. Yep. So what's the format that we're using? PMM. Plain text PMM file. Let's see. An example of a color RGB image stored in PMM format. There is a new line character at the end of each line. So, it's literally ASCII numbers, zeros. I'm guessing the alignment is just there for convenience and doesn't have a meaning in the format. PPM. Yeah, PPM. PPM. What? Let's make some C++ code to output such a thing. So main function, image width, image height, loop, and then what are we doing? We are double I divided by image width -1. This is also auto. So I'm guessing also, wait, what? And then this is all multiplied by 255.999. Okay, so we're basically taking the index, we're dividing it by the width. We are normalizing everything over 0 to 255 or 266. Like in any case, we're normalizing it over this range, which I guess makes sense. I guess this is int, so we're truncating. And then we are printing IR space IG space IB RGB. Okay, so like, yeah, integer. Okay, let's implement the same stuff. Const width wait, what was it? 256. Okay, 256. Same with height. Then we need to loop from 0 to them. So for 0 dot, what do we do on the outer, width or height? Oh, it wants height. Oh, it always puts height first. Okay, height for 0 dot width. Then we are, so they're using INJ. Why would you use INJ when you have width and height? Why would you want to use H and W anyway? So it takes I, divides it by, it takes W and divides it. No, wait, it takes, oh yeah, no, it's the inner one. Okay, so it takes W, divides it by width -1, and that is supposed to be a float. But X and Y is what you would use. I mean, in this case, H and Y seems, H and W seems good. So, sorry, wait, we're doing this for, we're doing this for red and green, and blue is just hard-coded to 0. Okay. So const, let's see, red equals, we said H divided by height -1. And this, we also want to then we want this to be a float operation. And then we want to multiply it by 255.99 and then truncate to int. So let's do this. This is going to be, I don't know, usize. Then we need to do this. And so we need to do float from int. I don't know if the subtraction will yield us a float operation, a float number. I think it should, because this one is an untyped constant. We'll see though, I'm not sure. So we have the float operation. Then we want to do 255.99 times this, right? And then we want to int cast everything. Should be U8. That's fair. U8. And we want to int cast, and we want to, I guess we want to floor it. So, is it just floor? Yeah, floor value returns the largest integral value not greater than the given floating point number. Okay. Just multiply int by 255 and divide by height, and that's it. I think you're right. If we do that first, it should be the same, right? Yeah, let's, you know what? I'm gonna follow the book more precisely. Let's see what this shows. And then we can, float from int must have a known result type. Oh, fuck. That is annoying. You know what? That alone might be a good reason to do what you're suggesting right away. Yeah, this is kind of backwards, isn't it? Yeah, you can use add as, but generally speaking, I personally don't like using add as. Like if I add to, I would do this. FH, like float H, and I would do this. And then I would plug FH here. That's how I would do it. Let's start with this, and then let's do what Andrew is suggesting. There's no F32 from int. No, it doesn't work that way, because the way it works is that float from int understands what the target is from the result information. So originally, float from int took a type as the first argument. So you could do F32, and then you would pass the value that you wanted to cast to first 32. The problem was that this syntax has a it has a foot gun attached to it, where you could do something like you at some point, this maybe used to be float 32s, and then you want to change this to float 64, and you forget to change a float 32. You know, maybe the expression is more complicated, and you forget it in the middle. You're casting something to float 32, and then these two things go out of sync. And you don't realize that. So you did want to upgrade to F64 because you wanted the extra precision, but now some of your math doesn't have that precision because it's still stuck to F32. And casting an F32 to an F64, like in, coercion, succeeds, because every F32 can be represented as a F64. So this is the problem. The problem is that if these operators allow you to write down what the target type is, then you could have surprising, like coercion could hide some bugs. While with this system, there is no way for these two things to go out of sync because they have the same source of truth. It's annoying. It's annoying as fuck. I get it. But this problem is real, and this mechanism solves it. Okay, so RG RGB. Next. Oh, these are the I versions. Okay, and then we just print them with a new line. So we need an output file. Oh, wait, it doesn't even print to an output file. They just print to standard out and then do redirection, don't they? CMake? No, dude. What are you talking about? The fuck is this? No. Okay, in any case, you then redirect to a file. Okay, that sounds good. So we need access to std out. And we want to buffer because otherwise this thing is going to be slow. I don't know. Maybe going forward if we do bigger resolutions. You still need in from float. I mean that's what floor does, doesn't it? Doesn't it go to int? I think there's a floor to int that goes that truncates. Maybe this is not it, but I believe there is a built-in that does that. Same type as given. Okay. So not documentation. So let's see what we can use. Int cast, int from bool, int from error, from float. Let's see. Converts an integer part of floating point number to the result type. If the integer part of floating point number cannot fit in the destination type, safety check illegal behavior. Okay, so maybe we can just do this instead of floor. Let's look at seal. Oh, there we go. There's also trunc. Let's see trunc. Rounds the given floating number, point to an integer towards 0. Uses a dedicated hardware instruction when available. Let's trunc. Oops. Okay, so we need to print the standard out. Look at trunc signature. God damn it. Oh shit. Okay, never mind. Even round? But you know what? Let's leave it there. Let's see. I want to see the compile error, and then I'll fix it like you guys suggest. Why is it using 255.999 and not 255.0? Is it some weird precision thing? I don't. Probably. I'm guessing there's a reason why they do this. People in chat maybe can answer this while I fix this code. Actually, no. It's fs.file. Std out. No definition found? Are you kidding me? Oh, wait. FS. What am I doing? Okay, we get std out. That gives us a file, and then we need to have a writer. Can we do std out.writer? Yeah. The interface, right? Yep. Okay. Is this new IO? Yes. Not all of it. This more precisely, this is new reader writer. The new reader writer interface. Rest of IO is not yet in master branch. It's coming though. It's coming soon. So out.print. You want to print where said one thing, and yeah, digit space digit space digit, and we could even do the alignment. I don't remember how the alignment works. It's, I believe, what is it? Space greater 3, something like this. Like you say the character you want to put there, you want the alignment, the side in which you want the alignment, and then the number of seats. You know what? We can try this out and see how it works. And honestly, also maybe we don't care about how nice the file looks like, but RGB. There we go. Zig build. Prominent compiler errors. Watch. Let's keep watch open. Yeah, expected W8 found F32. Okay, confirmed. This is a problem. So in from float. Next problem. Except the type IO writer found const writer. Oh, yeah. Error union is ignored. Yes. Okay, so we built. PPM was right. Do we have an PPM viewer? Cannot be opened. It may be damaged. Oh no. I don't know if we have a viewer at all on macOS. Later, it would be better to run optimized builds for speed. In that case, you would, yeah, sure. Oh, there we go. Toy viewer on my Mac. You're missing the PPM header. Am I? Oh, you're right. That's what was printed here, wasn't it? You're totally right. That's definitely what's missing. Good point. So what is this? This is try out.print p3 new line image width space image height. Oh, wait a second. Wait a second. Is this being printed in binary? No, because this is printing. This turns numbers into text. Okay, thank you, C++. Okay, so it seemed weird, but I just wanted to make sure. So new line, and then 255. I guess that's the range. And then new line. Okay. What did we mess up? Memory function expected 2 arguments, found 1. Right, where right, there's a bit of a problem, huh? Height, width. Is this what we expected to see? I think not. I think we might have done something wrong. By the way, I also have these this thing here, which might or might not do good things. So let's see what's happening here. Yeah, it's there's a double zero. Wait a second. No, that's like this. No, not open. I'm gonna stop messing with oh no, reloading killed my editor. Hello? Oh god. Missing new line in the loop print? Am I? Oh, I think you're right. Yeah, that's a problem, huh? Why is my editor dead? Helix, come on, man. Why are you like this? That's crazy. This is also gonna kill my AMD. Wait, what? It's still here. Oh no. Well, you know what? Let's imagine that this never happened. Let's start again from scratch with the editor, I mean. So maybe I was right then with this the first time. I think the new line is wrong, right? We don't want a new line. We want the new line only. Wait, new line always? Wait a second. This does not sound right. This is doing a new line every time it prints 3 numbers. While here, this is doing, well, not this. Flash. Good point. We also need to flash, yes. But, you know, this screenshot here seems to suggest that, oh no, you know what? This is a 3x2 image. And it's not really, I guess new lines are not important. 3 columns and 2 rows. Maybe they are. Maybe any space works. Yeah, maybe any space works. Yeah. Oh, all white space is equivalent in ppm. Yeah, there we go. That makes sense. Let's do this. Let's see if I'm getting the alignment correctly. In any case, okay. Still black though. So the numbers are indeed changing. At least some of them. No, actually they are all changing. So this is correct in terms of, well, numbers moving around. Also, look, this is doing indentation correctly. It's adding 2 extra spaces to keep everything aligned. So this is good. Although it does not seem to be doing it for, wait, I need to cut it again, I guess. Yeah, okay, now it's doing the extra spaces also for this guy. Wait a second, why does it end like this? Did you specify the color range? I think I did. It's just 255, right? I'm curious though. Oh, right. We need to flash, by the way. So yeah, the problem here is that we're not flashing. So to do, as we're here, out.flush. Also, suggestion for people who program in Zig, you do not do this. I know that it's tempting to say, well, okay, here I have my writer, and then I'm going to defer flushing, but you can't, and you shouldn't. First of all, flushing can return an error because it's an IO operation that could fail. And then in defer, you can't try, because try is something that makes you return. But if you're running a defer statement, you're already returning, and you can't change what type of return you're doing. You can't change the return value. So then you say, well, then I take try out and I do catch, do nothing. That works, kinda. Like, sure, now it compiles. But generally speaking, you don't want to flush if you encountered an error before. The idea is flushing is you finalizing the write. And if you had errors earlier, it's kind of wrong for you to attempt to flush afterwards. Something already went wrong. You should leave that stream alone. Okay, there we go. We got it. We just needed to flush. Delightful. Okay. Let's see. Creating an image file. Yeah, we got this. We don't even need toy viewer. It works on macOS itself. Let's see. Hooray, this is graphics hello world. If your image doesn't look like that, the output file text or blah, blah, blah should look like this. Yeah. We didn't have everything nicely aligned. Can I open it in this editor? Will it poop itself? No. Okay. Yeah, look at this. This is nice. Yeah. Yeah, this is nice. Okay. Next, to do adding a progress indicator. Before we continue, let's add a progress indicator to our output. This is a handy way to track the progress of a long render and also possibly identify a run that's stalled due to an infinite loop or other problem. That's fair. Our program outputs the image to standard output. So leave that alone and instead write to the logging output stream. Okay, so here's how we're gonna do it. We have a nice thing called const progress equals std.progress. Actually, it's uppercase, isn't it? Yeah, it's uppercase. So progress, and we can use progress to well, as the name implies, signal progress. So let's do this. How do you use it? I don't remember how you use it. Start. Initializes a global progress instance, asserts that there is only one progress instance, call node.end when done. Okay, what are our options? We need to pass in a draw buffer, must be at least 200 bytes. Okay, so we're going to pass in a buffer. And I think the rest of the options are kind of fine. Oh, there's also a root name that we can put here. And there's also an estimated total items, which seems good. So let's see. So up here, we do PR equals progress dot start, and we're going to need to pass some options. Var pbuff progress buff 1024 U8s. What's the name of the option? I forget already. Draw buffer and then root name are the ones that we care about. Draw buffer equals pbuff. Well, for now, I think this is fine. And then we defer pr.end. Yeah, finished a sort of node, thread safe. Okay. And then we have the estimate, right? Estimated total items. Estimated total items is, I guess if we move these up here, you know what? Maybe we can even take them out and use them as global constants. Then we can say that this is going to be height times width. And then I think it was a root name. Raytracing, I guess. I don't know. It's not stdr, it's stdlog. Yeah, fd3. Man. Okay. So we have this. The problem is that we're not starting like a new progress every time we enter here, which, by the way, it's probably a non-insignificant amount of overhead. So this is probably going to make more sense once we have a less tight loop. So for now, I'm just going to leave it here. You don't even see it. Like, you don't even get to see it. It's just too fast. So let's worry about this later. And in any case, they also print what? Yeah, look, they also print this also in the only in the outer loop. So they make progress in the outer loop. We're going to tweak this as we proceed. It's fine. Vec3 class. Almost all graphics programs have some classes for storing geometric vectors and colors. In many systems, these vectors are 4D, 3D position plus a homogeneous coordinate for geometry, or RGB plus alpha transparency. For our purposes, the 3 coordinates suffice. We'll use the same class vec3 for colors, locations, directions, offsets, whatever. Some people don't like this because it doesn't prevent you from doing something silly like subtracting a position from a color. They have a good point, but we're going to always take the last code route when not obviously wrong. In spite of this, we do declare 2 aliases for vec3, point3 and color. Since these 2 types are just aliases for vec3, you won't get warnings if you pass a color to a function expecting a 0.3. And nothing is stopping you from adding a 0.3 to a color, but it makes the code a little bit easier to read and to understand. Okay, so let's see. Well, now, oh man, now it's time for these operations, huh? Yeah, that sounds good. That sounds great, actually. Let's do it. I'm tempted to make a new file for this. Maybe you can call it math.zig or vec3. This is how to write ppm faster. Yeah, so right, this is your solution where you do the multiply first. That makes sense. Yeah, P6. Oh, it's binary instead of ASCII. Oh, that is interesting. I did it. I didn't. I did miss out that nuance. Yeah, you're right because you're not writing ASCII. That seems a nice improvement. I guess the problem is that it doesn't allow you to inspect visually what's going on with the file format, huh? But at the same time, if you don't do terrible mistakes, this thing seems easier. I'll keep this in mind. Thank you. I'm gonna open this, keep it around, and if at some point we need to upgrade, we're gonna upgrade. Okay, let's do so vec3 or math. Let's do math.z for now. Okay, class vec3. You know what? Can I rename this file? Yeah, you know what? I'm gonna write it also as source.vec3.zig. And then I'm gonna delete math later on so that we can use a top class struct at this point. So here's the idea. Vec3 has an array of 3 doubles. Is that how they do it? Or you can do move. Oh, thank you. I didn't know. Yeah, I searched for rename and nothing showed up, so I stopped there. I use a vector for my RT. So you did it like this, right? So you did so it's a struct, and then we put in here call it E. What do we call it? Let's call it V, I guess, in our case. And so you say V is at vector. I guess it's uppercase. Yeah, 3 element F32. Wait, doubles are F32s or F64s? I don't remember. Okay, by the way, I never used it's 64. Okay, though, so 64 it is. Let's go. Wouldn't want to. You're right. Float is 32. Double is 64. Okay, so we have VE vector, and then we need to implement all the things. So there's a couple of constructors here. Do I care about constructors? Nah, I think these guys suck, so I don't care. Getters for XYZ. I think that's fair. Oh, but I can't call if V is the field. God damn it. I see. If V is the field, then I can't do vector. So okay, const vector equals at this. Vector returns a F64, and then we can say return X. Return V dot E at 0. Z 2 1 Y. Here we go. Declaration not allowed between container fields. Yeah, something south is being parsed as something else. Okay, we don't worry about this. So operator subtraction. Right. So I think this subtraction is doable with just normal. Oh no, wait, this is negation. This is not subtraction. I guess for us would be this. I think. Then we have indexing. We don't need to do this. Double ampersand indexing. like a reference indexing. I don't know. I don't care. Equal assignment. I think we have this. We don't have to make it our own version. Negation works on vectors. Oh, never mind then. Fuck this. This we have, I believe. I'm guessing this we have. Also, oh no, wait a second. Operator divided equals takes these and multiplies it by 1 over t. Do we have this? Wait, what was the other one that I removed? Oh, right. Do we have this? Can a vector be multiplied with a scalar? It won't work on structural vector inside. You're right. Are you saying that we shouldn't do this and we should just have a naked vector? So we use naked vectors and then we make functions that operate on naked vectors? That might be better, wouldn't it? You need to splat the scalar. Okay. So by the way, I never really worked with vectors, so that's why I'm not sure how to approach this, and I need to figure it out on my own. So, okay, let's do this. So let's say that we do this instead. We do this. Okay, so if we do it this way, I think this is not bad. And then we need to move this file then to source slash, I'm going to just call it vec then, or v, vec.zig. Let's see how it goes. Again, I'm not sure. I'm just testing stuff out. So yoink what Mason has. I know that I could yoink what people have already made, but you know, we should be doing this work ourselves if we're doing everything from scratch, shouldn't we? But you know what? At least there's nothing bad in looking at what they do. Also, probably Mason has something more fancy than what we need. Two-dimensional vector. Wait a second. Two? What? And so he has some nice constants for this. Okay, he has splat, equal, scale. Yeah, this is all good stuff. Okay, you know what? We can come back to this later on if we find what we are doing to be absolutely inadequate or it's too much work. For now, I want to experiment a little bit with what we have. And I want to see if @vector is going to help me out. So, so the multiply assignment with a number. So, I guess basically we want splat. Wait, do we add splat? Produces an array or vector where each element is the value scalar, the return type, and thus the length of the vector is inferred. Scalar must be an integer, bool, float, or pointer. Okay, so we should be able to do scalar, splat with the other stuff. Okay. Requires the result location. Okay. So for now, I'm not going to implement any of this stuff. I'm going to implement it as I need it, I guess. Length uses length squared. So this is like the vectors. What's the name? Oh man, what's the English term for the? I mean, they use length here, but I think there's a more appropriate term for this, right? The magnitude. Thank you. Yeah. Okay. Norm? No, I don't think it's norm. I think it's magnitude, what we're referring to. It's like the length of the arrow, right? And the length of the arrow is constructed by by doing this. It's like the Pythagorean theorem, basically. In any case, let's call it length so that although we do like, you know what, fuck it, magnitude. Which is an F64. In its return std.math.sqrt. No definition found because we don't have std. By the way, we're really taxing ZLS because we have a bunch of C++ code pasted in our stuff in here right now. Now, can we do this on a vector? Can we do square root of std dot, what is this? I don't think there is a, we don't have it in the standard library, something like this, right? So we have to compute it. SQSum. Magnitude V is a vec3. Let's see if SQRT supports this stuff. Mason's SQRT would work. God damn it. It doesn't work? No, wait, it should. Wait. This is just a normal number, right? This is just an F64. This works. 0.3, right? These are the other things. IO stream operator. So it's giving it a FMT. We can actually do this. Pub function FMT. W is a pointer to a writer. Why not add SQRT then? Can we? Do we have an SQRT? First, the square root of a floating point number uses a dedicated order instruction when available. There is reduce. Okay, so how would you implement this with reduce then? Can somebody share this with me? I'm gonna write the formatter in the meantime. So I think it's writer and then wait, no, it's V, vec3, and then here's a writer, and I think that's actually it now. This is void to, and then it's w.print, and it's printing what? Component space as digits. Okay. No new line though. No new line. And okay, and then we try this. Okay, so this is FMT. Okay. So this is okay. Then this is sum between two vectors. I think we have this, so we should be good. Multiplication doesn't seem interesting. This is multiplication with a scalar. Maybe we'll need to implement it. I guess we'll see. Division with a scalar. There we go. Now this is the interesting stuff. Dot products, cross product, and the unit vector. Yeah. Mine is so wrong. Let's see, what did you write? Reduce add v times v. Yeah, you multiply everything and then you add all components. Yeah. So this would be return sqrt of reduce dot add v my star, v star v. Nice. Okay, let's do dots. Function dot. Choose an F64. So we are returning. Okay, so this can be the same thing, right? So return, well, similar thing, reduce dot add LHS times RHS. You forgot arg is in your print. Oh, you're right. Okay, so here we do this. So this should be our dot. Then we have cross. Cross, I believe can you do this with reduce? You can't really, can you? Why is it not format? Because format doesn't exist, or does it? Well, because it's not format because I'm not, vec3 is not a struct anymore. So I'm not adding a format method to struct. I'm basically, I don't remember exactly how we glue everything together, but I believe that you need to. Yeah, that also doesn't exist anymore. I think it's now called stdfmt alt. So I think you basically do this. And this returns a struct. Yeah, there we go. A struct that has the format method. So this is how you do it. Pub const fmt equals alt of, let's call it format then, of vec3, comma, format. There you go. So fmt is what now we can use to do formatting. Mm-hmm. I guess we'll see later how this plays out in practice. Okay, so cross to multiply, right? Yeah, I think this just has to be written out manually. So LHS, same signature, well, almost same signature. So LHS at 1 times RHS at 2 minus LHS at 2 times RHS at 1. Then 2, 0, 0, 2, 0, 1, 1, 0. And then unit vector. Which unit vector, is it also called in other ways, like normal? Is it like norm this thing? No. I mean, I get it. Unit vector is the same vector, but with magnitude 1. That I get. I wonder just if it has other names. It is a form of normalization, right? So, but is this the norm? I'm not sure if this is the norm. Also, you know what? Another thing that is causing confusion here is I'm used to Italian terminology of this stuff, which I'm also forgetting. And then mostly it's the same when it comes to norm is magnitude. Oh, I see. It mostly translates to English, but not always. Normalize means dividing by the norm. So norm is the magnitude. Okay. Okay, let's just call it unit then. So unit of v back 3. And I think we can... so can we do this with reduce? No, because we're not reducing anything. We need to splat, right? So we need to take v and divide it by at splat. And then we need the scalar that we want to splat. And the scalar is... the scalar is the length. So we can do magnitude of v. Can we do v dot magnitude? We can't, right? Would be nice though. Maybe this is an interesting solution. Nah. Magnitude of v. Okay, and you guys were saying that this is not gonna work because it needs things. Let's see. Duplicate start member name dot. Wait, didn't I write cross here? What happened? Let's see. Undeclared type writer. Splat must have a known result type. Fine. Honestly, this doesn't seem too bad. Okay. Christoph, call it dir as in direction. You're going to have a divide by 0 with that implementation. Well, that's how they implement it, though. How do you implement it in a way that a vector of magnitude 0 can make sense? Also, wait, a vector of magnitude 0 requires all members to be zeros, right? Call it dir for direction. I think I prefer unit, special case it. Okay. So like if the vector is 0, I return 0 and I don't do the division. I mean, that makes sense. Right, so we can do this, right? If mag equals 0, return 0. It's not going to work, is it? Well, I guess we need to use this. But also we can do better, I think. We can say 0 and return 0. And we have constants, right? So we make them. So we do pubconst 0 equals there we go. Okay. 0 is signed. Mag should always be positive. I'm not sure what you guys are talking about. I guess I'm gonna learn this stuff as I proceed. Yeah, okay, let's continue and then let's start using this code and see, and just watch it poop itself once the time comes, I guess. So using our new vectory class, we create a new color.h header file and define a utility function that writes a single pixel's color out to standard output stream. Write color So, okay, so the function from before takes a vector and interprets it as a color and then also prints it. Okay, so that's our previous main. And they put it inside color. Mm, minus 0 is not positive 0, so x equals 0 might be false for magnitude being 0. But magnitude is always a positive value. Where is it? Oh, but you're saying... Oh no, magnitude is always going to be positive. I'm just plotting it. Also, wait, why am I doing this? I can just test magnitude. I don't need to splat it first, right? Okay, let's do it like this. Const mag equals this. Magnitude of B. And then here we do if magnitude is 0, we return 0. And down here we do, let's call it mag3. And then we do mag3. And mag3 is splat of mag. Float 0 is signed. Okay, but is magnitude ever going to be negative? I don't think that magnitude is ever going to be negative. If any component is negative, it becomes positive from the multiplication, and then you sum numbers, so it can't be negative. So I don't see the minus 0 problem being a problem in this case. Also, more specifically, we also don't need to compare splats. After splat, we can compare the original value. So you're saying the problem is... Okay, you know what? I don't know what the problem is. It's fine. I'm going to go with main. If it's not greater than 0, okay. But is it really ever going to be negative? How can it be negative? So we were saying that this loop is what we're turning into a dedicated function. Print color, they called it. Print color, and you pass in, I don't know what. We're going to figure out what you pass down here. Let's see. Oh, write color, they call it. Okay, write color takes in a vec3 and prints it. Okay. To be honest, this could be an FMT thing for us, now that I think about it. This is basically a color format. You know what? Let's do it this way. Yeah, let's do it this way. FMT, and then we do color FMT. And actually, this function should not be public. Okay, let's see if we can do it in a smarter way. What was the idea? The idea was you take the component, you multiply it by 255 first, and then you divide it by height and width second. Also, wait a second, because here we have some values that are. No, wait a second. Oh, right. Because we're not coming up with a specific color. We're just printing what colors are already there. So this is taking the values, the components, multiplying them by 255.999, and then printing them out. So what we have here is not really useful. It's a try w.print. DDD. Right. I think this should be it. So this is color format. Okay. Int cast one cast floats. What do you mean? We were doing it here. Oh, sorry, it's in from float. You're right. Yeah. Okay. Okay, next. We can now change our main to use both of these. So the main function now uses the color printing and uses a bunch of overloaded operators now. Okay, let's see. Okay, let's see us make this happen. So it works by doing pixel color. Pixel color is going to be a vector. And it's a color constructor. So now the C++ metaprogramming stuff is not, it's about to make me go insane. So we're constructing a vec3. This is an initializer. And we have the integer turned into double divided by width minus 1. The other one, and the third component is 0. We make a vec3, and then we try to print it. And that's how we continue doing it. By the way, we also lost all new lines in the process because write color does not do a new line at the end. No, never mind. Print color does have a new line at the end. Okay, sure. Let's add a new line. Okay, so here we do so we were saying the first component is outer counter, so height, width, yeah, the inner one, sorry, width divided by image width minus 1. So this is H, and this is actually 0. Also, this is not really print color. This is just the main loop. We don't have vec3. We can add it. We can have it. It's ours. Const vec3. Let's do vec equals at import vec.zig. Const vec3 equals vec.vec3. Right, and these are called width and height for us. And then we do std, try out.print F. And then we need to do vec.color. And color wants color pixel. This is a pixel. Okay, so this should roughly be it. Let's see what Zig build has to say. Incompatible types, use size, and comp time float. Right. So what if I take this out? Will you be happy? I don't think you will be happy because we need to float stuff, right? Except I F64 found use size, right? How do we float this stuff? We need, right, we were making them, if we undo a bunch, we previously were making them explicitly floats. I'm gonna yank this, redo everything, and here we can paste this stuff. That's how we were doing it. So it's W divided by FW, H divided by FH. And maybe we're not done, but that needed to happen. So let's see, incompatible types, use size, and F32. Right. Float from int and inverse works on vectors. Yeah, but we have the operation around it, so it's not gonna work, I think. We need to, like, if I float from int this is still not okay, right? Because we need that division to be float division. So this is not gonna solve it. Invalid built-in function float from int. This is not going to solve it. Let's see. Oh well, that's this should not solve it, I believe. Yeah, because the problem is the inner operation. So we can do this, but since it's in an operation, we don't have a known result type. So this is not going to work either. So we need a floated version of this value before we do the division. There's no real solution, is there? And actually, now that I think about it, do they both need to be floated? Yeah. Just create two F32 function. That is a good point. That would solve it, wouldn't it? We make our own casting function. You know what, though? I would like to continue with this path a little bit more. Let's see what happens. Oh, also... wait a second. We were doing FH divided by height minus 1.0. So that's how we were making it work earlier. That's what was solving it. So I actually got it wrong. This was like this. This was FW divided by width minus 1.0. And this was working. Let's see. Int from float must have a known result type. Okay, so we're back to... Okay, now we're seeing errors in our back implementation. Also, I'm surprised that ZLS is not helping us. What's going on with ZLS right now? I would expect to see... ZLS to give me errors in here. I'm going to restart my editor just to understand what's going on. Why is ZLS not working? Oh, there we go. Zig accept path. Expected actual path but got zig. That's fine though. That should be fine. Okay, so the error here is int from float must have a non-result type. And it doesn't. Why does it not do that? Oh, wait. It makes sense that it doesn't do that because we're not making up vector like or anything like that. We're making 3 numbers. Int from float. So how do we make this nice? I'm not going to use as. I don't like as. We can do it like this. Replace dot for vec3? No, that doesn't work because we're doing something else. If that was the case, it would work. Oops. I'm using underscores because I have functions that have the same name. Error type is not a function. You're right. How does this work? We need to. This gives me a type, and it has a format. We make an instance of this guy, right? This should be like this, basically. So in main, we need to use color like this, I guess. So vector dot color equals pixel. Sorry. Does that work? Yeah. Okay. Success. It works. Okay, we have successfully added extra functionality. Let's see the Ray class. Rays a simple camera and background. One thing that all ray tracers have is a ray class and a computation of what color is seen along a ray. Let's think of a ray as a function, p, parameterized by t, that does a plus t times b, where p is a 3D position. What do you mean p is a 3D position? It's a fucking... Wait, what's going on? It's a 3D position along the line 3D. A is the ray origin and B is the ray direction. The ray parameter T is a real number, double in the code. Plug in a different T and P moves the point along the ray. Yeah, so I get it. What a way to explain it, though. Add in negative t values, and you can go anywhere on the 3D line. For positive t, you can only get the parts in front of A, and this is what often called a half line of array. Okay, yeah, it's linear interpolation. That sounds good. We can represent the idea of array as a class and represent the function p as a function that will call ray at t. Class ray. Okay. Let's make a ray file. Uppercase ray? Should it be uppercase ray? What does it contain? Private. Point 3 origin, back 3 direction. Yeah. Point 3 origin, back 3 direction. Interesting. Okay. So point, back 3, direction, back 3. Const ray equals at this. const std import std. Actually, I don't know if we need std. We do need vec3 though, that's for sure. Okay. What does it have? Origin, direction. Okay. We don't care about this shit. At for linear interpolation. Okay. So at ray, copy. Well, you know what? Easier. I don't have to think. So returns a vec3. And in here we do return. Oh, this was origin, yeah. Ori. Origin, direction. Okay. So return origin plus t, which is a parameter that we don't have. F64. So this is t times dir. Okay. So origin plus t times dir. So what could we call t times dir then? Blind forest gene. What? Oh, it's a joke. Oh, okay, I get it. Offset. Scale. Let's go with scale. Okay. I'm not sure, but for now, it's fine. Displays. So scale, we're saying it's well, let's do tv3. T3 equals vec3 equals at splat t. That's splat multiplication, right? That we did not implement. Yeah. So wait, what's the name? It's dot multiplication with a scalar. So origin plus t3. T3. Okay, so this should be it. And T3 is splat T. Did we do it? Wait, something is missing. Origin plus T3 times R dot direction. Okay, there we go. This is it. Okay. For those unfamiliar with C++ functions, origin and direction both return an immutable reference to their members. Yeah. Sending rains into the scene. Now we are ready to turn the corner and make a ray tracer. At its core, a ray tracer sends rays through pixels and computes the color seen in the direction of those rays. The involved steps are calculate the ray from the eye through the pixel. Scale is multiplying a vec by a scalar. Yeah, that's true. Maybe it's helpful to have. We'll see if we are gonna need it. Yeah, that's a good point. If we're gonna need it, we'll see. Determine which objects the ray intersects and compute a color for the closest intersection point. Okay. When first developing a ray tracer, I always do a simple camera for getting the code up and running. I often got into trouble using square images for debugging because I transpose X and Y too often. So we'll use a non-square image. A square image has a 1-to-1 aspect ratio because its width is the same as the height. Since we want a non-square image, we're gonna do 16 by 9. Sounds good. I think this is 16 by 10. Actually, no, this is 16 by 9 right now because I'm using a non-Mac screen. Like Mac laptops are 16 by 10, but this is a Mac Mini. For a practical example, an image 800 pixels wide and 400 pixels wide has a 2:1 aspect ratio. The image aspect ratio can be determined from the ratio of its width and height. Yes, however, since we have a given aspect ratio in mind, it's easier to set image width and the aspect ratio, and then using that to calculate its height. This way, we can scale up or down the image by changing the image width, and it won't throw off the aspect ratio. Yes. We do have to make sure that when we solve the image, the resulting height is at least 1. In addition to setting up the pixel dimensions for the rendered image, we also need to set up a virtual viewport through which to pass our scene rays. The viewport is a virtual rectangle in the 3D world that contains the grid of image pixel locations. If pixels are placed the same distance horizontally as they are vertically, the viewport that bounds them will have the same aspect ratio as the rendered image. The distance between two adjacent pixels is called pixel spacing, and square pixels is the standard. To start things off, we'll choose an arbitrary viewpoint height of 2.0 and scale the viewport width to give us the desired aspect ratio. Here's a snippet of what this code will look like. Do we need to implement this? I think we should. We don't know yet where we want to put this stuff, but I think we're gonna do 235 one for cinematic effect. Maybe I should. You know, we were doing 235 at Software You Can Love. Actually, it was even it was even steeper than 235. 235 is what I wrote here, but I think at the cinema when we were there for real, you can also see, right, that this box here for the live stream has this aspect ratio. I think it was even bigger than this. It was like 250, I think. Anyway, yeah, sorry, setting this stuff aside. So we don't know where to put this stuff yet, but I guess we can implement it and then we decide where to put it later on. So, oh, you know what? I'm gonna do something unholy. I'm gonna modify the original code. So const aspect ratio. Oh, I guess we can put this here then. Height is image width divided by aspect ratio. Oh, it's also set to 400. Okay. So, okay. So width 400. Height is going to be image width divided by aspect ratio. So int from float of width divided by aspect ratio. I think aspect ratio, well, whatever, we can leave it like this. And ensure it's at least 1. It should not be a problem. Like, why? When would this be a problem? You know what? Okay, so this is doing. Okay, let's make a block. Let's do some code in a block. So h is this if h is lower than 1, break BLK with 1, else break BLK with h. Oh, you know what? Let's continue with this. Const. Okay, so this works. Instead of 16 by 9, use 15 by 8, so the diagonal is 17. Wait, why? What would that do? I don't know. I don't know what I would do. By the way, what? Add. Oh, we have mul add. I didn't know we have mul add. Okay, fuck it. Copy. Take it. I'll take it. By the way, if this is bugged, Andrew, it's on you. Everybody's gonna hate you. Just putting it out there. No, I'm joking. It's not gonna be that. Okay. I'm gonna leave this commented out just to double check what our intentions are. You know what? Pause and endure is not bad, is it? Although origin and pause. I'll keep origin for now. Okay. So viewport height times with double. So it's image width. I guess we can do 0.0. Oh, you know what's a trick? You do plus 0.0 divided by image height. And now I get why he had he called this image that. Oops. Oh my god, why am I doing this? There we go. Okay. If you're wondering why we don't just aspect ratio when computing viewport width, also wait, did somebody else say something else? Square root of 15 by 15 plus blah 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 17. Right, and we care about this when we're doing certain vector computations, right? Because we're square rooting certain vector computations. Is this important when it comes to our image size and aspect ratio? Well, in any case, if you're wondering why we don't just use aspect ratio when computing viewport width, yeah, it's because the value set to aspect ratio is the ideal ratio. It may not be the actual ratio between image width and image height. If image height was allowed to be a real valued rather than just an integer, then it would be fine to use it. But the actual ratio between width and height can vary based on two parts of the code. First, image height is rounded down to the nearest integer. Yes, we're using pixels, which can increase the ratio. Second, we don't allow image height to be less than 1, which can also change with actual aspect ratio. Note that aspect ratio is an ideal ratio, which we approximate, because it's pixels. Okay, so next we'll define camera center, a point in 3D space from which all seen rays will originate. Oh, I see. So it's like it's our eyes that light things up right now. That's that's in a sense, it's almost a philosophical statement. You know when they say beauty is in the eye of the beholder? In any case, in the person that watches. In some ways, light is also in the eye, or actually not. Physically, that's not really the case, but you get the idea. How could mirrors be real if our eyes are not real? Yeah, there's also that. That's another piece of amazing wisdom. Yeah. Let's see. We'll define camera center. Also commonly referred to the eye point. The vector from camera center to the viewport center will be orthogonal to the viewport. Yes. We initially set the distance between the viewport and the camera center point to be 1 unit. This distance is often referred as the focal length. Oh, yes. For simplicity, we'll start with the camera center at 0, 0, 0. We'll also have the y-axis go up, the x-axis go right, and the negative z-axis pointing to the viewing direction. Yeah, this is like the finger rule. Right-handed coordinates. Wait, are those the normal ones? Wait, are these the normal ones or are these the Microsoft style weirdo ones? And by the way, I might be I might be using judging terminology that maybe I this is the left hand, right? So this is what you do normally, right? When you like study physics, this is normal because I remember that a while ago, Specs guy ran me through how to write shaders for what was it, DirectX, and they have everything backwards. They had everything absolutely backwards. Okay, let's see. Now the inevitable tricky part. While our 3D space has the conventions above, this conflicts with our image coordinates, where we want to have the 0th pixel in the top left and work our way down. Spread your legs 90 degrees and sit on floor. Yeah. I mean, yeah, left hand rule. That works. I mean, you guys are seeing it backwards, but this is my left hand. As we can scan our image, we'll start at the upper left pixel, scan left to right across each row, and then scan row by row, top to bottom. So we're doing yeah, we're deltaing to the right and we're deltaing to the bottom. Sounds good. Why is it U and V? God damn it, man. Anyway. Our pixel grid will be inside. Actually, you know what? Maybe it will make sense afterwards, but for now it doesn't seem particularly useful. In any case, we'll use vector from the left edge to the right edge and a vector from the upper edge to the lower edge. Pixel grid will be inset from the viewport edges by half the pixel to pixel distance. This way, our viewport area is evenly divided into width times height identical regions. Here's what our viewport and pixel grid will look like. Okay. In this figure, we have the viewport, the pixel grid for a 7:5 resolution image. Yeah, 1, 2, 3, 4, 5, 6, 7. Yep. The viewport upper left corner Q, pixel 0, 0 location. Yep. Viewport vector U, then V, viewport vector V, and the pixel data vectors delta U, delta V. And the length of this vector is the pixel to pixel distance, right? Okay, so this is the new code. Ray color. Huh? Ray color takes in a ray. Also, what the fuck is this syntax? Const ray %r. Fine. But also it returns a hard-coded 0. Fine. I guess we're gonna change these afterwards. Yeah, I guess so. Take as a reference to ray. Unlike a pointer, can't be null. Ooh. So, image auto aspect ratio. So this is what we just did. Focal length is new. So let's do focal length. Also, look at how weak they are. Look at this. This math is in their main function. Disgraceful. We don't do it in the main function. We do it out here. We solve these at comp time. No way we do this at runtime. I mean, I guess ideally C++ code goes through the optimizer and everything happens at runtime. But by putting this stuff here, the language guarantees that all this computation happens at compile time every single time, even in a debug build with like 0 optimization passes. Just pointing that out. Okay, so we have focal length. Camera center 0, 0, 0. Oh, it's a shame that I can't do this. But we can do back to 0. Calculate the vectors across the horizontal and down vertical viewport edges. So viewport U, viewport V. By the way, this is also all stuff that can be done at compile time. I'm going to copy this and translate this. Okay, const. Viewport U is colon vec3 dot curly const pixel delta U. This is not going to work. We're going to need to translate this. Okay. Oh wait, this is just a very long comment. Okay. So user identifier image width. Yeah, it's EMG width for us. EMG. But this is not gonna work. Then camera center minus. I guess we can do this. Maybe. Minus viewport U divided. Oh god. Okay, there's a bunch of math here that we're gonna have to split off into multiple steps. There's spamming the Going Live Discourse channel. Thank you. Delete message, report. I sure want to delete this message. You can hold down shift when clicking delete message to bypass this confirmation entirely. No, but I want to ban the person first. How do you ban the account? Oh, there we go. Right click. Oh, you have to right click on the account name. Ban this account. Suspicious of spam. Delete all. Ban. Why did it not remove the message? Did it not remove the message? Okay. Okay. There we go. Okay, sorry all. Hey Snackstron, are you using GPU for ray tracing? I don't have anything right now. I just have a bunch of C++ code that I'm slowly digesting. That's all I have for now. Thank you for the report, by the way. Thank you all. So this stuff should be fine. Except this one. We need to splat these guys. Oh, that's annoying. So we can do this stuff in a block, I guess. Image W3. Vec3 equals at splat img with, and then we break VLK with viewport view divided by emg w3. So there we go. And height has the same problem. So pixel delta v is image h3, height h3, viewport p. There we go. C++ code? Yeah, because I'm following ray tracing in a weekend, and it has C++ code samples. So that's just life. Okay, so this is a little bit complicated because they by the way, the fact that they keep mixing and matching different types and they are leveraging operator overload to have all operations mix up. I don't know. I find it weird. I guess it's a mindset. Once you get into the mindset, you can accept it and, like, I don't know, even love it. But how is this weird? It's C++ bullshit magic. Except I get it that in the math case, it's less bullshit than in the random. I don't know. Like, look at this. What the fuck is this? What is this? Why are you shifting left strings, man? Why are you shifting left a space? What even is the point of this? This is just silly. Just print, man. Stop shifting. Just print. Like, they're doing like Fast and Furious here. I don't know. Let's see. So camera center minus a vector minus viewport u. Is that a vector? That is indeed a vector. Actually, you know what? Let's set this in stone so that we don't ever get confused about this. That's a vec3. Oh wait, this is pixel delta in any case, but that's fine. So camera center minus another vector minus viewport u. We were saying it's a vector divided by 2. So let's see, viewport u divided by 2. Okay, so we need to make this vu of, I don't know, let's call it vu half. This needs to be splatted though. That's annoying. I'm trying to think if we should have a splat at this point operation. I think we should have a splat operation. Using add splat every single time is kind of annoying. It's forcing us to make too many temporaries. Let's add splat. Wait, no, it's not exactly splat that we want, right? Because the problem is that's like division with, oh god, right? Because then you have the problem that, are you doing this scalar multiplication? Are you doing scalar multiplication, division, or whatnot? So, but let me think about it for a moment. I can do splat, and doing splat allows me to splat in line without temporaries, right? Yeah, that's the problem. Okay. I get it. So we don't get a vec3, we just get any type. And then we return a vec3. And here we can return at splat. And yeah, and that gives us a splat to what we want. So with this, we can do vec.splat. We don't need this, and then we don't need the block anymore. I guess could be better, could be worse. I'll take it. Yeah. Okay, so here we can do then viewport u divided by, we're going to put parentheses, but we can do viewport u divided by vec.splat 2. And that should work. Although I have to say this whole formula kind of sucks. I might want to do this regardless. Oops. There we go. Also, this is kind of ass. What is this guy supposed to be? It's a vector 3 that has focal length at the XYZ. Yeah, I mean, that makes sense. Okay, I'll leave it as this right now. In boost vector, I think you can write V and then you shift into it 1, 2, 3, 4 to pen values. Delightful. Delightful. You think with work Zig won't be able to infer it? Will it? We want it? Well, if it doesn't, then we're gonna make a dedicated variable for it as well. Okay. And then we have pixel lock. So viewport upper left. What's viewport upper left? I believe this is a vec3, right? So it's a vec3 plus vec.splat 0.5 multiplied by pixel delta u. So like this, which is a vec3 multiplied by another vec. Sorry, sum to another vec3. So this is okay, I guess. We got this on a new line. Yes. Okay, so we should have all the math. We'll see what happens with this guy. Okay, so we have all this stuff. Then we do auto pixel center is pixel 00 location. Viewport upper left. The first pixel is the viewport upper left. Yes. Plus 0.5 multiplied by pixel delta u plus pixel delta v. Why are we doing this? So we're summing two vectors. And then we're dividing by... We are basically dividing them by 2. Why are we summing and then divided by 2? Is that like a poor man's Pythagorean thing? No, right. It makes sense because no. It absolutely makes sense. It's not a poor man's anything because you basically want to you want to take that number divided by 2 for each component. So yeah, it's basically a fancy way of doing that. Yeah, that makes sense. And like we don't need a vector that points diagonally that way, I believe. Yeah, okay, sorry. No, I don't know what I'm saying, but I think I get it. Okay, let's do this. Copy. So pixel 00 location plus integer times pixel delta u plus j times pixel delta v. And then ray direction is camera center minus pixel center. Sorry, pixel center minus camera center. We make a ray that has camera center as the origin. This is the direction, right? And then we do ray color. And this is pixel color. Okay, I have no idea what this is going to print. Now I'm curious to see what this is going to print. Copy this. Okay, so const pixel center is actually, you know what? Let's adapt this. Const pixel center is pixel 00 lock. We have it plus I. So for us, I is W. Pixel delta U. Yeah, I think this U should really be renamed to W in my case, but in any case, plus H times pixel delta V. No, that's fine. Okay, so this is the first thing. And this is R. Something like this. We might need an init function for Ray. Oh, we don't even have Ray here. Okay. Okay. Let's fix this stuff. So we can't do this way. W needs to be splatted. So vec.splat h.splat. There you go. Right direction. This works. Pixel. Don't care. This is just going to be pixel. And it's ray color that for now is 000. Okay, so wait. As the code was given to us, this is right now not even implemented. So I guess we're going to implement it. I don't know. Function ray color. So this is what they had. Okay. We don't need this anymore, do we? Doesn't seem that we do. Okay, so let's see what happens now. Notice that in the code above, I didn't make ray direction a unit vector. Let's see. Okay. Because I think not doing that makes for simpler and slightly faster code. Now we'll fill in the ray color ray function to implement a simple gradient. This function will linearly blend white and blue depending on the height of the y coordinate after scaling the ray direction to unit length. Because we're looking at the y height after normalizing the vector, you'll notice a horizontal gradient to the color in addition to the vertical gradient. I'll use a standard graphics trick to linearly scale alpha between 0 and 1 when alpha equals 1.0. I want blue. When it's 0, I want white. In between, I want a blend. This forms a linear blend or linear interpolation. Yeah, which is the same formula. 1 minus alpha times start value plus alpha times end value. Okay. Okay. And so we expect to see this, huh? That's it. Okay. So unit direction is unit vector of r dot direction. So r dot direction we don't have. So it's vec.unit of r.direction. Wait, do we call it dir? Yeah, we call it dir. Okay. So this is this. Then const a is actually, you know what? Let's do it here. A is 0.5 times unit direction unit dir dot y plus 1.0. And then we return 1.0 minus a times vec.splat times I guess this is vec.ones. I'm gonna make vec.1 plus vec.splat a times 0.5, 0.7, okay. I'm gonna make this a constant. I don't know what. I don't know what that is. Okay. So in vec, we had 1. Okay, I don't know what this is. I guess it's like a color it's the color that we're blending, basically, I guess. Because on yeah, I guess it's the color that we're blending, right? Okay. And so this should build. Okay, let's take a look at what build errors we have. Ambiguous coercion of division operands. Comtime int and comtime float. Non-zero reminder of in const h usize. Main does line 11. How do you like this? Incompatible types, comtime float, and usize. Okay, so this is in viewport with, right? Yeah. I think, by the way, if image, no, these are integers, that's fine. I guess, you know, we can do this. Is this happy? Incompatible types usize and comtime float. Image height is usize. Well, what if we make it, is it usize? Yeah, because this is usize. If it was comtime int, would that make it better? It works. Let's see, mix scalar and vector operands. Vector and struct. Oh no. So I guess I have to explicitly either write at vector or we have to. Duh. No, there's no way we make a variable for this. Vec3 111, we already have vec.1. Next problem. Let's see. Ray does not support a reinitialization syntax. Yeah, that's true. That is something that I left ASA to do. Function init origin rec3 here rec3 returns a array. Pretty much. So where are we creating one of these bad boys? I don't remember. Line 60. Yeah, there we go. So array equals dot init. Next problem, accept F64 font use size. Back 25. Come again, accept type F64 found use size. I guess we need to do two things in based on what we're given. Switch type of n, and we have use size return splat of at float from int n. Then we have f64 return at splat n. Else unreachable. Does this make everything happy? Reach unreachable code. Oh, we're passing to, okay, so use size, comp time int. F64, comma, comp time float. No field or number or function named y in vector. Yeah. So this is back.y of unit there. Okay. Well, success. Is this the aspect ratio that we want though? It looks mostly okay. It's just not 16:9. What did we forgot to do? What did we mess up? Like the blending is happening beautifully. We're just somehow forgetting something. I don't know. Oh, I know what we're forgetting. Wait. I think we're lying somewhere in maybe the file format. Are we lying? We're not lying. Well, we're saying 400 by 400. So there's something wrong. We think that the width is the same as the height. Why are we messing this up? We are doing the viewer you're using probably displays a scaled image. P3 header is width and height. Yeah, but regardless, we're passing in wrong numbers. We're giving 400. That's definitely wrong. We should be giving 400 something else. So width is 400, sure. This should be something else. This should not be. Let's do this. Add compile log h. Let's see what's h. Yeah, it's 400. Why does this give us 400? Oh, because of this. Oh, it's empty? Oh, we also need to remove the compile log. Somebody said that it's width then height. Is it? We're doing height then width, which previously did not make a difference. Now it might. It was width then height. Yeah. Thank you. We also were able to catch this right away. Thankfully. There we go. Okay. Fix our problems. You're using minus 0.0 to cast to float? Yeah. Hell yeah. I am. I totally am. And you can't stop me. Although I agree, it's a poor man's way of obtaining a float, huh? Definitely true. Okay. So success. We still have a way to go, but so far so good. The licensing programmer will go not to use as. I don't like using it as. Honestly, I get why it's there, and I can see. I'm not saying that it's categorically wrong to use it, but my personal preference is to always do something else than use as. I think that it adds way, way, way too much noise. So yeah. Let's see, noticing the color above, I didn't make any right direction. Okay, we did this already. We did this. Adding a sphere. It's time. Let's add a single object to our ray tracer. People often use spheres in ray tracers because calculating whether a ray hits a sphere is relatively simple. The equation for a sphere is of radius r, that is centered at the origin, is an important mathematical equation. Yeah. You can also think of these as saying that a given point xyz is on the surface of the sphere. If a point is on the surface of the sphere, then x squared plus y squared plus z squared equals r squared. If a given point xyz is inside the sphere, then this value is lower than r squared. And if a given point is outside, then this is bigger than r squared. If you want to allow the sphere center to be at an arbitrary point, then the equation becomes a lot less nice. You subtract each component to each component. Okay. In graphics, you almost always want your formulas to be in terms of vectors so that all the XYZ stuff can be simply represented using a vectory class. You may know that the vector from point P equals XYZ to center C is C minus P. Yes. If we use the definition of the dot product, C minus P times C minus P gives us the formula. So then we can rewrite the equation of the sphere in vector form as C minus P times C minus P equals R squared. We can read this as any point P that satisfies this equation is on the sphere. We want to know if our ray ever hits the sphere anywhere. And if it does hit the sphere, there is some t for which pt satisfies the sphere equation. So we are looking for any t where this is true. So we plug in pt, okay? Which can be found by replacing pt with its expanded form. So c minus q plus td times c minus q plus td equals r squared. We have three vectors on the left dotted by three vectors on the right. Wait, we have three vectors on the left dotted by three vectors on the right. Oh yeah, so these three, yes. If we solve the full dot product, we would get 9 vectors. You can definitely go through and write everything out, but we don't need to work that hard. If you remember, we want to solve for t, so we'll separate the terms based on whether there's a t or not. Okay, so you do some math, and we move the square radius over to the left-hand side, and oh no, what? It's hard to make out what exactly the equation is, but the vectors in R in that equation are all constant and known. Furthermore, the only vectors that we have reduced to scalars by dot, the only vectors that we have are reduced by scalars by dot product. The only unknown is t, and we have a t squared, which means that this equation is quadratic. You can solve for a quadratic equation in this form by using the quadratic formula. So solving for t in the ray sphere intersection equation gives us these values for a, b, and c. Okay, a is d squared, b is 2d minus cq, c is cq, c minus q times c minus q minus r squared. Okay. Using all of the above, you can solve for t, but there is a square root part that can be either positive, meaning 2 real solutions, negative, meaning no real solutions, or 0, meaning 1 real solution. In graphics, the algebra almost always relates very directly to the geometry. What we have is no solutions, no intersection, 1 solution, touching, just barely touching, 2 solutions, full intersection. Sure. Creating our first ray trace image. If we take that math and hard code it into our program, we can test our code by placing a small sphere at -1 on the z-axis. So the z-axis is the depth axis, and placing it at -1 should put it in front of us. I'm assuming that you want the sphere to be in front of us, but also, should it be minus? Isn't positive in? No, it's positive out, is it? Let me scroll up for a brief moment. No, it is positive in. So why are we placing it at -1? Oh, is it because we ourselves are on the way back? Are we inside the sphere? What's going on here? Okay, well, let's start doing this. And then in ray color, if hit sphere, then return color 1. Okay, so this is showing us where that happens. You can only see what is behind the viewport plane. Okay, let's see. OC. OC is a vec3. And we subtract r.origin. So yeah, that works. A is doing a dot product. So this is a back dot between 2 vectors, r direction and r direction. Yes, we're squaring. That works. Then const b is, we need to back splat. Times vec dot direction NOC. So that works. Then const c is vec dot dot times radius minus radius times radius. Where's radius though? Where is radius defined? Oh, it was up there. Do I still have? Oh god. Okay, that's on me. But this means that this needs to be splatted. Dot returns a scalar. Oh shit, you're right. You're right. And so we don't need to split anything. Yeah. You're right. Whoops. Is it possible to use Zig's build system to make a step that pipes the output of run step directly into an image? Yes, absolutely. You can do capture standard out. You can also capture standard error, and then you can decide what to do with it. You can test it for equality against a known good value. For example, you can write it to a file, and then you can install that file somewhere. Honestly, in this case, I would probably change the main function to write to a file instead of standard out. But for now, like that's what I would do. But for now, I'm just following what the book does. Okay, so this is its sphere. And yeah, good point that the dot returns a scalar value. I forgot. Okay, so we do this in ray color. If hit sphere, if hit sphere, then return this. Okay. Let's see. Vector 334 is not a function, right? We can't do r.origin. This is vec.origin r. Although no, wait, we can do it with. Wait a second. No, r is ray. It's not this. Wait a second. Where are we doing it wrong? 80. r.origin. But that's ray, so we can do it. What's going on? Type vector 3 f64, not a function. Did I typo it? No, I said that r is array. Origin is not a function. Oh, you're right. Oh my god, yes. This is now me going insane. And you know what? I think I want to call direction at this point. Calling it dir. Okay. There we go. We got our fancy Japanese flag. Success. Okay, next. Surface normals. Oh wait, this lacks all sorts of things like shading, reflection rays, and more than one object. But we are closer to halfway done than we are to our start. One thing to be aware is that we are testing to see if a ray intersects with the sphere by solving the quadratic equation and seeing if a solution exists. But solutions with negative values of t work just fine. If you change your sphere center to be z equals +1, you will get exactly the same picture because this solution doesn't distinguish between objects in front of the camera and objects behind the camera. Yeah. This is not a feature. We'll fix those issues next. Okay. Shading with surface normals. First, let's get ourselves a surface normal so we can shade. This is a vector that is perpendicular to the surface at the point of intersection. Yes. So you need to basically make a vector from the center of the sphere. Yeah, your 2 points are center of the sphere, point of contact, line that goes through it. And that's your normal. We have a key design decision to make for normal vectors in our code, whether normal vectors will have an arbitrary length or will be normalized to unique length. Ooh. It is tempting to skip the expensive square root operation involved in normalizing the vector, in case it's not needed. In practice, however, there are 3 important observations. First, If a unit length normal vector is ever required, then you might as well do it upfront once instead of over and over again, just in case, for every location where unit length is required. Second, we do require unit length normal vectors in several places. Third, if you require normal vectors to be unit length, then you can often efficiently generate that vector with an understanding of the specific geometry class in its constructor or in the hit function. For example, sphere normals can be made unit length simply by dividing by the sphere radius, avoiding the square root entirely. Yo. Okay. Given all of this, we will adopt the policy that all normal vectors will be of unit length. For a sphere, the outward normal is the direction of the point minus the center. Yeah. Disclaimer, newbie Zig build system user here. Is there any project that can help transition from a horrible Visual Studio solution projects in C++ MSVC to a nice build.zig? So there is no self-contained resource that I know of, but here's two things that you can do are RKTR. Number one, so I'm taking a brief break to answer from the ray tracing stuff to answer this question. So here are two things that you can do. Actually, let's say three things. Number one, go to ziglang.org, learn, and then there's a Zig build section. This will teach you some things about the build system. Bork, send this. Then resource number two. And this is actually, you know what? I'm saying that this is resource number two, but I think this is more basic than actually what's written on the website. So you can go to Zig build system. Oops, I typoed it, but should still work. I made a video that explains the basics. This also can help. Third, you can go to github.com/allyourcodebase. This is an organization that has right now 93 repositories of C and C++ projects that were packaged for Zig, well, using the Zig build system. Not every package is of maximum quality, meaning that in this organization that I run, people are allowed to push projects that they package, that they made a build system, a build.zig for, even if they don't port everything right away. Like maybe sometimes people only need a subset of what the original project was able to do through the build system. And so they only port that part that they need, and that is fine. So my point is, not every project will show you how to do everything A to Z, but each one of them does actually tackle a real world C project, and so C or C++ project, and so you can actually see how that works. For example, Tracy is a C++ project. Most of them are just a build script that adds the original project as a dependency. Some of them are a fork of the original project, depending on their needs. Some of them need to apply patches, for example, or make changes to the original code. So I'm going to link you this. This is going to be your last resource. Let's see. Raytracing is working on something similar, but it needs some cooking. Oh, you mean some automated stuff? That also works, but you know what? Just learn how to use the Zig build system and port everything over, get used to it, and you'll never look back again. You'll never look back to CMake again. So save yourself. Remove the dependency, because at the end of the day, you're doing some work. You might as well do the work in a way that allows you to get rid of the dependency completely. And all you do is, and at that point, you're just left with one dependency, the Zig build system, the Zig compiler that does build system and, compiler. Thank you for the $5 to the ZSF. Thank you very much. Okay, so let's continue. Okay, so this is our normal. Let's see. On the Earth, this means that the vector from the Earth center to you points straight up. Yes. Let's throw that into the code now and shade it. We don't have any lights or anything yet, so let's just visualize the normals with a color map. A common trick used in visualizing normals, because it's easy and somewhat intuitive to assume n is a unit length vector. So each component is between -1 and 1. So is to map each component to the interval from 0 to 1, and then map it to XYZ. Okay, let me think about it for a moment. Yes, because it's a unit vector, it does go to from -1 to 1. Yes. Okay, so we scale it that between 0 and 1, and then we scale that to 0 to 255. For the normal, we need the hit point, not just whether we hit or not. Yes, which is all we're calculating at the moment. Yes. We only have one sphere in the scene, and it's directly in front of the camera, so we won't worry about negative values of t yet. We'll just assume that the closest hit point, smallest t, is the one that we want. These changes in the code let us compute and visualize n. Okay. So, hit sphere. If the discriminant is lower than 0, we return. So this now returns a float, and it actually computes the solution. And okay. So in here, we do this. If discriminant is lower than 0, return -1. If this is not a boolean anymore, now this is an F64. Otherwise, return -b minus. See, Zig doesn't know what the heck. What the heck are you doing here? Yeah. So do we have our own SQRT for to do stuff? But discriminant is just a number, so no, this is just at square t. Do we need to change anything? I don't think we need to change anything. I think this math is good as is. Okay. And then in Raycolor, we do this. Hit sphere. You know what? Also having .init could be nice here, but nah, the curlies at the end of the day are shorter. Okay, if t blah 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 const n vec3 unit vector. So this is vec.unit for us. Once a vec3. So let's see, r at t gives us a vec3, and we subtract that to another vec3. Okay, and then we return 0.5 times color, but color is just a constructor for a different vec3. So we splat 0.5 times times vec3. I guess we have to do this. And we can't do n.x. Unfortunately, have to do vec x n vec y n. Why are you adding +1 to each component manually? Dude, I'm just copy pasting. I just copy pasted this thing. Do you think we should do what? Is this a reduce? Wait, what would be the operation that we should do to optimize this? Mul add, right? Okay, let me use mul add because I copied pasted your code earlier, but I never used it myself. So return, let's see, add mul add. Focused fused multiply add, similar to a times b plus c, except only rounds once and is thus more accurate. Supports floats and vectors of floats. So it's a times b plus c. So that would be n times 0.5, which needs to be splat. Also has type, so vec3. And vec.splat And then we do plus 0.5, right? Because we do the +1. Here we're doing the +1 before. Here we're doing the +1 after. And that also needs to be splatted. Okay. So does the math sound right? Just splat works here because it has a result equation. Oh, you're right. We can use the easy splat. So this one. Although it doesn't make a big of a difference, right? But yeah, that makes sense. Okay. Cool. Okay, so we have this. And okay, it should give us this. Does it? It doesn't. Give us compiler error. What? We got lied. Let's see. Mixed scalar and vector operands. Vector 64 and struct. Okay, yeah, sure. There you go. This does not look right, does it? I mean, there's some gradients happening, I think, a little bit, but it's definitely not correct. Isn't mul add wrong here? Let's see. So this is doing each component, a vector where each component is +1. I guess this would be basically n plus splat of 1 and then multiplied by 0.5. Mul add does a times b. So first we divide, we multiply by, well, we divide by 2 basically. And then we sum c. And since we're taking the sum out, we're doing it after, then we 1 times 0.5 is 0.5. So we, instead of adding 1, we add 0.5. So this formula seems fine. But you know what? So I think that the fact that we have a different solution is because of something else. Yeah, so this gives us the same result. So these two things are equivalent. This is fine. But we might be doing something else wrong. Yeah, because this is clearly very different. Clearly very different. So what are we doing wrong? What are we doing wrong? Also, this code has all, this math has all the parentheses possible. So this shouldn't be a problem. Also, this is minus b minus sqrt. Yeah. Divided by 2.0 times a. Are we getting a different order of operation here? Maybe. B times b minus 4ac. Is this stuff implemented differently in Zig than for them? I don't think so, though, because then this would fuck up our intersections. We wouldn't even see. Wait, okay, so wait. I know what the answer is. We can reason about this. We are getting, the sphere stuff is right. What we are getting wrong is how we end up dealing with the normal, right? No, we do not ignore basic mathematical order. Okay, so yeah. In any case, this was certainly not it. The problem is it's the normal vector. We are doing something wrong with the normal vector. we're doing, let's take a look at this code here. Maybe this gives us a hint. It's unit vector of ray at t. T is the point where we touch the sphere. T is the point where we touch the sphere. And then we subtract. Why are we subtracting this? 0, 0, minus 1. We're subtracting, I think, the center of the sphere, right? And this is what giving us the normal vector, in theory. And then we scale it. Maybe we should print some of these values. I don't know. Let's see if at t makes sense. What if this is wrong? Wait a second. Wait a second. Andrew. uh, don't worry, I'm joking. It happens. So we're doing fine. Okay, let's see. What's wrong with this malad? Let's take a look. By the way, I copy pasted it earlier without thinking deeply about it. Maybe it's time we do that. So here we're doing origin plus this multiplication. And yeah, that's a problem, right? We need to move direction last. Or as one way of solving it. Yeah. Okay. Or not? That wasn't it. Wait. You need the origin last. Oh, you're right. Origin is the thing. Right. Yeah. Oops. Well, at least we got to see an interesting image. There we go. Let's take a look at what it was. What the heck? That was cool. That's nice. There we go. Okay. Cool. So next. Simplifying the ray sphere intersection code. Let's revisit the ray sphere function. Yep. Okay, so this is the same code as before. Nothing has changed. First, recall that a vector dotted with itself is equal to the square length of that vector. Okay, yes. Second, notice how the equation for B has a factor of -2 in it. Consider what happens to the quadratic equation if B equals -2h. Notice how the equation for B has a factor of -2 in it. Wait, what does that mean? Has a factor? What's a factor? Is that a component of dynamic multiplication? It's multiplied by -2. Yeah, is this because of the -4? Is that what we're talking about? Is a factor a like I'm having a terminology problem right now. Are we having is a factor a component in a multiplication? That's what it is, right? Let's see, considers to the quadratic equation if b is minus 2h. So if it's minus 2h, then yeah, you simplify and you get that the 2's simplify out, and then you get h plus minus square root of h squared minus ac divided by a. This simplifies nicely, so we'll use it. So solving for h, b is minus 2d times c minus q. H is b divided by minus 2 equals d times c minus q. Using these observations, we can now simplify the sphere intersection code to this. I have to be honest, I have not really followed this math. But I trust the book. So let's see, it's direction minus length squared. Oh, it turns out that we do need length squared, as a separate function. Okay, let's see, vec3. So length, which we call magnitude, is this. I'm gonna call it magnitude 2, maybe. Thank you. Have fun. Okay. So let's take a look at this math now. So we have A. A is now this is different for us. This is vec dot magnitude 2 of this. We have h, const h equals vec dot dot between r dot direction and OC, which is the one up above. Yeah. Then we have const c is OC dot length squared, so it's vec dot magnitude 2 of OC. Discriminant is h times h minus a times c. Okay. You did it too much, did I? Oh shit. Oh, you're right. Thank you. Ooh, that would have been bad, wouldn't it? Thank you. Holy cow. Thank you. Okay. Well, that sounds good. But now we don't have B anymore. So how did this stuff become? It's H. Okay. It's H. Okay, we were basically multiplying by 2. Okay, okay. So H. There we go. Okay. So the idea is that they should yield the same result. Oh no, it does not. Not at all. Uh-oh. Wait. Where's my stuff? That did not work. It seems. Let's see. What did we change? We pretty much only changed the heat sphere. So this should be the same exact thing. So it's on us. We didn't change anything else, did we? Literally nothing else changed. So what are we doing wrong? Is this the correct implementation of magnitude squared? Yeah, it's the dot product of v plus the dot. Wait, It's the dot product between v and v, right? And then you sum it. H not minus H in the equation. Oh, thank you. Thank you. Thank you. Thank you. Thank you. Yeah. Okay, we're back. Back in business. Thank you very much. Yep, works. Okay, an abstraction for hitable objects. Now, how about more than one sphere? Well, it's tempting to have an array of spheres. A very clean solution, like clean, is to make an abstract class for anything that array might hit and make both a sphere and a list of spheres just something that can be hit. What that class should be called is something of a quandary. Calling it an object would be good, if not for object-oriented programming. Surface is often used. Well, we don't have objects. We don't give a fuck about objects. So we could very well call our stuff object in the physical sense of the term. And you know what? I think I'm going to do that. With the weakness being maybe that we would want volumes, fog. Maybe object. Yeah. Hitable emphasizes the member function that unites them. I don't love any of these, but we'll go with hitable. Well, we're going with object. Why not call it physical object at this point? I just call it physical object. If object alone is not enough to specify what kind of object we're talking about, physical object should solve it, I think. I think it's better than hitable. In any case, this hitable abstract class, Jesus, will have a hit function that takes in array. Most ray tracers have found it convenient to add a valid interval for hits, tmin to tmax, so the hit only counts if t is between tmin and tmax. For the initial raise, this is positive t, but as we will see, it can simplify our code to have an interval tmin to tmax. One design question is whether to do things like compute the normal if we hit something. Wait, what? One design question is whether to do things like compute the normal if we hit something. We might end up hitting something closer as we do our search, and we will only need the normal of the closest thing. I will go with the simple solution and compute a bundle of stuff. I will store this instruction. I have to be honest, I do not understand what this sentence is supposed to communicate. Here's the abstract class. One design question is whether to do things like compute the normal if we hit something. So you hit something, and the question is, do we compute the normal of that hit or not? Oh, I think I guess. So, okay, I think I'm starting to understand. He's talking about abstractions, and his question is, should the hit abstract method interface thingy concern itself also with computing the normal of that particular hit, or should we leave that for that responsibility for something else? Well, if I know anything about clean code, is that one class should have one responsibility and only one. So if your thing is hit and it's also completely normal, then you're not following the something separation of thingies principle. Thus, you're doing bad OOP, and you're gonna go to OOP hell, where everything is functional programming. Single responsibility principle. Thank you. Separation of concerns. Wow. Okay. So he doesn't know whether to compute the normal in here or not. What did he end up doing then? I will go with the simple solution and compute a bundle of stuff I will store in some structure. Okay, so a hit has the point where we hit, the normal of the point where we hit, and I guess, whatever normal of whatever surface. I guess it depends on the concrete shape that we're hitting. And then there's also double T. And T is our... I actually wouldn't know how to describe T at this point. What is T? I'm not sure. Yeah, I'm not sure how to describe T. The other two, I get. It's time, isn't it? Yeah, I guess. Yeah, it's distance from an eye. Yeah, that makes sense. The length of the ray. Yeah. That makes total sense. Yeah, it's distance from the eye. Yeah. Okay, cool. Okay, so Hitable. Yeah, the fuck is this shit? What do I do with this? Now, what do I do with this? How do we solve this in Zig? How do we do it without object-oriented programming? Oh no, we're never gonna be able to solve this. Let's see how they do a sphere then. They give it the sphere a hit method. So I think we have two options here in Zig. One is our list of objects going to be objects in the physical term of the word? Okay, so in Zig, when I'm going to say objects, we literally mean here's my mouse object. Okay, no abstract objects in here, only physical objects. So the question is my list of objects going to be comp time known, or is it going to be dynamic? Your shapes will be a well-known list. Then, if that is the case, we can get away with just comp time duck typing. We make a bunch of different structs. They share absolutely nothing other than the fact that they all happen to have a hit function that you can use on them that has the same signature. Actually, it doesn't even have to have the same signature necessarily, but obviously it makes sense for it to have. Why not a tagged union? Yeah, we could also do a tagged union. Sure, but here's my point. So, Lee Cannon, you are totally right. So I guess we have three levels of abstraction, right? Wait a second. Wait 1 second. Wait 1 second. I have a drawing tablet. I almost forgot that I had it. I guess now it's time to whip it out. That doesn't sound good, but I said it. Lorian. Yo, my calligraphy is still gonna be crap, but we have this. Okay, so let's see. Why not attack union? Dynamics dispatch, dispatch in and dispatch. Yeah, as a restriction would call them. Yeah. So this is the idea exactly. So the idea is you have basically 3 levels of dynamicism. And by the way, this is in my opinion something one of the most genuinely interesting about software development. I think that this is one of the things that as a software engineer, one of the big questions that you have to answer every time you make something. And the fact that we're bad at answering this question really speaks poorly for our industry. So think about it. Every time you make a piece of software, you have to choose the level of dynamicism, like the dynamicism level. And so in our case, we have the tools at our disposal because we can say like level 1 is duck typing. So duck typing means we have no real dynamicism. We use comp time reflection to basically inline the call to the correct function based on. We're basically using metaprogramming. We're using metaprogramming to just make it more easier for us, more syntax sugary, to have a completely static set of shapes that we want to apply operations on. Then we have enums. Well, no, not enums. Sorry, that's more like a Rust word. It's tagged unions. Oops. Let me try again. Yeah. Oops. How do you hold this thing? Yeah, tagged unions. And this one is more dynamicism because now you dispatch to a runtime function call, but among a closed set of possible destination functions, the ones that are in the tagged union. And this is actually often enough, and you don't need any more than that. And I think that this methodology, maybe not today, but I suspect that this approach could potentially give you optimizations that you wouldn't be able to get with the fully open-ended Vtable approach. I'm not sure though, but I think it might be possible. So 3 is Vtable. Oh, G? Why there's a G there? Yeah, Vtable. And I think it's interesting because you have these 3 clear different levels, right? And each come with more flexibility, but also with different kinds of performance trade-offs. And I think, this is just one example where this happens. But if you think about it, every time you write a piece of software, you have to choose the level of dynamicism of it. You make a tiny program that computes the sum of 2 numbers. You can hard code the numbers, and then the program always prints the same value. You can hard code one of the 2 numbers and leave the second one as an input that the user can give. That's more dynamic. You can have both numbers be given by the user. You can have the operation be provided by the user. Maybe it's not a sum, it's a multiplication, it's a division. Then, you can let the user come up with not just a single operation, but multiple operations. And all of these choices have implications. And the same is true for pretty much everything that we make. And it's kind of weird if you think about it, that we have programming languages that take this gradient completely away from us, and they make a choice for us. And what happens is that they tend to give us the highest possible amount of dynamicism, even though we might not need it. And one thing that I realized while working on a tiny set of programming languages myself is that if you're not careful, so for my static site generator, there's a templating language and that has a tiny scripting language. And, even though it's tiny and extremely self-contained, it is a tiny programming language. And one thing that I realized is that dynamicism in this type of programming language is what you get by default if you're not careful. If you're not careful, your functions will be able to accept any parameter, return any parameter, have a lot of dynamicism to them. But all of this dynamicism costs you, because then it becomes harder to do, for example, static analysis, because if a function can accept any type of argument, like maybe you even define it as that, where maybe you make a function that can accept maybe a string, maybe a number, maybe something else, and it behaves differently based on what you pass in, then all of this stuff makes it more complicated to do, as I said, static analysis, provide tooling for it. But one thing that I noticed is that you don't get to dynamicism by being good at designing programming languages. You get to dynamicism by being bad. It took me a moment to like realize that that's where I was going and like hit the brakes and stop. So in any case, I thought this was something interesting. Let's see, you want an array of hitables, so you can't really use duck typing alone unless you have each array for each object type. No, you can. So here's how it works, Canon. The way you can make it work is that you can do something like this in your well, I'm going to do it in the main function, I guess. But in your main function, you can do this. You can do const shapes, objects. And then you do this, and you do, cube 1, cube 2, pyramid, sphere, and then you semicolon. And this can be different types. And then what you do is you do inline for. And then you do obj.hit. So you can totally do this. The way it works is that this is not really an array. This is a tuple. This is a comtime known struct that you can iterate on, basically. Yep. Let's see. Fourth, separate array for each type of object is best approach here. It would be even faster than a union. That's a good point. So you're saying we do want some dynamicism, but also we know that there's a fixed number of types of objects. And so you just make a list for each type. That's also fair. Yeah. But I'm going to go with the full comp time stuff, I think. But this is a very good point. We can go with the full comp time stuff. And then if we need something more, we can then switch to multiple arrays. Yeah. But I think that so far, like just one array like this is going to be fine. I guess this approach is in case you have many, many functions. Like if you have a lot of functions, then maybe it might be worth. I will definitely, at some point, it will definitely be worth having multiple arrays so that you can use for instead of inline for. Okay, yeah, it's comp time dispatch, but think about it. Inline for, you should think of inline for as literally copy pasting the body multiple times. When you have a normal for, you can have actual go to, etc. Well, I shouldn't say go to. I should say, you can have actual looping, actual jumps in the code instead of having the body be copy pasted n times. Branch predictor won't be able to predict which type of object you're trying to intersect with. I think I'm not communicating properly than what we're talking about. I'm talking about this approach, but with the difference that you do, like, first you do all spheres, then you do all cubes, then you do all pyramids, and that reduces code bloat. If you have a ton of these things, that reduces code bloat compared to what I showed earlier when you do inline for. Not doing inline for will save you some code bloat. Okay. Let's go back to Raytracing in a weekend. So what are we doing here? Okay, so this is the implementation of the sphere, huh? Okay, let's do this. Let's make new write source / objects.zig. Yeah, okay, so we're gonna put them here. So const sphere, the struct has a radius probably, I'm guessing. Does it have a position? I guess it has maybe a position. So let's get also a vector in here. You know what? Let's get all of vec and then we get vector from it. Okay, so as a center, which is going to be a back 3. By the way, I'm not looking at the code, I'm guessing, but this seems not too complicated. So function, nothing prevents you from using inline for in this approach. Sorry, I'm not looking at the code, but if your code is this one, my point is that at some point you don't want to use inline for. At some point, if you have 100,000 shapes, as an extreme example, you do not want to use inline for. It produces code bloat. You want a normal for. So my point is that not using inline for and still being able to do static dispatch is what you want to achieve when you have a ton of shapes. I'm sorry, when you have a ton of objects. So sphere, hit, I don't remember the signature of hit, and it returns a hit, right? So we have to define what a hit is. So a hit is, we said, the hit position, which is a vec3, then the normal, which is a vec3, and then the T, which is an F64. And that's a hit. Okay, so hit takes in a array, tmin, tmax. Okay. I guess I'm going to copy this. Some of this is what we had earlier. Some of it's new. Well, okay, you know what? Wait. Let me get the signature right first. Const override. No, I'm not talking about different types of objects. I'm talking about you still have only circles, squares, pyramids, let's say, but then you have a ton of those. But then you have many of those. Just a lot of objects is obviously won't produce code bloat. If you have one array with a mixed set of elements, it will. You want to inline for over each object? I think we're talking past each other. Give me a second, I'll show you. Let me get there. So S is sphere, R is ray, tmin is an F64, ray tmax is an F64, hit record and returns a bool. So yeah, no, exactly. So what I'm saying specifically is this: you can do the lower one, and to do the lower one, you have to do inline for. But then if you have a ton of these, like if this tuple here is gigantic, you don't want to do it anymore because that will produce a ton of code bloat. So then to scale up to a ton of things, you want to switch from this to this above, which I believe is what Andrew was suggesting originally. And yeah, this above is pretty good because it allows you to do 4. You do 4 on box, then you do on all boxes, then you do 4 on all circles, and that reduces code bloat significantly compared to doing inline for on a gigantic list like this one at the bottom. So this is returning Boolean and then modifying a value. Do we want this? I'm not sure we want this. Why? What is wrong with just an optional hit? Is it a problem for us to do an optional hit? It doesn't seem to be a problem for me. Let's do the optional hit for us. Do we need this? Yeah, this is fine. So okay, so we need to do the math, which is what we were doing here. But then it's doing something more because it's also computing the normal. So we do this, we do the discriminant. If the discriminant is below 0, we return null. So early return. Then find the nearest root that lies in the acceptable range. Okay, so this is different than before. So let's do this. Let's see. Root is h minus sqrtd. Where is that? Oh, I failed to copy this. Okay. So divided by a, if root is lower than or tmax is blah, blah, blah. We're making root a var. Return false. Let's see, what if rec is changed regardless whether the heat returns true or false? Oh shit. But no, that's not what's happening. We only modified down here. I don't know why they use this style. I guess it's because nullables are probably considered an advanced C++ feature. So they decided to use this approach because they didn't want to use optionals. No, but I think that depending on the usage of this API, it could have been a thing, but apparently it's not. Okay. So here we do return dot t equals root dot p equals r dot at rec dot t and dot n equals rec dot p minus center divided by radius. I haven't checked if these operations make sense for us or not yet, so just translating. Okay, let's like type check, or you know what, we let Zig type check this stuff for us. So here's the problem: center origin, and there is no center for us. Yeah, we're getting center. We're not getting center here. What's center? What? Center is our center, and radius is our radius, right? So this is as.center, and this is yeah, you know what? There's too much stuff called R. So radius. Let's call it radius. Now this is rec because rec was called what? What's rec? Oh, rec is the return value. Okay. There we go. Okay. So this should be our sphere, I guess. Note that here we use C++ standard function std fmax. What? Where is fmax? Sphere. Public sphere is given a center and a radius. Is what am I looking at? Is this a constructor? And it's constructor initialize list. So this is setting these fields. And radius is being, if radius is negative, we give it radius 0. What's going on here? Which returns a maximum of 2 floating point arguments. Similarly, we will later use fmean, which returns the minimum of the 2 floating point arguments. Why are we creating negative spheres? What's going on? Why are we creating spheres with a negative radius? Actually, that's my question. What's going on? It's defensive programming. I see, but if it is defensive programming, it's kind of stupid. Like Andrew is right. Like you should assert. You shouldn't. They don't know what an assert is. That's the problem. They don't even know what a freaking assert is. Okay. God damn it. You know what? Let's even take it out of std debug. Let's just assert right away. But it's like, it's the dumbest possible kind of defensive programming. Or maybe not. Yeah, I think it is the dumbest. Like, okay, either you're not doing any defensive programming, so you're just letting arguments potentially violate invariants. Yeah, that's fine. Should we allow a radius 0 sphere? Maybe. Or you know what? Maybe they're going to use some kind of random number generator later on, and they just don't want to bother with the fact that sometimes it gives you negative numbers, and so they don't want to worry about having to make them absolute. But then again, why clamp them in 0? Then you wouldn't want. Then I think you would want to just do the up. Whatever. Okay. Whatever. Okay. Sure. There won't be negative radius. Then why is there? Then why is that function called there? God damn it. The second design decision for normals is whether they should always point out. At present, the normal found will always be in the direction of the center to the intersection point. The normal points out. If the ray intersects the sphere from the outside, the normal points against the ray. If the ray intersects the sphere from the inside, wait, how does it do that? To intersect the sphere from the inside, it would have to first intersect it from the outside. I'm guessing this has to do with the fact that we're picking these at not exactly at random, but like we're not really too discerning with how we pick our t, and so sometimes we could pick the solution that makes us intersect towards the outside. The sphere can be so large that it's around the eye. I guess technically that would also be an option. But no, because, I mean, I guess yes, but also it would be I think it would be a degenerate case, because you would, like the sphere, it's not, the way we consider hits, I believe, the sphere is not like empty. I might be wrong. No, you know what? I might be wrong, because I think we only consider solutions to the equation, so we only do surface. Foreshadowing, glass spheres. Yeah, that makes sense. Okay, if the ray intersects the sphere from the outside, the normal points against the ray. If the ray intersects the sphere from the inside, the normal, which always points out. points with the ray. Alternatively, we can have the normal always point against the ray. If the ray is outside the sphere, the normal will point outward, but if the ray is inside the sphere, the normal will point inward. Possible directions for sphere surface normal geometry. Outside surface, inside surface, this is the ray. Which normal do we pick? Yeah, I don't know. But in any case, if you always compute the normal as point and then center of the object, then you can always make it point outwards, I guess. I guess there are reasons instead to try to point it the same direction that the ray is pointing at, maybe. Right? That would be the only reason why you would even worry about this, because if that wasn't interesting, like if you were fine with a normal always pointing outside, then you kind of get that for free just by computing that from the center, I think. In any case, we'll see. We need to choose one of these possibilities because we will eventually want to determine which side of the surface that the ray is coming from. This is important for objects that are rendered differently on each side, like the text on a two-sided sheet of paper, or for objects that have an inside and an outside, like glass balls. Yo, that foreshadowing, man, on point. Not too far into the future, not too close, just the right distance. Good job. If we decide to have the normals always point out, then we will need to determine which side the ray is on when we color it. We can figure this out by comparing the ray with the normal. Okay, so this means with the normal, as in the normal always pointing out. I'm guessing if the ray and the normal face the same direction, the ray is inside the object, yes. If the ray and the normal face opposite directions, then the ray is outside the object, yes. This can be determined by taking the dot product of the two vectors, where if their dot is positive, the ray is inside the sphere. Because they're either both positive or they're both negative. While if they point in different directions, then one of the two will be positive, the other one will be negative, and so their dot product gives a negative solution. Okay. If we decide to have the normals always point against the ray, we won't be able to use the dot product to determine which side of the surface the ray is on. But why are we... I'm not sure I understand this reasoning, because in my mind, we're computing normals. Wait, how are we computing normals up until now? Maybe I should have paid more attention to the math that we're doing, because that maybe would explain it. Where's n? I mean, it's point minus center divided by radius, so it's not even a function of the ray. So why are we wondering about that? Well, I mean, no, it is. I mean, sorry, the ray is in the picture, I guess. But I mean, that only gives us a point. So I don't get it. Like the directionality, I don't get it. In any case, oh, so wait a second. P at. That gives us a vec3. Center is a vec3, so this gives us a vec3, and then we're dividing it by radius, which, last I heard, is not a vec3. So, yeah, right, because we need to splat this bad boy. Okay. Instead, we would need to store that information. Okay, but fair, but so far, I'm not sold at all on why we would do it that way. So I'm not invested in the resolution so far, because to me, it seems clear cut that we want the other one. Now watch me get completely destroyed. P is the intersection point. So P minus center is vector outside the sphere. Yeah, that's my point. Like, my point is that since we compute it this way, how will we even compute it the other way? Like, I don't get it. Anyway, we can set things up so that normals always point outwards from the surface. Isn't this already happening? God damn it. Or always point against the incident ray. This decision is determined by whether you want to determine the side of the surface at the time of the geometry intersection or at the time of coloring. in this book, we have more material types than we have geometry types. So we'll go for less work and put the termination at geometry time. This is simply a matter of preference, and you will see both implementations in the literature. Okay. We add the front face boolean to the hit record class. We'll also add a function to solve this calculation for us, set face normal. For convenience, we will assume that the vector passed to the new set face normal function is of unit length. We could always normalize the parameter explicitly, but it's more efficient if the geometry code does this, and it's usually easier when you know more about the specific geometry. By the way, where's the assert? Dude, you could assert this. Like, this is a perfect case where you can ask to have for correctness. You're saying, I'm assuming there's this implicit invariant. Please put an assert. Make it an assert. God damn it. Okay, let's go do this, and let's do it the right way. So we're saying that hit also has what's it called? Front face. It's not that easily to correctly assert that. I mean, you can assert that it's like within a given delta, right? Let's try to make this work. Let's see how it works. So front face, bool, and then what did they do? Set face normal. Front face is the dot, and then based on front face, normal gets negated. Wait, now I'm confused. Now we're flipping the normal. Why are we flipping the normal? Isn't the normal always pointing out? So I guess this makes the normal point in the same direction as the ray? Yeah, I get that. So we're not happy with that anymore. So maybe I missed a piece reading this. So we're not happy with having the normal always point out. We want to have the normal we want to have the normal also. We want to be able to have the normal also follow the ray. I guess that's the point. I feel like this explanation above spent too much time arguing for a way of computing this that we didn't go for at all. So I don't find this case compelling. I get the point that you might want to know about this because that's what you might find in literature. Fine. But the whole like argument, should we decide to do this? Like this what? Like what we're doing so far seems perfectly fine. In any case, okay, so now we want to be able also to flip the normal. Fine, let's flip the normal. Set face normal. Okay, I'm gonna copy this so we can have it for reference. Okay, so pub function set face normal. We need to mutate hit, and we have outward normal. Isn't this n? I guess no, because we were modifying n. So like if you call this once, then n is going to be flipped. But imagine a plane. Okay, I'm flying in the sky. I'm in a Boeing 747. Hits normal. I'm joking. Okay, imagine a flat plane or like an horizontal one. Its normal will show, for example, up. So we hit the plane and the normal points up. But if you look from the bottom towards the plane, you want to have the normal to be down. Understood. Okay. So unit feels properly. What do you not like about P, N, and T? P, N, T. No, I think the song was slightly different than this. Outward, normal, like 3. Set face normal, void. Okay. Okay. Note the parameter outward normal is assumed to have unit length. Okay, so here's how we do it. If const built-in equals at import built-in. By the way, I think that built-in, this is not going to happen too soon probably, but I think that built-in is going to be renamed to config, which I think it's a much better name because it's like your build configuration. So don't take what I'm saying for granted, but I think it might happen. It's just that probably requires messing with a bunch of stuff that's hard coded. That's probably kind of brittle right now. So if built-in dot I don't remember. Let's go to definition. Target OS single threaded DBI CPU output mode. Where is it? Mode built-in dot mode is dot debug. If we are in debug, then we spend some extra effort computing stuff. So I could put a normal assert. The point is I want to make sure that the assert just runs in debug mode. So also the extra like calculations. So we're basically what we want to assert is that this outward normal is already of unit length. So we do LVM should be able to optimize it. Yeah. Andrew, have you seen the thread on Zigit? There's like some cases where it's kind of obvious. No. I don't want runtime safety. I don't want to run this in release safe. This is, by the way, an interesting point. And by the way, this is like up to taste in a sense. There is a difference between wanting to have something happen only in debug, happen in runtime safety mode, so like release safe, and not happen at all in release fast. In the case of Zine, for example, I have some extra turbo redundant safety checks that I don't even want to have in our release safe mode. And I personally believe that in the case of a ray tracer that for some reason you want in release safe, you want to build in release safe, which honestly I would never build in release safe. It's to me it's either debug or release fast, I guess. Although I guess maybe you can do that because you're testing and you still want it to be not too slow while testing it, I guess. But in any case, there are some stuff that you could genuinely want to only relegate to debug. I do that on purpose sometimes. So you can totally do SDD debug runtime safety. That's fine. That's precisely not what I want to do right now. So outward normal. So we want to compute basically the normalized version. How do we do that? I don't remember. What's the name of this function? Unit, right? Okay, so const unit equals vec dot unit of outward normal. And then we need to assert that the two are pretty much the same. So how do we make this happen? I guess we can subtract them and assert that it's close enough to 0 with a delta that we pick. That sounds right, no? I mean, at the end of the day, even if it's not normalized and it's close enough, who can even tell the difference? So we say assert, const delta is unit minus outward normal. And then we say How do we do this? Contains a bunch of functions to compare floats, but I don't know which would be correct here. Nice. We can check for that. Can you compute magnitude 2 and compare absolute value to 1? You're right. We can do that. Magnitude square. That seems a good idea. Because the magnitude needs to be 1, right? That's the definition of a unit vector. That seems a good idea. So how do we compare it? Let's see, std.math. Let's see what's in math. Approximate equals absolute. Hey, that's what we want. Performs an approximate comparison of two floating point values, x and y, returns true if the absolute difference between them is less or equal than the specified tolerance. Boom, immediately found it. It's kind of weird place to put that check assert comment. Initializing the hit should check for that, not a random function for that hit. But the point is that we're passing here. But here we are passing an outward normal. Are you saying that this function is not really meant to be called from the outside and it's only meant to basically be used down here? If that's the case, yeah, this whole thing seems silly. This smells. If that is the case, then this smells of object-oriented brain rot. To be honest. In any case, let's approx eq abs. We can move it. Approx eq abs. Type f64 x1 y outward normal. I think you might be right though that this is I just saw that the code that the book wanted me to do this and it wasn't immediate. It's not yet immediately clear to me what is the expected use case of this function, like where you're supposed to put it. And maybe it's obvious if you know exactly what you're doing. I'm not quite there yet, right? So it wasn't immediately obvious to me that this is something that we're just gonna call in here. If that is the case, then yeah, we're gonna take this out. We're gonna put it down here, and like inline these things. And yeah, are we gonna call set face normal at random on a hit? Maybe, maybe not. If we are, then fine. If we aren't, then if we are, then fine, because we're gonna pass this argument here, and we need to validate that this argument is good for us. But if that's not the case, if we're always passing what we're computing here, then yeah, fuck that. Approximate equal absolute, and then the tolerance. I don't know what is a good tolerance. I think cd.math has a good tolerance for us, doesn't it? Log none. Let's see, float exponent beats mantissa beats fraction beats exponent true mean max. Eps, is that the epsilon? Returns the machine epsilon of floating point of type t. There we go. That's our delta. Float eps. I think. I don't know. We're making this go through a square operation. Whatever. Oh yeah, you're right. 1 and 1. Thank you. Okay. So we're checking for this, and then we're doing front face, as in h.front face is vec dot r dot direction. Oh wait, this also takes in array. Oh. Okay. And then h dot normal equals if front face, then outward normal. You know, we can even do this. We can do int from bool front. No, okay, it gets too clever. Never mind. Let's not do that. Front face, then outward normal, else minus outward normal. And then we delete this. Built in. There we go. Okay. So where do we use this? And then we add the surface side determination to the class. Yeah, it just calls this fucking function. Missing assert. Oh, yeah, you're right. We need to assert this. So why are we even doing this? And then instead of doing this, oh, it's showing us the lines that changed, but copy sign. Yeah, I think this is fine. Okay, so copy sign. I would hope that LLVM understands this pattern and knows how to optimize it. I mean, it's so simple. Please, LLVM son, get this right. Okay, so we have P and N here. So we have T and P. So we're changing how we do N. Now we are doing this. We're not saving it inside. We're saving it. What is the point? Yeah, make it an init function. Yeah, I think you're right. That's a good point. This whole, I mean, I understand that this is not like a software engineering book that's teaching you how to do software engineering well, but that's what we saw just now. It's definitely a choice. That's for sure. That is for sure. That is indeed for sure. And then we do this, I guess. Okay, let's see how if I can get this right and not fuck it up. So this is gonna be our normal. Then there's gonna be the front face. Then we have to set T and P. T is root. So I guess we can call it T in this case, and it's gonna be a F64. But you know what? No, let's call it root. Actually, no. Why is it even called root in here? Find the nearest root that lies in the acceptable range. Oh, it's called root because it's the root of the, like, the solution to the equation. God damn it. Okay, so no. We call it T. So this can go here now. And this is T. This goes away. Okay, that seems right. I hope I didn't mess it up too much. We have our assert. We have our init. Does pretty much the same thing as before. With the only main difference that we flip outward normal based on the front face condition, which, oh no, we moved down here and now that is a problem. So we need to make this a, there we go. And this is a hit. And we don't take this in anymore. Okay, we're getting there, right? And then down here we do return dot init pass in root, ray, and oh shit, we lost the outward normal. We lost the outward normal, which is this. Okay, let's see. Rack.p. Oh shit, the outward normal needs us to compute stuff. It needs p. Right, sorry. I kind of messed this up. Const p equals this. So I guess we don't do this. You just give me t and ray, and we compute this inside. So outward normal is gonna be p minus center. We're gonna need a center, like 3, and a radius. F64. This goes here. Now heat only works. Heat dot. Wait. Now it dot what? Dot init. Oh, heat dot init only works for spheres, not all shapes. Oh, you're right. That is a good point indeed. Yeah. Good point. Okay, so this means that we need to take some stuff out. So const p equals this, p minus center radius. So we pass in the root, which is the t, the ray, and then we also pass in the collision point, of course, and the outward normal. That seems fine, right? So we take in p as a vec3. Here we do p. Okay, this should be it. Did we do it? Actually, no. T is root. And here center is s.center and s.radius. Okay. I think we should be it. We should be there now. Sorry. Thank you, by the way, for catching this. That's a good point. Init needs to not be tied to a sphere. And this list of arguments makes sense. You know what? Let's add some comments to them, just to not forget. What is it? Length of the ray. Yeah, it's distance at which the collision happens. Oh, you know what? Whatever. So far, we know what they are. Fine. Okay, let's continue. A list of hitable objects. We have a generic object called hitable that the ray can intersect with. We now add a class that stores a list of hitables. Yeah, no, we're not doing any of these. Goodbye. Here's my hitable list. Look at how it's going to be. I'm going to go in main. And in main, we don't have this anymore. We're going to figure out what to do with ray color, but here's how it's going to work for us. We can have in here something like this. Const objects equals, and then we put them in here. That's it. That's all the code we need. What's next? Shared pointer. So they said that they were only using basic C++ stuff, almost FC, and now we're getting a lecture on shared pointers. Yeah, I don't give a fuck about this. Let's skip this stuff. SharePTR is included in the memory header. Yeah, good to know. Goodbye. Common constants and utility functions. We need some math constants that we conveniently define in their own header file. For now, we only need infinity. We have that. But we will also throw our own definition of pi in here. We have that. which we will need later. We also throw common useful contents for future utility in here. This new header, rtweekend.h, will be our general main header file. Yeah, like fuck that. We have infinity, we have pi, degrees to radians. I think we have in SED math this stuff, so we should be fine. And yeah, the rest of the stuff, that's fine. Oh, and now we're going down on a adventure, refactoring all the header stuff. Okay, sure. There we go. Now ray color is different. Okay, so these are changes that we want to have. You need to copy hit function to hit all objects. I don't understand what you mean for now. So we need to fix ray color because we don't have its sphere anymore. So how does it work? If world.hit. Okay, wait a second. What happened here? So he made a hittable list, I guess. Oh, and it has hit. Oh, I see. So, okay, now I get it. So this is what I need to implement, like hit everything. Hit everything. How does it work? Ray, tmin, tmax. Same signature. But then it calls hit for everything in there. And then it finds the closest. It keeps track of the closest. And then returns if something was hit. And so it throws away all the hit objects. No, it doesn't, because hit record. Wait a second. What is going on here? Oh, yeah. Or hit record is the type, right? That they have types on the left. So okay, it saves inside of temp rec. But then there's rec in here. And then we keep assigning to rec temp rec. Okay. Sounds good. So where do we put this? This is like hit everything. I think it can be a function inside objects. So I'm going to copy this so that we don't need to wonder how it's implemented. I think I'm going to put this in objects.zig, I guess. Or should we put it in main? I think maybe this belongs to main. Because it happens to have the same signature. But it does, like this, by the way, it's another interesting thing about object-oriented brain rot. It has the same signature, but also because we're making a hittable list also hittable, but it's doing something completely different inside. Why do you feel the need to homogenize this stuff? What even is the point other than creating confusion? Like, I get that you might have a practical reason to have your individual objects, like your individual shapes, all be hittable. Fine. Why is a list of them also necessarily... Why does it have to be hittable in on itself? So let's not do this. Let's go back to main and let's implement this down here. Let's call it hit everything, I guess. Returns an optional hit. Sure. So we pass in, I guess, objects, we say then ray, then tmean, ray tmean, and that's it. Then in line 4, for each object, we call hit. And we pass down ray, ray tmean, ray tmax. Then we maybe obtain an H, maybe not. So there's hit anything, which I think it's interesting and useless, but in any case. Although, you know what? Maybe I'm wrong. We'll see. So we hit something. I guess we have to save this hit somewhere, right? So we need to have a hit in here. Okay. And this needs to be optional. Then we assign to it. Then we save closest so far. Oh, we keep changing. Okay, one argument. So bar closest so far equals ray tmax. Closest so far. So far equals hit.t. And then we return hit. And that's it. I believe this is pretty much it. Maybe we should import hit, you know, as a type from objects. Okay. Oh, but now we have a collision in the name. It says objects. You are overwriting the result hit on every object now. Yes, I believe I am. Let me think. That's also what's happening here. So we pass temporec every single time. We assign, we read from it, and then we unconditionally assign it to the outer thing. Oh, you're right. It's an optional. Yeah, that's a good point. I didn't do this. So if hit, that is a good point. What do they do? Oh, they do the assignment unconditionally. Even no. Oh, right. Only if it succeeds, they do this stuff. Oh, thank you. Yeah. Which I guess we can do this. There we go. Okay. Some new C++ features. No, please, dude. I have enough of C++ features. Wait. I mean, we're missing a world. or else continue. You're right. We don't want to assign. Oh, good point. Good catch. Yeah, we don't want to assign it unconditionally. Yeah. Which then, to be honest, we can do this then. We can assert that hit is accessible because otherwise we would have continued. Yeah. Okay. So anything else like about the world? Is there anything bunch of useless OP stuff? Look at how much garbage, man. Okay. The Hitable list class code uses some C++ features that may trip you up if you're not normally a C++ programmer. Vector, share pointer, make sure. Okay, please save me from this stuff. Common constant. Wait, did we do this already? Okay. You need to pass. You still override hit unconditionally. No. Wait, or maybe this was true earlier, but with or else continue, it does not happen. So with this construct, what's happening is that we take this value, and if we can unwrap it, if it's not null, then we assign it. If it's null, then we continue. So we don't do the assignment. Yeah. And I am passing closes so far, so we're good. Okay, perfect. So we need to do this, right? Raycolor if world.hit return 0.5. And then here we're making the world. And so when we call Raycolor, we give it the world. Okay. So let's make the world first. Call it world. Fine. Make shared sphere. What? Objects. Oh, you know what? Let's also get those. What is going on? I got into Colimac for some reason. And so what do we do? 0, 0, minus 1, 0.5, minus 100.5, minus 1, 100. Okay. And then when we call Raycolor, we pass in the world. So Raycolor takes in the world. Any type for now. And this is where we do the last modification. Let's see what that looks like in Zig. So, well, this looks already good. If world, not world or hit, but hit everything. If hit everything, world are 0, infinity. This is std.math. I think it's just inf. Oh, inf of f64. And then rec we don't do. Hit return hit dot normal plus there we go. Then the if so this is not done then, and then uniter a okay. Okay, so let's see. What do we get? Mixed scalar and vector operands. Vector and F64, right? Objects. Line 97. Wait, what? Main does line 97, sorry. Objects line 60. We need to splat this guy. Then what's the next problem? Content control flow outside of runtime block. Oh, interesting. Let's see. So this is on inline 4. So we are getting punished a little bit by our use of CompTime metaprogramming. Yeah, you can't do so. You can't continue. You can't do continue in an inline 4 if the condition that causes you to do continue or not is not also CompTime. So that is indeed annoying, and I guess we need to change this basically. We need to switch it back to what it was before. So if h, then we do this stuff. Remove Raytracing and Tmax from params. What? Why? It should be hit anything. Why remove T-Raymin, Raytracing, Raytramax from params? Why? We have them here. We use Tmin here. We use Tmax here. I guess you're saying because they were only passed because it was a virtual function. Oh, you're right. Jesus, that is so dumb, isn't it? Because you're saying that this always starts from std.math.inf f64, and this always starts from and this is always 0. That is yet another reason why it's kind of weird to try and make that be a hit, huh? Okay, so hit everything, go to references. Here we're using it, so we don't need to pass these constants, which is fair. Okay, let's see what else is there. Extracted type F64 found a function. Oh, wait, float EPS is a function. Oh, that makes sense. You need to pass the type of float. That's fine. That is fair. Let's see, mixed scalar and vector operands. Vector and, right. Okay, main 79. This is actually vec.1. Mixed scalar. Oh. Splat. Yo, we got a runtime. We triggered the surgeon. We triggered the assertion. Ooh. So let's see what happened. Let's see if we actually ask float apps at. What's float apps at? Returns the local epsilon of floating point time t. Maybe epsilon is too small. Yeah, that could be it. But wait, why at? No, we still hit. Yeah. But we still hit, and we're supposed to be near 1. Let's make this 2. I don't know. Bigger epsilon. Let's see what this epsilon is. What is the epsilon, man? I guess we can play into the epsilon once. Oh, but yeah, well, we're gonna print it a bunch of times, so I guess that's fine. So 1, 2, 3. 1, 2. Oh, this is 4. Here's what we can do. Let's do something like this, 0.001. Is this what we're supposed to see? I don't know. Let's see. Well, it is. Let's see, this yields a picture that is really just a visualization of where the spheres are located. Oh, right, because the bottom one is a giant sphere down below, right? This is, let's see, are located along with their surface normal. This is often a great way to view any flaws or specific characteristics of a geometric model, resulting render of normal colored sphere with ground. Let's go. We got our ground. An interval class. No, bro. Enough with these fucking classes, man. Please. Before we continue, we'll implement an interval class to manage real valued intervals with a minimum and a maximum. We'll end up using this class quite often as we proceed. Let's see. An interval class to manage real valued intervals with a minimum and a maximum. So I think this is a good place where to stop. By the way, for people who have done this already, how far along are we? Are we halfway done? What? No, it's almost 11 p.m., man. I've been streaming for almost 9 hours. It's been fun, but I think this might be not a bad place to stop. We reached another checkpoint. We succeeded at everything. There's more object-oriented programming insanity. Raytracing is a never-ending rabbit hole. Okay, yeah, no, I get it. I know that there's also the third book that is about spending your entire life trying to understand ray tracing, but so far in this book, I mean, I see that we are like 1/3 maybe of the way. No, we're a bit above 1/3 with what? Yeah, more or less 1/3 of the way. Yeah, I can push to GitHub. Yeah, of course. I would say this is not bad as a starting point. We've been streaming for, okay, so this specific thing we've been doing for 4 hours and a half. So I would say this is a good place where to stop for now. So git status, cd source. I think we have a math file they want to remove. Everything else should be fine. Yeah. Git ignore. I'm gonna add emg.ppm. Actually, probably, you know what? Anything.ppm we might want to ignore. That's not a good idea. More or less halfway through. Okay, that seems good then. I think it's a reasonable point where to stop. By the way, I'm gonna do the second half tomorrow. It's ray tracing in a weekend. We're doing it in a weekend, like this weekend. So today the goal was to do, I guess, more or less half, and then do more or less half tomorrow. So day one, is there a way to say up I guess 6.8? Day one up to chapter 6.8 excluded. And we can push. There we go. So thank you all. I hope you had fun. I'm gonna stop the recording. So I don't know, say goodbye to YouTube, and yeah, we're gonna continue tomorrow with the second half. And yeah, that's it pretty much. So I'm gonna stop the recording now. Bye, YouTube. Okay, so let's see. Is there anybody who we should raid? People doing Zig. Oh, there's Pharaoh. Pharaoh is definitely doing Zig, that's for sure. Yeah, I'm reading Sphero. So go enjoy some Spherophoria so you can see some people being actually productive and do cool shit. Can we now trash talk of these plebs on YouTube, right? Yeah. You're still watching, by the way. We're just, by the way, I've also been live streaming to YouTube at the same time. So I just made a separate recording that I'm going to upload as a video, not as a live stream. Spherophoria, let's go. Go have fun. Say hi to him for me. Bye bye, everybody.